Right. So we will start in the paucity of time. So good morning, everyone. Welcome to this 164th edition of the Zak World of Façades conference series. My name is Ahmed. I'm part of the organizing team here at Zak. This is our 6th New York City edition. Back to this fabulous city, fabulous venue once again. I'll quickly take a couple of minutes to introduce the event before we get into the program. Can we have the screen switched, please? So, we've been organizing the Zak World of Façades conference series since 2012. As I said, this is edition 164. We've done events in 42 countries around the globe now, spanned from New Zealand up until Canada. Every event is different. Every region, the way facades are designed, engineered, installed, completely different. In some regions, it's about carbon reduction, embodied carbon. Some regions, it's about going tall, complex geometries. Some regions, it's about cost. So no two events are same. We try to curate these events basis the local market, what are the trends of that respective city or that region or that country, and it gives us a chance to bring new trends from one region to another region. The events in New York and London are, I think, for us, the trendsetters. What happened in these cities generally seem to be taking precedence in other cities. So for us, these are our two flagship cities. And New York City has always been growing, has always been kind to us. Thank you all for taking your time out and coming today. I'd like to start by thanking our event partners without whom this event wouldn't have been possible. I'd like to start off by introducing our presenting partner, that's Rayner's Aluminium. Rayner's Aluminium is from Belgium. They are an aluminium door, window, curtain wall system company. They are our presenting partners for this event. Rayner's and all our associate partners have a tabletop display, which is in the exhibit area. So we've got the exhibit area open throughout the day. We've got a total of 62 sponsors this year, which is, again, a record for us, showcasing over 95 products. So there's a lot of new products, existing products on display. Please do visit them during the course of the day, during the networking breaks. Lunch, tea, coffee, breakfast is all being served in the exhibit area. We have our 61 associate partners. I don't want to get into explaining all of them. It's going to take a lot of time, but I'll quickly just mention all of them, starting with AGC Interpaint, Air Renaissance and Ital Mesh, Altair, Amico Architectural Systems, Arcon Glass, Axalta, Becker's, Vishaan Facade, Boston Valley Terracotta, Cosentino, Cove Tool, CRL, China Southern Glass, Custom Metal Crafters, Dassault Systems, Dow, EOT, Equitone, ES Group, Euromax, EXO, FacadesX, FG Glass, Glass Bell, Gridworks, Guardian Glass, Hemp Glass, Hydro, Hansen, Kingspan Light Plus Air, Curare, Laswit, Longboard, McGrory Glass, Northern Facades, North Glass, Onyx Solar, Optimum Steel Windows, Porcelanosa Facade, PPG, Press Glass, Qvent Architectural Systems, Rigidized Metal Corporation, Rockwool, Rotoblas, Saflex Venziva from Eastman, Saint-Gobain with their brands of GCP, Sage Glass and Vetrotech, Saint-Gobain Glass, Sedac, Shildan Group, Siderise, Spectrum Metal Finishing, Stowe, Techfire, Tenmat, TGP, Wanda Glass Eckelt, Vitro Architectural Glass, Walker Glass, WHTB Glass from China. And of course, just want to give a quick intro to our largest event in the series, which is London, which is a couple of weeks from now. This is our largest event in the series, close to 1,000 delegates. It's an event where we have the Gala Awards dinner with the Society of Facade Engineering at the end of the day. It's a black tie event. That's something which we are very keen to bring to North America also in the near future. So this is our event in London. And of course, our events in the Americas region. So we're going to new cities. We're going to new locations. We're going to Brazil for the first time. We're going back to Mexico. We had a fabulous event in Miami and Montreal last time around. We go back to Seattle. Boston's new for us. Atlanta's new for us. And of course, Chicago, Toronto, and then again New York City the next year. So these are our events for 2025 in the Americas region. And it's very unique that we operate across the globe. But the principal idea is getting people to network with each other and to ensure that new technologies, new ideas are brainstormed together. So today's program also reflects that. We've got a lot of new topics. We've got a lot of refreshed topics also. So I hope all of you will enjoy today's program. We've recorded today's event, so if you've missed any lectures and if you've got permission to share that recording with you, we will send you a YouTube link a week from now, which will have a feedback form and also the links of all the 3 sessions. After lunch, the hall is going to split into 3. So you see this air wall here. So this is going to become track A, this is going to be track B, and that's going to be track C. So the 3 screens are going to be 3 individual halls. The air walls will come out, track A, track B, and track C. So please pick which track you would like to sit. If the tracks are full, we're going to close the doors due to fire and capacity reasons. So it would be a little difficult to switch between the tracks. So please pick which track you'd like to sit. This is track B in the middle. To my left is track C, and that's track A at the end. I think that's it from me. I'd like to call upon today's event host and convener. It's Kimberly Garcia. She's the Senior Director, Design and Construction at Tishman Speyer. She's basically leading the envelope and the facades for JP Morgan's new corporate headquarters, which is 270 Park Avenue. I hope we can get to present that project next year, and we get permissions from the client to have that as a panel next year. She's a well-known figure in this industry, and she's going to be hosting today one of today's event. She's going to be hosting the plenary session, which is basically session 1, session 2, and session 4. For the individual tracks, we've got respective session chairs who are going to be taking it forward. So that's it from me. I'd like to call upon Kimberly on stage, and then she's going to be taking you through until the end of the day. Thank you so much.
Thanks, Ahmed. Appreciate the warm welcome and introduction. Good morning, everyone. It's an honor to welcome you all to this year's Zak World of Façades, and thank you for asking me to host. Today, we come together as innovators, architects, engineers, and thought leaders to explore the evolving world of facade design and technology. Our shared passion for creating sustainable, resilient, and intelligently built structures brings us here, and I'm thrilled to see such a dynamic group of professionals gathered here to exchange ideas. Hopefully, I'll keep you guys energized and awake through this process, but there's a lot of great speakers and talks today, so it should be very interesting. The facade is the first thing that people see when they approach a building. But it's much more than just an exterior. I think we all know that. It serves as a bridge between form and function, between artistry and engineering, and it shapes the environment that people experience on a daily basis from the inside out. In an era where sustainability is at the heart of every design decision, the facade plays a critical role in reducing energy consumption, enhancing comfort, repositioning the old into the new, and pushing the boundaries of what architecture can achieve. Today's conference will feature presentations, panel discussions, and case studies that will provide valuable insights into emerging materials, cutting-edge technologies, and the latest innovations shaping the future of building design today. We're here not only to discuss how facades are designed, but how they're transforming the world we experience and interact with our built environment. Whether you're a seasoned expert or new to the field, I encourage you to engage fully in today's sessions, share your experience, and challenge yourself to think differently. This conference is an opportunity for all of us to collaborate, to inspire each other, and to envision new possibilities for our cities and our communities. After all, we're here. It's a day. You're not in the office, right? So thank you all for being here, and let's get started. My first introduction is a good friend of mine, colleague, Vishaan Chakrabarti. He is going to be presenting the architecture of urbanity, walls that connect. And Vishaan, if you don't know him already, is an architect, an urbanist, and an academic known for his forward-thinking approach to city planning and urban design. He's the founder of Practice for Architecture and Urbanism, PAU, a firm dedicated to designing and advocating for more equitable, sustainable, and vibrant cities. Vishaan's work focuses on addressing social, environmental, and economic challenges within urban environments, emphasizing the importance of inclusive public spaces, transit-oriented development, and affordable housing. We're working together right now on a master plan. My client that I work for relies on him as our chief architect and advisor, so I'm really proud to be able to introduce him. Vishaan also has recently written a book, The Architecture of Urbanity, Designing for Nature, Culture, and Joy. So hopefully all of you can pick it up. I think it's out newly for Christmas, so a little pump there. And right, yes. He's held various influential roles, including academia, so professor at Columbia University, where he's taught architecture and urban planning. Vishaan, welcome.
Good morning, everyone. It is such a pleasure to be here. It's such a pleasure to be introduced by my dear friend, Kimberly. She's really one of the best in the business, so it's a great start to the morning. Kimberly mentioned I just wrote this book, and the book is an argument for why I think architecture is relevant to the big issues of our time. And by that, I mean not only climate change, which is something that you're probably all very familiar with in terms of what our field has to do with that, but even political division. I mean, we are weeks away from a very, very divided election in a very, very divided country, in a very, very divided world. And for young people, this is a pretty depressing state of affairs, how unaffordable things are, the role of technology, how divided we are, and of course, climate change is kind of the meta-narrative over all of that. So one of the things I try to do in the book is talk about the difference between community, which is a word we use a lot and think about largely as a positive thing, and it is, except sometimes it refers to how tribal we are, how much we cling to people who look like us, pray like us, vote like us, as opposed to really encountering difference and celebrating difference, encountering people in real space, not online. And I think this is something that our industry plays a big role in. So when I talk about urbanity, you might think of it as meaning big cities. I don't mean that at all. Big cities can be quite segregated, quite unurbane, if you ask me. Small villages could be quite diverse. And so the book starts with a kind of understanding of the fact that we are an urban species across antiquity, from the beginning of time, on every continent. We have gathered in collective places for much more than just market and bartering, but for spiritual and cultural reasons. And so this is the thing that I like to try to advance with our practice at POW. And so these are the kinds of things we do: social housing, cultural educational infrastructure, workspaces of the future like 270 Park, where I get to work with Kimberly and our good friend Norman Foster. It's an extraordinary project. And with all of it, there is this idea of co-design, of working with communities. And so in our work, we have a method. We basically do what many good architects do, I think, which is to look at place in terms of climate, context, local construction methods, the needs of the city and the community. And then through that, we try to forge the idea of connection. Connection through the scale of construction and the individual, through the community and the urban scale, and of course climate at the global scale. And so that becomes our motto as a firm: place needs connection. And a lot of our early work was about trying to create spaces of connection in some of the most horrible spaces in New York City, like Penn Station. And we're still advocating for fixing that terrible, terrible place. And that advocacy actually in many ways led to a lot of the work that we're doing, everything from new air traffic control towers for the FAA, a new bridge in Indianapolis, and then some projects I'm going to quickly talk about this morning. And hopefully you'll see the through line of these projects. This is a new college at Princeton University, Hobson College, right in the heart of Princeton's campus. As you may, if you've been there, you know Princeton has some of the world's leading architecture on its campus. It's actually a terrifying project. This is a Venturi building, Harry Cobb down here, Williams and Chen up there. So we have some pretty prominent neighbors. We're building all these courtyards around them. And one of the things that Princeton, like many institutions that kind of struggle with history, right, deal with the fact that it is a historic institution. And so sometimes there's like, well, shouldn't every building look like Hogwarts? And we kind of have to explain that we don't really do Hogwarts. But what we can do is interpret all of the historic conditions and understand how to make a contemporary reading of them. And so this is the building that's under construction right now. It's a 511-unit residential college with a theater and other things. So what we basically argued to Princeton is that we can mirror the scale of the campus. We can mirror the materiality of the campus, but at the same time, this is a campus, this is a college being donated by Melody Hobson, who is one of the most prominent African-American alumni of Princeton University. And this is an institution in the middle of, like all of our institutions, a great deal of change and a great deal of diversification. So it has to represent in a different way on this campus. And so it's a big building. It is a brick and terracotta facade. There's a 6-degree cant on a portion of the building that's meant to echo the mansard roof systems of Princeton, a 12-degree cant on these community clusters. Some of our construction folks struggled with a 6-degree and a 12-degree cant, to which I responded, how is it we built Rome if we can't build a 6-degree and a 12-degree cant? So we got through that period. And the main thing in terms of tying it to history and connecting to the historic campus is a material palette in the facade, a really beautiful brick, cover tile, terracotta that ties to the historic fabric in terms of what, down to the mortar color, right? But is, again, expressed in a fundamentally contemporary way. I have to say, we have, for all of the reasons you know in terms of universal modernism, and I saw the slides of all the presentations that are done around the world, gravitated towards standardized systems that I now worry about. That those standardized systems in the 20th century of glass and steel that were supposed to bring us together in many ways are becoming quite segregating and quite off-putting, as every building becomes the same blue glass building with the same Starbucks on the bottom, whether it's in Mumbai or Shanghai or Dubai. So I would really encourage professionals to try to think more interpretively about their environments and think about different systems and materials that do that. This is another project that's trying to connect to a community and a place in a different way. This is terrifying. We are expanding IMP's Rock and Roll Hall of Fame in Cleveland. This was an invited competition. If you've been, I'm a huge Pei fan. This is his second worst building after Javits. He had just come off the Louvre. He didn't want to do this commission. He said, I know nothing about rock and roll. It was his kids that encouraged him to take the commission. And so he designed it famously to look like a turntable from space. Many younger people may not know what a turntable is, but that's the record player. That's the arm of the turntable. Interesting idea, terrible functional diagram for a museum. And so we're building an expansion that practically doubles the size of the institution. And what we wanted to do is connect, again, the pyramid, which feels very isolated on the shore of Lake Erie, to not only the lake, but the city of Cleveland, which is also going through a great deal of change as a city, extraordinary mayor, with a new front door and a different kind of relationship to the city. And so one of the things, so with the original pyramid, our idea, and this is a kind of 80s postmodern building, has a lot of these Platonic shapes. We wanted to build on the vocabulary of Platonic shapes with the core service elements, a new performance space, but in the middle, a new kind of public space for the city of Cleveland. And so the building is meant to be both reverent of IMP and feel like it was always there at one level, but also be deeply irreverent in the sense that rock and roll is a deeply irreverent genre. And so this new entrance will bring people in, and the two buildings do connect. We are going to build this. This is the gutter that attaches to the mullion system of the pyramid. This keeps me up at night. But we are going to do this. And then we're introducing a material palette that, again, is very much, we think, about rock and roll. And about the idea that this should not feel expensive. It should feel gritty. It should feel inviting of kind of change and dynamism. And so this is that public space between the pyramid and the Performing Arts Center, or the Performance Center that I mentioned. And what we convinced our client of is that this should be unticketed space. That a kid from Cleveland on a bad Cleveland day, in terms of the weather, that happens, that on a rough Cleveland day could come here, play music with friends, listen to music. And from every artist, from Paul McCartney on down, that we've heard from about this project, it's this notion that young kids get absorbed. This is happening with my daughter right now, who just learned the electric guitar, get absorbed in this, and they just never kind of come away from it. And this was the inspiration for this space. And so we're building it. We're working with field operations, and Lisa Switkin is doing a beautiful landscape around the building, and also a space that connects. Believe it or not, the Rock and Roll Hall of Fame never had a performance space. And so we're building a performance space. And the budget is tight, but we are doing it. It is this ellipse. We're working with Jaffe Holden, extraordinary acoustic consultant, and there it is under construction right now in Cleveland. And then moving on kind of to the last project I wanted to mention this morning in terms of walls that connect, the refinery at Domino. So I've been working on this project for almost 10 years. I used to be a partner at Shop Architects, where we did the master plan, again with Lisa Switkin at Field Operations. This park is incredibly important. How many of you have been to Domino Park? Good, a good number. I encourage you to go there on a sunny day and just look at the playground, because there are 4 or 5 different communities around this site that, before this park was built, really never had a space where they can get together. And this includes Orthodox Jewish kids and African American kids and Latinx kids. And the fact that they all played together in this playground, I think, is so important for the world we want to build, the more connected world we want to build. So we were then, after I formed POW, we were given the assignment by Two Trees to put a creative office building and event space into the sugar refinery, which is a historic landmark, has very small windows, was built as a factory. And this is kind of what the inside, this is our drawing, but it's kind of what the inside looked like. The facade itself was really kind of a lie. It had fenestration, but it really it was housing all of this equipment. It was built by the Havermeyer family in the 1880s in 3 phases. And because of these 3 phases, none of these windows lined up. Because there was all this machinery inside, it didn't matter whether the windows lined up. And so Jed Valentis, who runs this project, called me and said, we've got this massive problem. There's no light getting into the building because the windows are so small. None of the foundations are plumb. It's an old factory building. And the biggest problem is because the windows don't line up, we can't strike a floor across. And I drew this while we were on the phone. I said, Jed, I think the only thing you can do is build kind of a ship in a bottle, or actually a bottle in a ship. Build a building inside the building with standardized floors and let light in through the gap between the old and new building. And we were able to go to the Landmarks Commission and say, look, this was the historic condition of the building. With these vats were filled with crushed lamb bone. When you learn how refined sugar is made, you'll never eat it again. And so there was all these vats, and then they were the facade was held up with these steel tiebacks and these ring beams. And we said, this is the condition we want to emulate in the new building, where we put in a new curtain wall with those new steel tiebacks, new ring beams, and a gap between the old and new building that lets light in. And it'll rain and snow in this space. And we actually use this photon technology that a friend of mine uses in Berkeley to establish the size of the gap to get light down to the lowest office floor. And that was an extraordinary thing to undertake. And Jed said, okay, let's do it. And then there was an extraordinary amount of work to do about this building. I mean, it's a historic structure. They had to cut the old steel tie beams. And a lot of analysis had to be done in terms of where the brick actually had the kind of structural integrity that we needed. We did some repointing, but in a very, very particular way, in the sense that we didn't want the building to feel bright, shiny, and new. We wanted to keep its patina. And then again, this was also terrifying. And then if you saw this under construction, because those steel tie beams were cut, a whole new superstructure had to be built temporarily around the building to hold up the facade while the new building was getting built inside. All sorts of details had to be worked out, like there was thermal differentiation between the movement of the brick and the glass curtain wall. And so when that tieback went in, it went into this blade that had to move. And so we had this extraordinary team on our curtain wall facade consulting, Foki, other people who helped us pull this off. So it's about 145,000 square feet of new curtain wall. We tried to limit the number of types of glass that were there and came up with this system. And so this is the system going into place. And that gap is now out there today. There are 25 pin oaks growing in the gap between the new and the old building. It's really rather extraordinary. And if we want to talk about the future of workspace, the space inside, I think, is just breathtaking, because you are looking through a magnificent modern curtain wall system, then through foliage, through then the brick of the old building, with these vignettes of the city. And then, of course, what the brick does is it acts as a solar shade for the entire building. So if you think about the modern worker and having a screen in front of you, there's no glare, there's just this very soft light that I'm going to daringly compare to the light in the Kimball. It has this very soft ambient quality that I think is really quite extraordinary. And then, one of the things that happened is when we created that gap, more FAR, more development rights moved to the top of the building. And we did several studies for what the top of this form could be, but we kept coming back to something, which is a kind of fascinating history. These windows, these arched windows, are not there for decorative reasons. The American round arch style developed in these old factory buildings because the older buildings, and there was actually an older building here that burned down, had a wood lintel that held up the brick above it. And so what would happen is, if there was a fire, and there was always a fire in these factories, the wood would catch fire, the entire building would collapse, which is exactly what happened, until they developed the idea of doing these brick arch windows. And that was actually not just a decorative device, but a fire retardance device. And so to that shape, we wanted to pay homage. And so we kept coming back to that vaulted form. It also rendered the building column-free on the interior. It's about 25,000 square foot floor plates that can be used either by single tenants or multiple tenants, because it is column-free. And then the barrel vault landed the foundations very nicely inside of the gap, away from the existing foundations. So it did multiple things really well. And so the building, in terms of also connecting to the community, very importantly, we got Landmarks to agree to take out the old glass, because the old glass, a lot of it wasn't original, and to drop the windows on the ground floor to door height. So the building would become as porous as possible to the park system around it. So you have this big muscular building, but it has this ability to relate to the neighborhood and to the master plan and to these streets, because we connected up the street grid in a way that feels very urban, very New York, very open to the community. And that includes an amazing event space that's at the top. This is fritted glass, it's double pane, it's bent, and so it's really very beautiful. There is a shading system that hasn't been installed yet, but it's just a spectacular place to be and to see the city. And again, the way we open up to the ground floor. And so I just want to close with, so the building's very important to me. It's kind of our pride and joy. To me, again, what is important about this project is it can't be just anywhere. And so our litmus test as a firm, and as we work with all of our collaborators, curtain wall systems, contractors. We ask ourselves, if you could take this project, if you can take this thing that we've designed, and you could move it to another site, and it would be kind of the same, we have failed, right? And so when you hear communities, when you hear about NIMBYism, people don't want new construction in their neighborhoods. Well, if you're giving them this generic thing that could be anywhere, why should they want it in their neighborhood, right? With this community, we had extensive conversation about the fact that they were open to change. They were open to growth. They wanted to see some affordable housing. They wanted to see a park system they could use. And they specifically said on the architecture and the wall systems, we want things that echo our community. That didn't mean nostalgia. It didn't mean historicism. It meant this idea that you could pull history forward into the future, that you could marry the old and the new, and that you could invite everyone into that conversation. So the thing I'd just really like to leave you with is this notion that, so this is my idea of nature, culture, and joy. There's 8 billion people on the planet. There's going to be 10 billion by the end of this century. We need to find a way to all live in harmony together without all of this division. And I think, again, places like that fountain, where you'll see every race, class, play together in front of this building, is a place that models that kind of idea of us all living together. And I think design plays a very, very important role in this, right? That with every move we make, every place we put a door, every place we put a loading dock, every place we decide to make a facade blank as opposed to something that's inviting. And by the way, this isn't, some of the book talks about some of the best architecture in the world that overcomes these challenges, and much of it's in the global south where they have far more challenging economics than we do. So this isn't about money. It's about intent, right? And that this idea that if we can build those more connective buildings, we can create places where we celebrate difference and have friction among people who think and act and vote differently. And we can create nature and culture and joy. And we can actually build a world for 10 billion people where we can live in harmony. I think we need that hope right now. And so that's why the book closes with this idea that I like to call the Garden of Urban, right? This notion that we could build a planet, and we do have a lot of building to do. There's a lot of people unhoused in the world, underhoused in the world. We have a lot of work to do, and we need to use the right systems and the sustainable systems. You all know that. I'm going to add an extra layer of challenge, which is in addition to building sustainably, we have to build connectively, right? That we have to invite people into this world and not just create the same old building again and again and again. Thank you very much.
Great job.
Editor.
Nothing. Thank you so much, Vishaan. Really interesting. I love that you present with a partie, and that partie was about connecting walls, and the materials and the specificity was really interesting for me. So I hope you all took something away from that. Our next presenter, Emily Losego. She's the Director of Commercial Innovation at Vitro Architectural Glass. We're going to now dive into a little bit more technical here with her talk. Emily plays a key role in driving innovation and advancing new solutions with the glass industry. In her position, she focuses on identifying and implementing cutting-edge technologies and products that enhance the performance and aesthetic qualities of architectural glass. So, Emily, welcome. I believe you are getting low with U values.
We are.
Okay, great. Thank you.
So thank you very much. So I am Emily Losego, the Director of Innovation for Vitro Architectural Glass. This is my first time at Zak Façades, and I am truly privileged to be here to talk with you today. So the topic today is getting low with U values. So what we're going to do, we're going to talk about what is U value, why it matters, why we should care. We're going to talk about it in terms of carbon, how we can reduce the embodied carbon in our projects and the operational carbon as our buildings are used in the world. And lastly, we'll talk about glass strategies. And these are kind of what levers can we pull to continue to drive U-value low. Here's the problem. Okay, we're going to take a little plot twist. This presentation is called Getting Low with U-Value, and this is a song from 2003 by Lil Jon and the East Side Boys called Get Low, and this has been in my head for the past 3 weeks putting this presentation together, so my souvenir to you all is to get this song stuck in your head as well. And if for those of you that don't know, did anyone remember that song? Right? Okay, pretty catchy. So remember, U-values, we want to get low. So diving in, we're going to understand Lil Jon a little bit more during this presentation as well. So he had a rap career in the early 2000s, but in 2021, how many of you knew that he had a show on HGTV called Lil Jon Wants to Do What? And he got into interior renovation and moved into the construction world, which blows my mind. So you'll see Lil Jon popping up through here. And if you don't know his sound bites, Lil Jon Wants to Do What? This is why it's important. What? So let's skip to 101, right? We got to start at square one. On our buildings, we're using insulated glass units or IGUs. And the way to think about how this glass is working is very similar and analogous to a thermos or a Yeti cup, right? So everyone has their Yetis, they're keeping your coffee hot, your ice water cold throughout the entire day. And there's a few factors that are making that occur. It's a double wall assembly, similar to our insulated glass units, which is 2 pieces of glass with a cavity. And just like an IGU, there is a cavity that is giving us insulation performance in that. The other thing that's really driving why people love their Yetis is that metallic silver lining. And just like a low-E coating, silver is the effective ingredient in that, and that is working to reflect and keep the contents of that Yeti the temperature you want, right? So your coffee stays hot, your ice water stays cold. The technology of that cup doesn't change. It's doing what you want. And just like our exterior glazing, we want to keep our contents or our interior spaces at the temperature we want for as long as possible. So understanding U-value, this is really a metric about insulation. What is our heat loss? What is our heat transfer through our envelope? As we understand this, we want to talk about winter nighttime U-values. So the reason this image is up here is because winter nighttime is our coldest scenario, right? This is all about temperature differential between our interior spaces and the exterior temperature. So winter is the worst case, night is even worse. And that's where we're going to have that biggest differential. And that's the metric you want to pay attention to. You'll sometimes see summer daytime. And so he's going to be better performing or a lower U-value, right? Because with U-value, you want to get low. Because it's a smaller temperature differential between exterior and interior, winter nighttime is going to be our worst case. And one of the ways I like to think about U-value is think about it as a jacket, as a coat, right? It's the difference between putting a windbreaker on and putting a Columbia jacket on that has silver dots that is going to keep you sweating in the winter. That's the same premise and same thinking along the lines of what U-value is doing and contributing to our projects. But with U-value, lower is better. U-value is also the metric for understanding occupant comfort, right? We want to have spaces that are enjoyable and comfortable to be in. And one of the things that's interesting with U-value and the physics of U-value is that how that glass is installed actually can affect the thermal performance of that glass. So the convection between the 2 lights of glass is at its minimum when it's at 90 degrees or our vertical orientation, and it's at its worst when we go horizontal. So that domino factory that we just saw had every angle in that barrel vault glazed structure on the inside. We're going to get in a standard IG a different thermal performance as that glass is installed in different orientations. So now let's talk about carbon, right? This is really the next way that we're understanding the materials that are going into our buildings. And another key soundbite that Lil Jon blessed us with is this. Oh, let me try that again. So again, what's embodied carbon, right? This is the energy it takes a manufacturer to bring a product through the manufacturing process. It includes the extraction of raw materials, getting those materials to a production site, and actually going through the process of turning raw materials into a finished product. And we talk about it as global warming potential. And this is important because this is really the common denominator, how we're able to evaluate different products by different manufacturers and understand the environmental impact for those products to come to be. So I like to think of this as it's the way to compare apples to oranges or windows to walls, just like Lil John likes to talk about to the windows to the wall. Now for glass, as a float glass manufacturer from Vitro Architectural Glass, the most intensive process for the glass in terms of GWP that's on your building is really our first step, which is making the glass itself. So at 3,000 degrees, we're melting sand and other additives and extracting it, and that is very energy intensive. So you'll see here, there's low-E coatings that are added, there's heat treatment as we temper or heat strengthen the glass, there's fabrication to pair two lights together, but really 75% of the GWP is in the making of the glass itself. And as we'll talk about U-value codes and what those metrics are driving down, one of the strategies is to go to a triple, right? Instead of two pieces of glass, you add a third. But understanding the embodied carbon and where that's driven from, that's actually adding 50% more GWP to that makeup because you're adding that third piece of glass, and that's really the energy-intensive process step to getting that glass on your building. So what's really amazing with how far glass has come is how low we can get our U values to go, right? How long we can keep the interior conditioned air in that space as long as possible. And by doing that, we're able to allow more glass. And allowing more glass increases daylighting. I mean, that domino project couldn't have been teed up any better for me, so thank you for that lead-in. But that daylighting, bringing in that natural light is a strategy to reduce our operational carbon because you're not relying on your electrical system to do the work entirely, right? You're employing more of a holistic approach for your daylighting, your illuminating of the spaces. And same with mechanical. So our U value, as we're able to design lower and lower, we're able to have higher thermal performance, but also require less performance out of our mechanical systems. Because the heat is staying in longer and because our air conditioning is staying in longer, we're not putting that demand on the mechanical system, so we're able to use them less wear and tear, less utility bills, less operational carbon. All right, we got one more amazing soundbite from Lil John. So this is my favorite part because it's glass, right? We're going to talk about what levers can we pull as designers to drive U value now that we understand why it's important, what it's doing from a carbon perspective, and now we're going to look at it kind of from a specification and design perspective. So the first iteration of glass in existing buildings is monolithic, right? We got one piece. So what are the levers we can do to improve the thermal performance of that? First, we can add a second piece of glass, which is giving us that cavity. In that, we can change, we have a surface that we can add a low-E coating now, that before when it's monolithic, we're not able to do that. So we can add a low-E coating to that IG. We can then change what sits between those two pieces of glass by changing it from air to argon to krypton, so on and so forth. From there, that second piece of glass also gives us a second opportunity for another low-E. So that's using a forced surface or a room side exposed. Again, think back to that Yeti to reflect and keep that interior temperature reflecting in on itself. So you're going to keep it longer and keep your coffee hot, ice water cold, and you're building the temperature you want it to be as long as possible. Then we talked about adding another piece of glass, right? A lot of this is happening because of that cavity, so why not have more cavities, right? That's adding that third piece of glass, going to a triple. That gives you a third surface for a low-E coating, a second cavity to employ. And the other part that's really important is the spacer, right? So what is holding this glass apart from each other? That can be a major factor because that's really where the frame and the glass overlap and live in the same world. So for us at Vitro Architectural Glass, we were very excited earlier this year to launch Sungate Thermal, which is our own forced surface low-E coating. And when it's paired with a solar band, 70 in this case on surface number 2, so we're going to defend that airspace from warming up with our low-E on number 2. We have our cavity with argon. We have Sungate Thermal on surface number 4. In that 1 inch, we're able to get to a U value of 0.19. And what's exciting for us is we've been out of this interior coating due to technology changes, and now we're back, which means that your entire IG can be supplied by Vitro again, which we're very excited about. So I was an architecture student when this song came out, and I felt very seen because of this part of the song right here. Right? It's not very often you hear architectural elements referred to in pop culture, on the radio. So, of course, I geeked out. I mean, you have to, right? So let's talk about windows and walls together. And for us in glass, that means putting the glass into a frame. All the numbers I've talked about has really been center of glass focused, but codes talk about U-value performance as a system or as an assembly, and that means how does the glass and how does the frame work together? And there's factors that affect that. We just talked about the edge spacer, right? That's where the two kind of overlap as an opportunity for thermal bridging. There's also what frame is it in entirely? What's that frame contributing? And even the size of the unit. How much frame is in your design? So the frame does contribute. It reduces our solar heat gain. So that's saying we're going to get less solar radiation coming into our interiors because there's frame there. But the trade-off is, as we know that U values need to get low, U value goes up. And that's because traditional framing systems are made out of aluminum and are highly conductive. So you'll see here, we can drive the center of glass U value really low, but you put it in a frame and that number is going to get higher and higher and higher. It improves the better thermal performance of that frame. But there are architects that will use more glass as a strategy to improve their system U value because you're limiting and reducing how much thermal bridging is occurring by having less metal in your assembly calculations. You're using more of that center glass performance, and you're able to increase your window to wall ratio, have more glass, get that daylighting while still maintaining and improving the performance embodied carbon needed to do that and the operational carbon to run that project. And what's exciting for us at Vitro Architectural Glass, we can now talk about where the window becomes the wall. So we have our VacuumMax VIG, which is the next generation of insulated glass. We're taking 2 pieces of glass, putting it under vacuum, and held off by micropillars. With our solar band 70 on surface 2, we are able to get to a U value of 0.05. That is an R20, and as we know, U value and R value are reciprocal to each other. So truly, the window can become the wall using this, and then as we talked about installation orientation, it doesn't matter. You're getting that same performance no matter which orientation that glass is installed in your building. So as we look at these kind of major thresholds, right, from single glass, double, triple to VIG, we're seeing a double of insulation performance in R value as we look at that between double to triple. And from triple to vacuum, we're getting 3 times the insulation value, but we're doing it in about 1/5 of the footprint. And as we know, less glass is less embodied carbon. And so there, you don't have to trade off anymore. And with that, I would like to share with you our first US installation of VacuumMax. The even next generation that you can do with vacuum insulated glazing is to use it in a hybrid. So your vacuum light can be treated as a monolithic light. And in this case, it was used as the inboard. They had a traditional cavity and an outboard light that actually featured bird-friendly first surface markings and another instance of Solar Band 90. So with that, I want to thank you for your time. Thank you for indulging me. I mean, I am pretty excited that I was able to Get Low for you. And with that, I just want to remember, U value, let's get low.
Thank you, Emily. That was great. And now in a world where developers, owners, and all of our consultants are having to deal with the new energy codes, this is really important for all of us to obviously understand. Most of you deal with it on a regular basis. Our next speaker, James O'Callaghan. Sure some of you are familiar with James. He's a structural engineer and co-founder of Eckersley O'Callaghan, a leading engineering consultancy known for pioneering work in the glass engineering field. O'Callaghan is widely acclaimed for his innovative use of structural glass in iconic architectural projects, most notably in his collaborations with Apple. He played a key role in designing the glass staircases and facades features in Apple stores worldwide, including the Glass Cube on Fifth Avenue. So with a deep understanding of materials, an approach to structural design, James is with us today. He's pushing the boundaries of what's possible with glass, and he's going to present for us today, Engineering Transparency in a Changing World. James? There you are.
Thank you.
Welcome.
Thank you. Yes, I am here. I was worried about that. Good morning, everyone. It's great to be back in New York. Great to see so many friends from the past, and to touch base with a city that I spent a lot of time in, and one that I enjoy working in. Today, I'm going to talk a little bit about a reflection of the work that I've been involved with for the last 20 years. I've had the opportunity to work with some great collaborators that's allowed us as a practice to innovate, and in particular in the material of glass. So today I'm going to reflect on that in what is clearly a changing world with changing parameters, many of which we've heard about this morning from Vikram and also from Emily in terms of the challenges we're facing in energy and what glass needs to do to manage that. There is an element of how glass remains relevant in our future, particularly given these challenges of energy and its use. And there's some really big challenges it relates to the construction industry. So I'm going to sort of start here with this image. This was glass being used in its very in a very innovative way in the sort of beginnings or turn of the Industrial Revolution back in the mid-1800s. Joseph Paxton most famously designed this glass house in Chatsworth, and then went on to design the Crystal Palace, which in turn burnt down. But the point is here, glass was used for a very singular use, right? It was used to essentially let in light and keep out the rain, the moisture, very simple. And as a result of that, the engineering of it allowed it to be very delicately and beautifully contained within this skin. The glass and the structure are working together. They're in harmony, you know, they're integrated in their thinking and their work. And that's great because it's resulted in a beautiful piece of architecture. Today, this is kind of where we've got to. It's a very generic detail. It happens to be of a closed cavity facade, but what you can probably tell from it is that this is the bit of glass here, and there's a whole load of stuff. There's extrusion, there's mullions, there's gaskets, there's all sorts of things that we've needed to add over time in order to be able to ensure that our glass can perform. And in fact, I'll ask Emily showed some great examples of how glass can be combined with coatings and vacuum glazing, and all of those things have been additive to the material or additive to the glass technology in order for it to be able to perform in today's requirements. I think the point being here is that there's a lot of stuff in that, right? And there's a lot of energy, a lot of embodied carbon that we need to put into our building envelopes in order for them to perform. And that's a question. It's not necessarily stating where we go, but it's got to give us some indication about the direction of travel. We need to be able to integrate more. We need to be able to reduce. We need to be able to get the materials we work with to do more. So I've been reflecting on that as it relates to glass in particular. And I go back to this image, which is when I started working with Apple as it relates to glass. Of course, this was the latest technology in 2002 when we started to play around with glass in a slightly more ambitious way. But at that point, sustainability wasn't on my mind as it came to the development of glass design. It was very much about a maniacal pursuit of transparency. And the interesting thing about that was that in that maniacal pursuit of transparency, I was trying to do more with much less. And that is that is a sort of underpinning of a sustainable narrative as it comes to structural engineering. And I think as structural engineers, we tend to look at it like that. We should be trying to do things with the most efficient way. And I think in terms of glass, it's very much important to be thinking about that sort of approach. What can we do more with the glass? And I think that's what this is about. Now, it started with these ideas of, you can see in this kind of ancient technology that we now face to this image, this first glass staircase in Soho, not so far away from here in Prince Street. It was very much what could we do with the material at that point? And actually, it was the development of interlayers, which allowed that to happen. Century glass was pretty novel to the market at that time. It allowed for much more structurally ambitious approaches to the lamination of glass, the post-failure of glass, and that allowed us to be more brave in terms of what we could do with the material, as well as refining its transparency and its detailing. But it was very much about that sort of detailing. It was as much about the glass design and understanding the material as it was understanding the connectivity, and that connectivity, reducing that connectivity, minimizing that connectivity to make the most of the material itself. So getting the most out of the material in terms of its performance, structurally at least. And then combining that with different situations or adaptivity. So you have the idea of a system that you've developed in terms of glass, but how does it relate to different environments? How does it relate to historic environments? How does it relate to different geometries and playing with different materials that then combine with that, chemically tempered glass in this instance, and different technologies for forming the glass in different parts of the world, subject to very significant different forces, seismic loads, for example, in Osaka, and yet maintaining the familiarity of that design. Now, I was then getting more interested in understanding about how we could integrate more the building envelope or the building elements that are otherwise considered as secondary. So, for example, here, a staircase being supported on an envelope, the wall, the glass interior envelope of the glass of the space itself, therefore obviating the need for any secondary structure to support a staircase. I mean, a simple idea, but then you extrapolate that to a much larger idea, and then you start to see that you can really start to do more with those bits of material that are already there. They've got double purpose, and you're taking away the need to have something else. And I think that whilst this is, of course, extreme examples of that, it's allowed the thinking to settle in terms of that ability to be considering the materials themselves to have more than one function. And that's what I'm kind of interested in exploring more and more. Iteratively over time, that allowed for the development of details. It allowed for for us to be a little bit more considered about how we might have buildings themselves. I mean, this, for example, Fifth Avenue was the first of the sort of glass buildings that we stepped into in terms of this journey. And in 2006, it allowed us to build this particular building, which used 90 panels of glass and had, at the time, the technology that was available to make those sizes of panels of glass. But as we'd moved through time, we were able to develop ideas to make much larger pieces of glass, and those much larger pieces of glass, up to 12 meters, now up to 20 meters, in terms of their fabrication and their ability to be post-processed, meant that we could distill that into something much more simple. Not the most sustainable story, I have to say, because there was certainly nothing wrong with the first one. But it is, in fact, a demonstration of how innovation and development of technology can, in fact, result in something with less. I mean, this, in fact, was about transparency as I go to. It wasn't about sustainability. But it does involve the fact that we then have able to use much larger elements, therefore much more transparency, much less materiality. And that journey has continued a little bit. Very recently, this is something that we just finished a few weeks ago. This was, in fact, the replacement of a project in Shanghai that we did on the left-hand side. And you can see it had a glass structure. And through what we've learned about the material and what we've learned about the engineering of that material and the understanding, and of course, all the great people that have made this material. I mean, we can only do things, we can only design things as well as they can be made. So the fabricators of this glass, like CDAC, for example, and North Glass in China, have been able to enhance their processing facilities, their technology, and that's all led to that. So, it got to the point where we could, take away the structure. So once again, this envelope is the structure. It's dealing with those forces. It's dealing with everything that we stitch together at the same time. And it's a play on transparency, but it's also a play on how we can do more with much less. In Zorlu in Istanbul, a very simple idea: how do you make a glass box with 5 sides but with no structure? And in this instance, we were exploring glass as a roof, as we were trying to make something that was made out of 5 sides of glass. Decided that actually that wasn't the right material, because the limitations on the width of glass, at being approximately 3 meters and 10 meters by 10 meters, meant we needed more than one piece of glass, and that needed supporting. And therefore we stepped to one side, looked at the problem a different way, and said, okay, what else would be of an interesting material, and started to play around with composites. And in this instance, carbon fiber. So we were able to then put this very singular 2-inch thick at the edge, 6-inch in the middle, tapered composite structure on this 30-foot square space, to sort of give this, drive towards a minimal use of materials in for its simple terms. In terms of its ideology of doing more with less material in the same form. That led to this building, the Steve Jobs Theatre, in part of the campus for Apple in Cupertino, and extending that idea that we had in Istanbul to a much larger application, in this instance roughly 60 meters in diameter, and making that from sort of pizza-shaped wedges of carbon fiber, fabricating those in place, and then enabling us to be able to lift that delicately onto this glass structure. And you can see from this video the impossible thinness of this significant structure itself. And in it, therefore, there are no columns. It's just the envelope and the roof. That's it. There isn't anything more secret to it other than the way in which the services are led through the silicon joints to create the lighting and the sprinklers. And it sort of creates this really dynamic space that's connected to the environment in which it sits. Of course, it's all very much about that transparency. Now, one thing that challenged that in all of these glass structures, of course, is there's energy, and that's what we're going to move on to now. And of course, in many ways, they're not viable from an energy perspective. They don't have any performance from energy. And we talked about a little bit before about those beautiful conservatories in the 1800s, and I guess that was the modern day equivalent of that, but it don't necessarily deal with the energy transfer and flow. This project in Singapore recently finished, which starts to address that and still utilizes that idea of a homogeneous material structure. It uses this glass shell. It's supported by very delicate steel columns. Those steel columns are not capable of supporting the glass. The glass has to work with it, so it's all tied together to create a sort of tension structure, a shell structure, that enables this structure to support itself, but also within that, it has this ability for creating moderation of energy and light through the shading and through the opacity of the envelope itself. So it was kind of taking that next step. Where do we go? Again, with Foster and Partners, exploring these ideas about what might be transparency, and how does one navigate that more intense energy performance criteria. This is in fact an insulated unit panels, and of course there's more transparency at the level at which you're existing, and that opacity changes as you move up the structure, as does the thing. So those ideas about larger format glass, those ideas about structure and doing more with less have ultimately start to find their way into different parts of the world in different buildings, and thankfully there's some things that have come from that become useful in other buildings. This, of course, is just up the road, Manhattan West, one of our projects with respect to this utilizing much larger glass with SOM here, embracing that scale, minimizing that structure within these transparent lobbies of taller buildings. Perhaps an obvious application of that materiality, but it's a really effective one that comes to some extent from those ideas. Similarly, Beijing Public Library, where in fact there are no mullions. These are 20-meter, so 60-foot panels of glass that are that are articulated to allow them to act as the structure and the envelope. There are no mullions in this instance, in this particular building. So these ideas of doing more with less comfort. But we have to make the glass work harder. We know that glass has had a pretty bad rap with respect to its place in society, and it's been under pressure because of energy, but also of many other things, glass towers in New York, for example. But we need it, right? We love light. We need light. We need connection to the outside. We need to have that. It's part of our needs, and it's not something we don't want to lose. And we got to be able to fight the battle that glass has to fight in order that it remains relevant. We don't all want to live in this situation, hopefully, and we want to recognize that things change over time. I mean, this is Singapore, and you can see in the 1970s, and as land was reclaimed, glass performance and the neutrality of glass changed over time through to the 90s. And you can go and almost see this in panorama image of where the performance of glass itself has got better in order of managing light. But it comes down to this issue of window wall ratio, which I'm sure will be spoken about quite a lot today. And this is the thing that's the controlling measure of how we deal with it in terms of code generally globally around the world. By reducing the window wall ratio, of course, we can therefore manage the standard the standard performance of the buildings. But in doing so, it's quite easy to say, we reduce the window wall ratio, and this is, for example, in a building in Norway that's just about passes code now under their current requirements, 33% window wall ratio. So, are we heading in this direction? Are we going to be using much less glass? And that's fine, maybe. There's no problem with that, but we need to be conscious of those decisions about where the energy codes will take us, and likewise how quickly glass as a material within its facade can respond to that and remain relevant and have its pursuit of in our architecture. And I thought this was interesting. Quite clearly, these buildings actually show that perhaps there is a change. There's a change, and there's always been a change. There's a change in architectural style. There's a change in architectural, which is driven by technology, perhaps. It's driven by architecture and its influences, and you can see that actually that, to some extent, has changed over time. And where does that go next with respect to our buildings? And how do they start to evolve? And we've talked about the fact that the glass needs to do more. We have ways of dealing with that, clearly, that we're all aware of. There's and different techniques of combining things to the glass and with the glass to be able to get it to do more, shading it, optimizing how we do it. Many better tools now for us to be able to use, to be able to understand more about what we can do with it, and other ideas about how do we create shading. We saw a beautiful example from the Domino Sugar Factory with respect to, that adaptive reuse and, in fact, creating space that controls light. So all of these are quite interesting technologies. Some of them have been more successful than others. I mean, dynamic glazing is still in its relative infancy, hasn't been tremendously adopted, but the ideas are very clear. Starting to have a building that dynamically responds to its environment, just as we dynamically respond to our environment, is quite important. Closed cavity facades, we're looking at doing a number of buildings like this at the moment around the world, and this is becoming an increasing technology, but it does add this extra stuff, right? It has this very clever in terms of their ability to be able to adapt to light and thermal performance and glare, all the things we need it to do, but we're adding stuff. And so where does the future come with respect to glass as a material to become more integrated in not only its structure, but also in its performance? And we're still, we're seeing many buildings like that around the world. For us, we start with things like this. There's a lot of research that we do goes into building tools that actually start to optimize the way in which we start the process in the design process. So being able to build facade systems parametrically within that modeling environment, and then being able to inform our clients, inform the architects we work with, what that means in terms of embodied carbon. So that that decision matrix, which starts to rely more and more on that kind of performance and embodied carbon, is understood. This particular graph I find very interesting with respect to Arup's publication carbon footprint of facades, and you can kind of get an idea of where we are. Now these, that I've just talked about, the closed cavity and the double skins, very effective in creating dynamic systems, but of course very laborious in terms of its embodied carbon. So we haven't got the answers, right? We know where we've got to get to, but there's this real tension between what we need to be able to do and what we can. One way of looking at it, I think that we'll see more of this, which is the adaptive reuse of buildings. I particularly like this particular case study, a building we worked on in Paris over the last few years, because it relates to the right thinking in the first place, and it relates to thinking about the end of life. So a building facade, what's going to happen to it in the end, and how is it going to be reused? This building started like that in 1968. I think Jean Prouvé developed the UNESCO headquarters as a completely modular facade system. That was his idea in terms of his architectural narrative frequently, such that in time it could be taken apart and it could be potentially refurbished. I don't think he necessarily had that understanding where that might be and when that might be, but clearly 50 years later this had no insulated units, it had a very poor it was beginning to corrode, and there was elements that were structurally unsound in terms of the core of the building. We were able though to take the building apart, the facade apart, literally unbolt it, clean it up, replace those elements that didn't work any longer, including all of the glass. We were able to recycle all of the glass, we were able to recycle the elements that weren't able to be used, and we were able to reinsert timber cores within it rather than aluminium cores in order to be able to re-strengthen it. That massively drew down the embodied carbon that we would otherwise use to refurbish that building. And as a result of that, right now, not only does it have a significant re-savings, but it has a brand new skin that is exactly the same as it was before, because it had been considered in that way, and it'll last for another 50 years, 60 years before somebody has to look at it again. And I think that kind of thinking process at the beginning rather than at the end is something that we need to bring to bear along with these other ideas that we're looking at with respect to technologies and integrating. So all of that comes only through research. It only comes through trial and error. It comes through the pressures of change in our industry. It comes through us being innovative and responding to the need to those changes. And this diagram gives us an idea about where some of those things might be through my research at TU Delft, where I have a research group that is focused around glass technology, and in particular its relevance in the buildings of the future and how it will be integrated in some way and how does it respond to that, all of which I've talked about today. And of course that's in many areas. It's different materials, it's understanding how different technologies, innovative materials like thin glass, for example, that you find on your iPhones, how's that going to find its way into our building environment, built environment? Should it, does it have a relevance? Well, maybe, because maybe it means we can do things with that material that we couldn't before. We can start to flex it rather than having articulation in facades and complex systems that I showed before. Is there a way that it can have a relevance like that can help us to solve a problem that we've already got? Can it help us with lightweight glass, to reducing weight, so we can have composite materials with glass and therefore reduce the overall building weights, and that of course has an ongoing effect to energy? Is it able to be integrated into much thinner insulated units? So all of the heritage glazing that we have around the world, which of course is very important and needs to be protected, which was never designed to have insulated units that are 4 times the thickness, are we able to replace that glazing with something much thinner, with a higher performance insulated unit, therefore get much better operational carbon out of the huge building stock that exists in the world of heritage buildings? It's a very, very important part of our work will be not only building new buildings that are great and performing well, but it's also making the ones that already exist perform much better. The circularity of insulated units, where's that going to go? How are we going to get to the point where an incredible product such as the insulated unit, designed to stay together forever, we're now looking at ways in which we want to take things apart. It was never considered like that in the first place, so of course the solution that was presented never had that in thinking, so we need to go back to the beginning of our insulated unit concepts and think about how they will come together in a way that they can be coming apart. Some of those ideas of connections and details and how do they the permanency of connectivity, reducing that to something that can be more undone through heat, through light, through different methods of connectivity and reduction. Taking materials that we otherwise are fond of, for example, cast glass. So we do a lot of research in that at TU Delft, and in particular, taking all forms of waste glass and finding things that we can do with those. As we know, in the building industry, very, very little of the building industry's glass is recycled. Less than 5% globally. I'm sure it's much less than that in the US. Most of it's finding its way into landfill or insulation. It doesn't find its way back into any form of a circular economy. That is clearly something that we need to address as an industry. We've got to be able to make more use of the material that already exists and that we're reusing rather than wasting it. One of these ideas is turning cast glass into a more usable product. That could be a modular system, or it could just be ways in which, in this particular example, where we were doing it for a recent installation by taking all of the sands around the world and combining it with waste and creating this installation, which is a sculpture, but it gives you the idea about what we can do with some of that material of the future, and getting more of that material, as I've said, back into the circular nature of what we are. This year's Glass Tech, which is next week in Dusseldorf, every 2 years this conference happens, which showcases not only, well, the majority of the glass industry, but this year its focus, of course, as is today's focus, is about innovation around the circular economy and what we will be doing with glass in the future. I encourage you to partake. If any of you are going to Germany next week, I'll see you there. But certainly this particular conference that's being led by Lisa Ramick, who looks after our office in the West Coast here in the US, an initiative that she set up with a bunch of people to ensure that this focus around glass, the circular nature of glass and what we do with it and its end use is particularly important. And finally, a website that we've set up recently, which is not related to us, but it's something that we've developed through funding that we've had from a particular benefactor. And this allows you or anybody to go onto this website into your local industry, your local area, and understand where you can therefore recycle your glass, whether it's your house, whether it's your building, whether it's your office building, and then it will start to build a network of where people will take your glass for it to be able to recycle, because that's largely part of the biggest problem, is logistical. And so we need to innovate in our industry. We need to keep pushing. We need to keep facing these challenges, and we need to find ways in which we can integrate all that thinking we've got into doing more with less. Thank you.
Thank you, James. And thanks for giving our industry such a unique and wonderful combination of structural engineering and glass pioneering. Very exciting. Our next speaker is Michael Bollan. He's Global Project Director for Axalta. Yes, Michael? There he is. Axalta Coating Systems is a global company specializing in the development and manufacture of performance coatings. And he's going to talk to us today about embarking on an architectural color design journey.
Thank you so much.
Thank you. Nice to meet you.
Good morning. As mentioned, I'm Michael Bollan. I'm the Global Product Director for Axalta Coating Systems. This is my first time at World of Façades, so thank you for having me. A little bit about my background. I started my coatings journey roughly 25 years ago as a engineer, materials engineer. Had the opportunity to actually design, install a coating systems, a spray systems. Got some experience with both liquid and powder coatings. From there, I guess I was bit by the bug of coatings and moved into sales and sales management. Came to Axalta roughly 10 years ago as a global segment leader. Got to travel the world, see many applications, many systems, many customers, and also had the opportunity for about 4 years to lead the Americas powder group. And then just recently, in the last 2 years, became part of the product management team. What we're going to talk about today is the project journey. I'm going to spell out some resources that we can supply as a coating supplier for you, the engineers, the architects, the designers. 4 key elements to the project journey. Project excellence, where we strive for excellence in every project and every asset to achieve quality and performance. Oops. The second is continuing education. This is our commitment for ongoing education and innovation. I think it's important when I get to this bullet point that we talk about the beginning, the middle, and the end, and beyond. Defining quality. This is not only the coatings quality, but the quality of the application. And what we do here is try to ensure that every coating meets the expectations for durability and aesthetics. And lastly, color effect and finish. Picking colors is difficult, and we want to give you the resources and the tools to pick the perfect color effect and finish. Project excellence. This is one area that we take a lot of pride in at Axalta. Our expertise in consulting of over 150 years of experience. We like to be involved in a project, I like to use the term early and often. As early as we can gain information and help you get the resources, information, whatever it may be. Do you have a preference on technology? Do you have a preference, what's the warranty expectation? Color, gloss, of course, but then performance. Where's the project going? Is it a high coastal environment? Is it dry? Is there special characteristics that we need to be aware of? All that ensures excellence the earlier we're involved in the process. And we get excited about that because the more information we have, the more we can give you that consulting experience. And it all starts with that collaboration. Continued education. We have a passion for learning at Axalta, both internally and with our partners. And we look at the education process as beginning, end, and middle in terms of being able to bring you along or bring your partners along in the journey for a project. And we have multiple platforms for education. Of course, there's no substitution for us getting together in person, but since COVID, the online platforms have really advanced and become really effective in bringing large groups of people all over the world together to collaborate on those projects. We have the ability to not only give you standard trainings, whether it be on a specific technology like powder or PVDF, on a specific topic like sustainability, which I've heard quite a bit about, and then also too, on demand. If you have a particular topic that you want us to develop a training for, we could do that and deliver that as well. Defining quality. Like project excellence, defining quality is another key point that early and often apply. Everybody has kind of a different opinion about what quality is, especially in my world, it's the finish. I can look at something and determine if it's poor quality because I'm looking at the finish, but somebody else might look at it and not know that the finish is an issue. I use an example on a building. You may look at the building and say that building is of poor quality, but you don't know why. You look at it from a finish specification or a defining of the quality, it could be that somebody liked a color, liked an effect, liked a finish from the interior, and without the information maybe needed, put it on the exterior and it failed. And that defined the quality as being poor. But we want to be involved in not only the product quality finish or defining, but then also the process. I think it's important when we get involved with the folks that are applying the coatings, the folks, everyone in the room here that would be involved in the project, when we get involved early and often and define those parameters, we won't get to the end and have surprises, which is the definition of a successful project. Pretty exciting to hear in the first few talks here today about sustainability because I have the pleasure of introducing a new product launch we had this year. It's our Alesta BioCore. This is the first powder coating manufactured with non-food organic waste as part of its resin system. What this does is you can achieve up to 25% lower CO2 emissions when compared to a product that uses fossil fuel in its resin system. So we're excited about this product launch because it is currently launched in Europe at Qualicoat level Class 1 and Class 2. We're working on Class 3. But the advantage of this product is all the same color families, performance characteristics, warranty, they transfer just like a standard product. So any of the products that we have today in any of the technologies and powder coatings, we can do in BioCore. We hope to launch, by the way, in the United States within the next year. And then, in conjunction with using the BioCore technology in our Alesta SD product, super durable, you can actually qualify for up to 8 LEED credits. Another aspect to the project journey that I want to talk about a little bit is the information we can supply in terms of technology. One key message I'd like you to walk away with is that Axalta, we have the ability to supply powder and liquid. And really, it's a preference, it's an education, it's an application, and it's really back talking about defining the quality. Is there a preference? Is one have the advantage to the other? Being able to supply both technologies, we can come up with data to make your decision-making process much easier. This is an example of a sustainability example where, when you first, common perception is, okay, what's the most green coating we can get? What's the most environmentally friendly coating we can get? Powder, right? No VOCs. It seems to be friendly in the environment because there's no solvents. But we had an example here where we took our Durapon 70 and we looked at in use with a thermal oxidizer. The thermal oxidizer is in the actual coating process, but that thermal oxidizer burns off the VOCs. That burn off is used to fuel the oven, which then lowers the carbon emissions. So in the end, when you look at the two technologies, they're very similar in their performance for both VOC and CO2 emissions. The last section here is color and effect and finish. So I'm glad I don't have to do this because choosing colors is overwhelming. There's a lot of colors and I don't know how folks do it. But we have assembled some tools that will hopefully make your job a little easier. The first is we have a BIM library where you can go online and download our color palettes, bring them into your projects, your modeling, and see what those colors look like in your project in use. The other piece is part of that library is if you look at the downloads, behind that is product information. We have the product information as well as the technical data sheets and the SDS. Another opportunity is in select regions, we have color experience rooms, if you look at the middle picture there. And these rooms are designed to have an in-person experience where you can look at a wall of color. You can bring in your materials, your whatever, flooring, siding, window, whatever that may be, and you can compare. And we'll have our experts there because they're in our facility and they can assist you. You can compare, you can take multiple panels with you. If there's a need for larger samples, we have the ability to order them up. The other thing that's unique about these studios is we've put in lighting so you can look at it under multiple light sources. I'll point out that we have our color design online where these color tools are all stored for easy and user-friendly access. And then we have lots of case studies. I don't have time to go through any of them today, but I heard through the other presentations, which is a nice segue into the case studies that we have. Globally, we've had projects. We can use these case studies and make these case studies available where you have similar applications, similar colors, glosses, performance, technologies, whatever you need. We can probably find a case study where we've had a successful project with our coatings. And then lastly, we have an annual publication called Vibes. And this is a comprehensive look at trends, colors, textures, psychological reasoning behind color, how it makes us feel, how it affects our influences. I encourage you to check that out. And that's good. If you have any other questions or would like to talk further, please see us at the tabletop. Thank you.
Thank you so much, Michael. Very interesting. Our next speaker is Matt Capone, and he's eager. I like that. Come on up. Matt is a principal at FacadesX. FacadesX is a firm specializing in innovative facade design and engineering solutions for modern architecture. Thank you. You're going to do for us a pechakucha.
Yeah, we're going to go
Right.
quick. We're going to get off to coffee and conversation.
Right. So does everybody know what a pechakucha is? Can you explain this? You want me to explain? It's pretty
It's
cool.
basically a
Quick.
Japanese rapid fire of slides and conversation and mostly images. So
Great.
we're
Thank
going to
you.
go fast. Thank you, Kimberly. My name is Matt Capone. I'm the owner of FacadesX. We represent manufacturers from around the world in facades, cladding, even some skylights. So we're going to go on a quick journey. We're going to go overseas. We're going to take this boat and we're going to go over to visit a couple of our manufacturing partners in Germany, Tonality, porcelain facade, terracotta facades, and Lamilux, high performance daylighting solutions. So before we actually go to Germany, we're going to go to Italy for a little bit and talk about daylighting. 2,000 years ago, daylighting was important, obviously here. This pagan temple. All of you know this as the Pantheon in Rome. So the oculus is this 27-foot wide hole in the roof. Important feature for daylighting. Probably not the most efficient use, right? Because obviously we need high performance. Back in 1975, you could actually walk up on the roof of the Pantheon with very little support or assistance and do your thing. So talking about this, it's actually known that the interior of the building gets very cold because of the thermal mass inside. And so on a warm day, the roof will heat up. It will actually suck you into the hole. So dating back to the 1800s, some people were sucked down into this. So you have to pay deference to the oculus, to the eye of God, to get up there. So pretty interesting. And then you actually have to get back down. So we don't allow this anymore, although I would love to do it. So basically, we're talking about daylighting, skylights, round skylights. This is something from Lamilux. They're very simple, efficient use of material and installation. So they have a triple pane solution for round, for square, for rectangle. Basically, simplicity and elegance in daylighting for high performance. And most of the products also come with basically a built-in upstand that flashes into the roof. So we take elegance, we take high performance, and we make it easy to install. And this is something that Lamilux is well known for around the world. And so a very simple opening here can be very well done and repeated in various colors, glazing. And actually, this is something we have on the boards. We're working with Seldorf Architects. Perhaps in ode to the Pantheon, they're doing a round oculus type skylight over one of the spaces at the AGO Museum in Toronto. So we just got the order for this. So this is in the works, and I hope next year to show some images. So Lamilux does round standard, round custom. So talk about advanced engineering, advanced thermal performance, in-house design teams taking care of all of the metrics, performance data, and all the engineering, all now NFRC certified and supported here in the US with lots of projects. But Lamilux is an example of really taking a small niche and perfecting it. So they're not just round, they could be square, they can be rectangle, creating beautiful spaces. In commercial, so these are typically modular type units, but also completely custom glass roofs. So complete solution, again, high performance as can be, and truly tested over time. This is at the BMW headquarters in Germany. So quick dive on daylighting. And we're going to go over to Frankfurt and visit our terracotta partner. This is an iconic building known as the Wave in Denmark. And so these are really flat, slat terracotta panels. They're made out of natural materials. So this is actually the hole the material comes out of. Looks like a big pile of dirt and clay. It is. This factory, this hole actually is very large, and it's actually only about 2 miles from the factory where all the material is refined and utilized. So if you have close proximity, you start to get, as James was saying, more with less, right? So more with less is really about best use of material. If you look at sort of a typical arrangement of what we know as terracotta, this clay in Vestfold is actually known as some of the finest clay in the world. You can see it's very dense, very consistent. So when you have the excellent raw materials close to you and you're able to create with efficient modern production, again, it's more with less. And so this machine is spitting out planks. These planks of terracotta are actually, because of the clay, because of the manufacturing process, because of the system, very efficient to build with. Integral hooks in a single wall system. The absorption criteria is very, very low, and so there's no water absorbing into this material, and essentially you're getting a forever facade, forever material that is really highly refined and a very simple kit of parts. And so this system looks very simple and in effect is, so it's very easy to install, easy to kind of understand, but it doesn't need to be just flat, doesn't need to be just plain. So we have ability to do things with depth within a single wall system. You can see here how the hooks are actually built into the tile. So you're actually getting integrity in the top and the bottom and the middle. So we have lots of projects in New York City and on the boards. Tonality is a great system. So actually EPD, to talk about environmental declaration, we have published data of about 18.5 kilograms per meter squared. That's in Germany. You bring it over here, we're talking about 20, 21, 22. It's very low and actually, I would say, best in class for what we can do here with this material. So all custom glaze potential at the laboratory. We've had architects come over from New York City to demo the factory, also work with the lab and create custom glazes. So unlimited possibilities, but within a kit of parts. So it's custom, yet we're still dealing with a very, I would say, finite depth to deal with. So come visit us and check out what we have at the table. A couple different references here, but we're doing projects at scale. All testing is complete, and we have some really great references. So it's just about what we can do best with material, and our journey ends with something that we're cooking here. We're actually working with some German technology and previewing this and bringing 3D capabilities over to the US with a factory in the Midwest. And so we're actually able to do anything, yet our first project is actually replicating bricks. So there's some irony in that. I don't quite get it, but that's what we're doing. So I appreciate your time. Let's get some coffee, some conversation going. This is my partner, Gus, over at the booth. Go visit him, say hello. He actually just turned 50 like last week, so wish him a happy birthday, and thank you very much.
Thank you, Matt. Doing more with less. Music to a developer's ears. Thank you for that. Appreciate it. So, ladies and gentlemen, that concludes our first session, and we will take about 30 minutes. If you could come back here, within the half hour, so we could get started, and I can keep your afternoon on schedule. Appreciate it. Coffee out in the pre-function area. Thank you very much. Hello, everybody. Welcome back to session 2. Hopefully, everybody had some time to chat and to network and talk to some colleagues and check out the interesting items we have outside there and have some coffee and tea. Let everybody grab a seat. Session 2 today, we've got Heintges, we've got Big, and a couple others, as well as the Department of Buildings at the end, which is going to be very exciting, actually. It will surprise you. I'm not going to tell you what the subject is because I'm actually very interested in this, and I invited a few of my colleagues from the development industry to be here today for it. So a few more minutes, everyone's coming in, and I would like to welcome up Jamison, guest, and Ryan Hansen. Jamison is a renowned consultancy. Heintges is a renowned consultancy specializing in building envelope design and facade engineering. They have extensive experience managing complex, high-performance facade projects. And our team members today who are going to present, Jamison and Ryan Hansen, 3D thermal analysis for building envelopes, approaches to progressive energy codes. Did I get that right? It's probably up here. Welcome.
Thank you to the organizers for inviting us to speak this morning. I'll start by introducing Heintges. We are a firm of architects and engineers specializing in the building enclosure. And for over 35 years, we have focused exclusively on the development and implementation of high-performance building envelope systems. And we are very proud to be a certified WBE women-owned business enterprise. Our work crosses virtually every sector, from commercial to institutional, residential, retail, and government projects, new building construction, recladding and renovation, additions and expansions, storefronts, and entrances. We are full-service enclosure consultants engaged in projects from concept design through construction, including materials research and glass selection, analyzing and rationalizing complex geometry, system design and detailing, structural and thermal engineering of envelope systems, roofing and waterproofing, as well as building enclosure commissioning and inspections services. To cite a few examples of our projects and collaborations with the firms listed. The United Nations campus headquarters renovation, where we served as enclosure consultant and design architect of record for the renovation and replacement of the historic facades. 66 Hudson Boulevard with Bjarke Ingels Group and Adamson Associates Architects. 270 Park Avenue South, JP Morgan Chase's new headquarters with Foster and Partners and Adamson Associates Architects. The New York University Paulson Center with Kieran Timberlake and Davis Brody Bond. Brown University's Integrated Life Sciences Building with Ten Burke in Providence, Rhode Island. 585 Kendall with CBT Architects located in Cambridge, Massachusetts. MIT Site 5 with Weiss Manfredi Architects and Perkins Eastman, also located in Cambridge, Massachusetts. And One Congress Project with Pelly Clark and Partners and CBT Architects in Boston. So to begin focusing on today's topic, since the Lawrence Berkeley National Laboratory introduced two-dimensional heat transfer analysis software in the late 90s, we have provided this type of analysis on our projects, enabling architects and owners to better understand the thermal performance of enclosure systems and to assess the risks of condensation. Today, we will discuss how increasingly stringent building codes require more detailed and three-dimensional analysis of heat transfer at complex enclosure conditions, and how undertaking this more accurate and more rigorous analysis actually benefits architects and their projects and their designs. What is thermal bridging? When we work with architects to develop an enclosure system design, at a very early stage, we identify potential thermal bridging. Maybe it's due to exterior sunshades or fin brackets, or soffit roof parapet conditions resulting from building geometry. Current software allows us to develop analysis of these conditions that then informs the design details and performance specifications we deliver to architects and owners. It's worth noting that we're also regularly using these tools to analyze existing conditions on reclad and renovation projects. I, at this point, want to turn it over to my colleague Ryan Hansen, who has been focused on this area of study and research since joining our firm. He will dive into some of the specific changes to building codes that are driving this more detailed and more accurate thermal analysis, with some examples that illustrate how we are using three-dimensional thermal analysis on our consulting projects. Ryan.
Awesome. Thank you, Jamison. So I've had this notion of thermal bridging as a clear penetration through an insulative blanket of enclosure, like those sunshades or brackets or exposed framing or uninsulated edges of systems, or simply a lack of thermal breaks, which open up a path of least resistance for heat energy to flow through. And as best practice, these are often identified and broken with shims or packed insulation. In the progressive energy codes that I'm going to be discussing today, these thermal bridges have been abstracted in order to cover a whole range of conditions that happen in this building. So a change in plane, an intersection of geometry, a transition to another system, things that you would not really call out as a blatant thermal bridge, but the code identifies as something that needs to be accounted for and used to derate the performance of the system because it can bleed out extra energy. So in an architectural spatial sense, these anomalies in the system may define design features, but in the code, they are opportunities for heat loss, and they need to be used to degrade that performance. So let's look at two progressive energy codes. One is New York City. The New York City Commercial Energy Code currently only requires the documentation of thermal bridges, so identifying them in drawings as three different types, so clear field, linear, and point thermal bridging. Massachusetts definitely goes further. In the 2023 stretch code, thermal bridging values have to be identified and used to derate the performance. So if a building has a target U value, that U value needs to include all the heat loss due to thermal bridges. So there's a fairly simple calculation that needs to be done to find this derated performance. And this is from the BC Hydro Thermal Bridging Guide. First, we calculate a clear field U value using 2D tools. This takes into account repetitive bridging elements like clips and framing and tiebacks, and this results in a heat loss over an area. Linear bridging is different. It is heat loss over a linear element, so heat loss over linear foot. And because the interactions here of assemblies is more complex, you often need 3D analysis. Similarly, point bridging is heat loss at a particular point. And if it's repeated across the building, that chi value is multiplied for every instance. So in the Massachusetts stretch code, you have a couple of options for finding these psi values, which is linear bridging, and chi values, which is point bridging. You could take a value directly from the code, from this table. You could reference a value from a catalog of analyses, which may or may not be really relevant to your system. Or you could do what we've done and model the actual values. So the basis for the 3D thermal analyses that I'm going to be discussing is this commercial building in Cambridge, Massachusetts. It is a unitized curtain wall enclosure with triple glazing and terracotta rain screen at the spandrel. So let's look at what these thermal bridging types would look like on a standard unit. So here's a standard unit with that terracotta and glazing. In a clear field analysis, repetitive clips that hold the terracotta are accounted for in 2D analyses, which I think we're all familiar with. And these analyses give us little U values that can be incorporated into a NFRC total U value for the unit, and that can be applied across the whole system. Linear bridges acting on this system may be a parapet capping the system, or a soffit coming to the underside of the spandrel. They could also be a transition to another system or a stark change in geometry. And point bridges on this system may be a slab anchor, or say a signage bracket coming from the framing, or simply a pipe penetration through the spandrel. So how can we use 3D tools to find these bridging values? Let's focus on that slab anchor. It always occurs at the spandrel, so we will focus on the spandrel for our analysis. We're also going to center our analysis on the unit splice. So defining the scope of the 3D model is a question of what's representative. So we will use the whole width of the unit. And it's also a question of how much of an impact the thermal bridge will have on the total system. So we'll make it tall enough so that that change in heat flow can normalize in the system. Like a 2D model, we'll also include frame cavities and interior and exterior boundary conditions. Because this is a U-value type analysis, we are going to keep these boundary conditions at NFRC standard temperatures. In other analyses for condensation, you could use custom temperatures. And like therm, which is the industry standard for 2D analysis, this is a steady state analysis. So we will assume that the boundary conditions are held at a steady temperature and heat is allowed to flow through the system. So running this model through a 3D thermal analysis gives us this output. It's a map of the temperatures across the surface after heat is allowed to flow through completely. And we can see that on the interior, where we have colder temperatures, that is where heat is flowing through more easily. So that slab anchor is definitely conducting more heat, but it's not nearly as much as the mullion, the aluminum mullion, was already conducting heat. And when we look inside the system, we can see that that point of least resistance for heat to flow through, coming through that mullion and those terracotta clips. And it's even more prevalent when you can see the isoflexes acting in the system. So those aluminum clips and that aluminum framing are really apparent here. But the end result of this analysis is fairly simple. It's just a total of the heat that has flowed through the system. So in watts or BTUs per hour. And to get the chi value in this instance, we really need to find a delta between a control case, so in this case a spandrel with a slab edge but no anchor, and then when the anomaly is introduced. So we'll introduce that slab anchor and find the difference. In this case it's less than 4 watts and the chi value is 0.162. And we'll multiply that for every unit on the building. So a linear bridge that needs a similar analysis is this soffit condition. So the colder temperatures that are flowing through the bottom of the system, they're conducting through the aluminum framing and the galvanized backpan down to the bottom of the system where there's less insulation. So that's a very clear bridge that we can calculate. And it's important here to compare apples to apples here. So we're only going to compare the heat flow coming through these equivalent areas. So that's something that you really have to judge for every single case of what's an equivalent area when we're analyzing. Another linear bridge that might act on our system is this parapet condition, where we have a terracotta rain screen that is wrapping into this terrace rather than going up into a glazed curtain wall. Now, this is a really unique case because the control case already has a thermal bridge acting on it. It's this uninsulated mullion that is protruding through this mullion wrap. So when the parapet is introduced, the change in heat flow is really not that much because there was already a lot of heat flowing through the system. So this is a question that we're really interested in our research groups is there a propensity for heat to flow through a system through those points of least resistance, where insulating and cutting off more and more bridges can have a diminishing return. So in this case, the psi value is fairly low because of that existing bridge. After all these models and analyses, they are totaled into a backstop, which is an area-weighted tally of system U values, with a goal of a total building U value. In our case, the end goal was 0.160. There are other systems on this building that perform a little bit better, so in this case, we could do a little bit worse than that target. But at the top, we have our clear field U values for those systems. And at the bottom, there are these thermal bridging values, which are taken from direct analyses or referenced from catalogs. So summing that heat flow derates the system U value. And it's useful to see what impact these bridges have on the total system. So you can see on the right that that impact is fairly low when we model them. But what if we were to use only prescriptive or code or reference values? The impact on the U value is really significant. So there's a clear benefit to a more thorough analysis process. Being accurate about those bridges, being honest about them gives us more flexibility with our design. So let's look at some other cases for 3D modeling that we've seen in our work. Apart from code compliance, our firm is really invested in analyzing condensation resistance. Many of the projects that we're involved in have really onerous criteria, like museums, healthcare projects, or even vivariums. So in this case, a shingled, stepped, unitized curtain wall was analyzed, and we found a lot of condensation potential at the mullion, jutting in through the mullion and the stack joint. And we were able to zoom in and into the stack joint assembly and cut off a thermal bridge because of this. And looking at this analysis, it's really interesting to see a confluence of heat flow coming through two pieces of framing jutting into each other. And that's something you don't really understand when you're drawing it in 2D. There's this 1 + 1 = 3 type of heat flow. In this case, we were analyzing this spandrel condition to figure out whether or not a mullion wrap was required in this ceiling space. In this condition, we were looking at a steel beam holding a canopy, and it cut across multiple systems. And we used 3D analysis to understand the effect of adding rigid insulation on the outside of this steel beam. Similarly, we also looked at how this HSS holding this brick rain screen may or may not have to have a thermal break or a shim connecting it back to the structure. And it was found that taking away that thermal break actually didn't create condensation. So that was a savings for the project. So what's the benefit of these tools for us designers? This rigorous analysis is not just a tool to comply with code. It gives designers the power to be more flexible and creative with their systems and to not be penalized by using generic values in our analysis. 3D modeling is becoming a standard, and it's pushing us to be more and more efficient with our designs. As that analysis gets more sophisticated and our energy and insulation requirements get more and more stringent, we need to consider a balance in our approach to sustainability. The question is, what's the end goal? Is it really carbon reduction? And that includes embodied carbon and operational carbon. If so, will spending a ton of carbon on extra insulation really save us a ton of carbon in heating the building? Especially when the building's mechanical system is already designed to work with less insulation, like a lab building that is constantly sucking in fresh air. On the other hand, what's the impact on resilience? Are we okay with our enclosure protecting people when heat is lost for days on end, especially with enhanced storms and a precarious energy supply? These tools like 3D thermal analysis can help us go further than the code. They can make us better decision makers for our systems, for our materials, for our building sites and geometry. And they can help us find a balance in our sustainable approaches in the right direction of net zero, in regenerative, and healthy buildings. Thank you.
Great. Probably one of the more technical presentations I've seen yet today. So thank you very much, Ryan. That was great. Our next presenter is Jordi Marasse. He's a technical project consultant at Rayners Aluminum. And Rayners is a leading provider of innovative aluminum solutions for the construction industry. You've probably had an opportunity to see their table outside. In his role, Jordi works closely with architects, developers, and contractors to offer technical expertise on design and implementation of high-performance aluminum systems for facade, windows, and doors. Welcome.
Thank you.
Jordi is going to present Improving the Living of People Now and for Generations with VR.
Hello, everyone. My name is Jordi Marasse. I'm working in the team of Rayners North America, managing the projects department. We're all here today to discuss and understand various advancements in the field of facade design and engineering. I'll take a minute to explain how we're implementing virtual reality into our day-to-day workflow in projects and with collaborations and stakeholders in projects. But first, I recognize that for many of you, this may be an introduction to Rayners, so I'll just take a brief moment to explain who we are. First of all, Rayners are a world-leading specialist in the design, development, and marketing of sustainable aluminum solutions for the building envelope. There are lots of other words you could use to describe Rayners, but very first and foremost, what we want to emphasize is that we are a family business. The company was founded in the 1960s by this man in the black and white photo, Jan Raynars. Jan was fabricating and installing his own aluminum systems. His system started to gain a lot of traction in the Flemish region of Belgium, where he's from. A lot of companies nearby, competitors even started to reach Jan and say, Jan, I really want to work with your product. I like it, but prefer to buy profiles, hardware, accessories from you and handle the fabrication parts myself rather than buy the complete window. This gives me a little bit of flexibility, responsiveness for my partners. That's kind of how the idea of Rayners as a system supplier came to be. Unfortunately, some 7 or 8 years after founding the company, Jan died very tragically in a car accident, leaving the company to his 5 children, who you see here in the photo. The eldest was Martine Raynars. That's the lady sitting on your right in orange. Martine was 17 years old at the time of her father's passing, so some family friends had to step in and help run and maintain the business essentially until Martine graduated with a law degree in her early 20s, at which point she took over the company as CEO and really built it into what it is today on these 4 pillars: innovation, excellence, loyalty, and respect. Our mission is to improve the living and work environment of people now and for generations to come. We blend design, technology, and digitalization into innovative solutions that add value and inspire our partners. Our partners are, of course, the fabricating clients who work with our systems, but also homeowners, architects, developers, engineers, general contractors, basically everybody associated to the project chain we consider as partners of Rayners, which is why our motto is Together for Better. There you see basically the global footprint of Rayners. Indicated on the map is our campus headquarters. That's in Duffel, Belgium. But we do have lots of other facilities, very global presence now, legal on-the-ground entities in 48 countries globally, and sales in 82, last that I heard. More than 5,000 fabrication partners globally, more than 2,600 employees, and an annual turnover of approximately $830 million US dollars. This is basically the trajectory of the company since Martine took it over. 1986, 15 million euros to 20 million euros, let's say, an annual turnover. By about 2010, we're approaching 300 million mark. That's the point at which we took the decision to go global. And you can see really the exponential impact it's had on the company since. The revenue is, of course, generated by products, a very wide range of products. Those of you who've engaged with our product portfolio in the past maybe know it's extremely extensive, so I prefer not to get too much into the weeds. But very generally speaking, windows and doors, everything from your economical solutions for elementary schools up until passive house insulation levels, large dimensions, ultra slim sight lines, it's all possible. Sliding systems, ultra minimalistic sliding systems, large format lift and slide doors with ultra high performance, facade systems, stick facade curtain walls, unitized curtain walls, window walls, etc. Of course, we have our catalog off-the-shelf products, which I just explained, but also about 30 to 35% of our business globally currently is in bespoke and custom solutions for projects. That being the case, we have a team of over 100 engineers and designers who are busy every day improving the existing systems, developing new ones, and working on these custom developments for projects. Of course, we live in the construction industry, a very highly regulated world, as you all know. So everything we do has to be tested, retested, validated constantly for every local market we're supporting. That's why we took the decision to invest in our own research and testing center, which currently exists as the largest research and testing facility in the private sector of aluminum worldwide. We're doing all manner of testing in-house, air, wind, water, seismic, acoustic, impact, so on and so forth. Basically everything excluding bulletproof, fireproof, and bomb blast for maybe obvious safety reasons. We do also work with local labs to test our products to supplement what we're doing at the facility in Belgium, but we want to work with partners. We don't want to rely on partners, and we want to address bottlenecks wherever we can find them in the company. Reliable network of fabricators, some of whom I see in the audience just in front of me. For the fabrication partners, we're offering more than just a product, windows, doors, profiles, etc. We're really trying to offer a complete ecosystem around the production of the products. So that's software that does design, engineering, calculations, orders, software that links our fabrication partners to their dealers, so the dealers are empowered to produce their own quotations linked to the fabricator's estimation data so that they're not burdening the fabrication partners with seas of quote requests, etc., etc. But like I explained, we don't just consider the fabrication clients who work with our products as partners, we also consider all of the project stakeholders. So we're also busy every day developing solutions, softwares, tools, platforms designed to improve the working collaboration with those stakeholders. And one such example is Avalon. What is Avalon? Basically, it's a virtual reality cave built to design or built to optimize and enhance the working collaboration of stakeholders and projects. Virtual reality is not a new concept. It's been with us approximately a century, let's say. Basically, it's just two images placed at differential depths. Your brain works to fill in the rest and give it kind of a 3D spatial realism if you want. There are many devices you can use for purposes of virtual reality. Architects in the crowd, maybe some of you are working with such devices or have worked with such devices in your architectural practices to date. We also explored utilization of such devices, but ultimately we felt that they were too limited in one extremely specific way, which is that they are too immersive, but for only one perspective. As you know, the project landscape, it involves many, many collaborators of many different backgrounds, some technical, some non-technical. And if that collaboration is not managed correctly, it can result in problems. With such a device, you end up sharing these goggles back and forth all over the place. A lot of guidance is needed. No, your left, my left, up and down. It's a very tedious, frustrating process if you've ever had to do it. We really wanted to take it a step further and bring these perspectives into one environment to enhance collaboration. So we started to investigate the concept of the cave. The cave is also not a new concept. Basically, it's used most predominantly in the automotive and aerospace industries for virtual prototyping of vehicles. What's different about the cave is that you're standing in a room. Essentially, everything around you is a screen, powered in the back by very expensive laser technology. You're wearing see-through glasses. You're standing in the project looking at it in a proper perspective and in proper scale. But essentially, I can look at you, and you can look at me, and we can look at the detail together. We can have our discussions and arrive at decisions in a highly informed environment. And that's our virtual reality cave, Avalon. I'll just let a small video explain a bit more.
Welcome to Avalon, a space to explore architecture through a shared virtual reality experience. Did you ever wish you could walk into a building that is still in the design phase? Avalon can take you anywhere you want. 25 projectors make architectural designs come to life in unequaled resolution, with cutting-edge laser technology creating the most vivid colors, contrast, and brightness. Active 3D glasses create a natural spatial awareness, and as a user, you are instantly immersed in a true 3D environment that creates an incredible sense of scale and depth. You are able to share the experience with your partners, allowing you to discuss and evaluate your projects before they are built. Avalon is a collaborative working tool, offering a joint experience between architect, contractors, investors, engineers, fabricators, and Rayner's experts. Virtual reality is set to play an important role at all stages of the architectural process, from evaluating design options and showcasing proposals to detecting construction issues before breaking ground on site. Starting at the conceptual phase, VR has proven to be effective in exploring the relationships between spaces. VR gives you an immediate feeling of being inside the building. You can experience the impact of light on a room, or evaluate the different interior viewpoints. The spatial realism makes Avalon an incredibly powerful tool to communicate design intent. When the architectural design is further specified, BIM files are effortlessly translated into VR, providing architects with even better tools to communicate about their choices and improve their designs. Enabling architects to effortlessly move between BIM and VR truly revolutionizes the way buildings are designed. Avalon allows you to explore your projects inside your usual design software. Its powerful main workstation handles 3D models produced in any commonly used software in the architecture industry. By tracking the visitor's movements, real-time rendering engines create the ultimate VR experience, from initial sketches through detailed technical models and realistic scenes. Before your visit, you provide the 3D model of the project. In consultation with the building team, the objectives are set and the model is adapted accordingly and prepared for VR. Different options can be prepared to compare several Rayner's systems, configurations, bespoke solutions, or specific design variants for your project. Avalon is perfectly suited to create diverse virtual mock-ups. You can make sections, explain complex technical setups, or examine specific construction details or project solutions. This new way of virtual prototyping reduces costs and increases efficiency drastically. The high-resolution real-time renders allow you to see every detail so you can experiment with different configurations, evaluate simulation or BIM data, and further improve your design. You are able to experience Rayner's systems up close and compare the different solutions for your project. Discover Avalon, the space where future projects become a reality.
So why is it that ultimately we felt an investment such as Avalon, by the way, 7 to 8 figures, something like that, would have value to our stakeholder partners and to the industry at large? Was really for two major reasons. Number one, avoiding mistakes. So there are lots of studies that indicate approximately 80 to 90% of mistakes are what you would call stupid mistakes, or avoidable mistakes if you prefer to be kind. Yeah, basically, if the right people were looking at the right thing at the right time, they would have been caught. But because the project landscape is so dynamic and fast-moving, so many collaborators of different backgrounds and so many different time objectives, ultimately things get missed and result in problems kind of like this Photoshop on the screen, at least I hope a Photoshop. The second one was expediting, making better and faster decisions. Like I explained, projects involving lots of collaborators, many different backgrounds, technical, non-technical, financial, etc. Sometimes I've experienced it firsthand, working in projects that collaboration of the stakeholders is not necessarily aligned in terms of the objectives. Maybe the architect wants one thing, the developer another. It can really bog down the decision-making process. So inviting all of these perspectives to the table at once to assess and evaluate options, we find really helps to expedite that process. Yeah, we've boiled it down to basically 3 types of evaluation we're doing within Avalon: concept evaluations, technical evaluations, and high-quality design evaluations. I will take you through a couple of real-world examples to help kind of underscore how we're using these evaluations to support projects. So this is a very simple, quick, early concept evaluation. Oftentimes, we're involved into projects in very early design stages. Maybe there's an idea of what the building wants to look like, or maybe there are several different concepts of what the building could look like. And the stakeholders are trying to understand what that building would look like within the context of the city, et cetera, neighboring buildings beside it, et cetera. We can very quickly and very easily model that within Avalon to show the stakeholders. This is an example of a technical evaluation from one of the FIBA World Cup stadiums that we did together with our partners at Zaha Hadid Architects. Yeah, you can see not a lot of glazing on the building. We did provide curtain walls, windows, and doors to this project, but that is not why the architects wanted to visit into Avalon. Why they wanted to visit into Avalon was to basically sit in various perspectives in the arena and try to understand what the spectator would see and feel in reality from those various perspectives. Based on what they saw within Avalon, they adjusted angles, inclinations of seats, moved some stanchions around, etc., to really try to optimize the field of view for all of the spectators, both in the upper and lower bowls. Additionally, there was a big service maintenance bridge traversing the entire arena. This was to service a large retractable roof, which opens and closes over the building. And the architects really wanted to walk on this bridge and try to understand all of the related safety aspects. Were people safe working up there? Would they feel safe working up there? Were there any liability concerns associated to the design? They wanted to understand within Avalon. So they walked it. Essentially, they decided if we can do it, then somebody else can too. Yeah, virtual visual mock-ups. So this was a topic that I would say ticked way upwards during the early days of the pandemic. We saw a lot of projects looking to address inflation-related costs. And one of the first places they looked to do this was on visual mock-ups, which can be expensive and can be time-consuming. What we can do within Avalon is we can take shop drawings of the various trades and we can build one-to-one the visual mock-up within the virtual space much faster and much more cost effectively. I'm working, for example, in a project in Toronto right now, a large residential mixed-use tower where the visual mock-up the architect wanted was costing the owners $2 million. We looked at this, we said, guys, it's an entirely custom system. By the time we can get this visual mock-up prepared, the amount of decisions you're going to be able to make, it doesn't justify the value. So we're now doing approximately 80% of the visual mock-up within Avalon, and we've scaled down the VMU to now $1 million mock-up. So just the presence of Avalon has saved the clients in this project $1 million off the bat. This is a residential project we did in Netherlands, kind of a tale as old as time. You have one wind load at the bottom of the building, one wind load at the top of the building, the tire. The windows are now calling for reinforcements for inertia over the span. And there was a big fight between the project stakeholders, the architect and the developer. Basically, the architect said, absolutely not. You're not putting this reinforcement on the outside of my windows. You're going to destroy my entire facade. What are you doing to me? The developer said, absolutely not. The reinforcements can't go on the inside. I didn't sell this to my tenants. What do I do about the blinds? It's going to mess up the interior space, etc. This went on for weeks until we invited both stakeholders into Avalon. We rendered the interior and the exterior of the building with reinforcements applied on the windows, both spaces. We stood the stakeholders at the bottom of the building. And from a respectable distance, the architect looks up and he says, okay, now show me with the reinforcements on the outside of the windows. And we said, Mr. Architect, they're already on there. And the decision was made like that. Okay, the reinforcements go on the outside of the window. See, sometimes putting things into proper scale, proper perspective can really help to address concerns or perceived concerns from 2D CAD sections, etc. We also rendered the interior spaces with different furniture, big tables, small tables, because they were in Avalon, and why not? This is a project, it's called Quad Central. We completed recently in Malta. The topic on this project was that it was the largest project being developed in Malta and in its history. We, working as a supplier designing the facade, had a lot of concern about what would be the quality of the workmanship on this project, in particular as it related to the concrete formwork, because every contractor on this project, it was their first time doing something like this. And as you can see, we had a unitized facade system, structurally glued, installed to the outside of the slab, that seamlessly blended into a window wall system installed between the slabs. We had curved corners with hot bent glasses, etc. The vertical alignment of profiles from the unitized portions to the window wall portions, etc. all had to be perfectly aligning. So that concrete formwork was going to be playing a critical role in the design of the system. We had foreseen of some potential challenges and solutions to address those challenges into our design concepts and into our price. At one moment, our fabricating client, he called us, he said, "Guys, I have a problem." He said, "I'm going after this project, the developer's gonna award it in about a week. My Turkish competitor, he's coming about 20% less than I am, and I'm having trouble to justify to the owner, why does my facade have more value to him?" So what we did, we invited the investor into Avalon. We explained to him, a non-technical guy, all of the technical concerns we had related to the project. We showed him how we plan to address those concerns on the projects. Also, how we were planning to implement our integrated zero sightline curtain wall vents, as well as the integral sliding panels into the facade system to give additional aesthetic impact to the building. And immediately he understood it, that a lot of guys were throwing numbers at the table, but this was a really preconceived concept. And because of the trust we developed with the investor in the room, the project was awarded before he left. This is Quatuor in Brussels, Belgium. It brings to light, I think, another topic we're hearing quite a lot about today, which is that, in facades, I think we're all tired of looking at aluminum and glass boxes. Also, regulation changes are coming and pushing forward the use of new and more different materials. This was such a case. The architects wanted to work with an aluminum structurally glued facade system, prefabricated, but also a soft architecture expression working with natural stone boxes on the outside of the facade. One of the topics for us is that the presence of the natural stone boxes were going to obstruct what would be a natural glass replacement on this building to the outside. So we had to propose basically a bespoke cassette system which would allow for replacement of the glasses to the interior of the building. And we were able to kind of demonstrate the entire constructability for all of the stakeholders involved in the chain, as well as the serviceability aspects, and go through that step by step. This is another concept evaluation we can frequently do. You have your building. Maybe it's a residential building with some balconies. You don't know what you want to do on them yet. Is it, architects likes this one with the sliding door, huge glass side light. General contractor says, how am I supposed to replace that on the 20th floor when the service elevator's gone, et cetera, et cetera. Maybe it's going to be a balcony door, split side lights, pivot door. There's so many options, right? So we can go really 1, 2, 15 different options if you want. Invite all of the stakeholders into the room and discuss all the feasibility related aspects. And if we have a fabrication client on board, we can even put a price to each one. Say, here's your 10 different options, Mr. Investor, pick one. This was a project we did just outside of Brussels, Belgium. Basically, it was an older historical industrial building, working with old steel windows, crossbar patterns. I think you're quite familiar with this in New York. The windows were protected by heritage, so we couldn't really redesign them to get rid of that crossbar pattern. But this was being developed into essentially office spaces for rental, sort of like a WeWork kind of thing. And the developer was really concerned because of the presence of the crossbar pattern. What would be the impact of light in the room? Would that light be disruptive to people trying to work in there? Would he ultimately find people that were willing to invest in working into these spaces, or would they ultimately find it too cumbersome? So what we can do is, based on the project location and using Google Earth data, render the path of the sun and render that light into the room at 10 a.m., 2 p.m., 4 p.m., and so on and so forth. And then additionally, we're also doing our own internal system developments, kind of like I explained for the car and the aerospace guys. Everything we're doing, we do now within Avalon to understand the systems before we cast any dies or extrude any profiles, etc. So yeah, everywhere we go, we hear that what makes a successful project is successful collaboration of the various stakeholders. Our motto is together for better, and I think that Avalon really helps to underscore that mentality. I would invite you, if you have any questions, to come by our booth and meet some of our North American team. Thanks.
Excellent. Thank you so much. I do have to say, I have a couple questions before you run off. No, not really. I am going to offer up the audience if you guys have any questions. My one question is, you know, it's an interesting setup, and if I'm a developer, owner, and I love the idea of the cave, right, from a virtual reality perspective. You're ultimately saying that it does save, you know, money in the end if you have a target goal. But how much time, in your experience, does that take from the architects and the consultants on the back and forth and setting up? They have to give you the model. They have to insert their design. What do you see in terms of that from, you know, that's important from an owner's perspective?
It varies depending on the objectives we're setting with the project stakeholders. Like for that early concept evaluation I showed on the screen, I've done several buildings like this, sometimes within less than a week time frame to turn around that render. If it's the case that we're in a design assist scenario and maybe there are 10 to 15 different areas on the building we're trying to really dig into, understand, or demonstrate to the investor group, for example, that can take a little bit more time. It all depends on the quality of the files we receive in the first place. If we have to adapt from, let's say, a 2D AutoCAD set of shop drawings, we're then taking that, building it in Inventor in 3D before we can put it into the 3D space within Avalon. That takes a little bit of time. But generally we say, if you give us a month to 6 weeks, we can do a very complete visualization, including animations even. There are some files we have now that they're so advanced. You walk up to the creek and there's a little fish that goes swimming randomly by, or a breeze that blows the trees.
Cinematography.
Yeah, exactly.
Thank you.
We can really make it as expansive as you want.
Thank you so much. Very interesting. If anybody else has any other questions, I'm sure that he will be around for more. So our next speaker is actually our architectural keynote, our second architectural keynote. Daniel and I know each other pretty well. Daniel Sundlin from BIG. We work together closely on Tishman Speyer's Spiral, 66 Hudson Boulevard. Daniel is one of the world's leading It works for one of the world's leading architecture firms, BIG, known for innovative and boundary-pushing designs with a focus on creating architecture that balances sustainability, creativity, functionality. Daniel plays a pivotal role in shaping the firm's global portfolio of cutting-edge projects. And I'd like to say Spiral being one of your most notable ones. Welcome, Daniel. He is going to present Wildflower Studios, a vertical media production village in the heart of New York City. Come on up.
Thank you. Thank you, Kimberly, and thank you, everybody, to join today. My name is Daniel Sundlin. I'm trained as an architect, and as Kimberly said, I'm a partner at Bjarke Ingels Group. We are a interdisciplinary architecture firm based in Dumbo. We're originally from Denmark. We're about 200 designers, engineers, architects working together to realize projects around the world, and predominantly here in the city. I'm really excited to be here today because I do think, like, historically the architect used to sit and draw on a napkin and hand it over to somebody else to realize the work. And we really believe in the Renaissance community, the idea that from the beginning, bring in the experts, having manufacturers, engineers, designers, architects, and clients in the room together to shape great ideas and push not only form, but also technology. So in the project that I'm going to share today is no difference. We got approached in 2019 by Robert De Niro, the actor. So he came to us and said, how can we create a hospitality experience around content creation and filmmaking? He basically said he was tired to living out of a trailer and wanted to have a really great experience while doing his work. Together with him, we were also working for Wildflower and a gentleman called Adam Gordon. We have been design architect, but also AUR for this project. It's in Astoria, Queens, and it's roughly 760,000 square feet. It's 11 sound stages, 120 by 150, 18,000 square feet. So we know from the get-go that we had to go vertical. So this is one of the first purpose-built vertical studios for content creations as far as I know in the world, but things are changing fast. Queens Astoria, it's a very grounded neighborhood, a lot of restaurants, a lot of townhouses, people living out there. There is also a kind of an industrial heritage. You have Astoria Energy as our neighbor, and the Steinway piano factory. This was actually an image that I took while we were doing the site surveys in the beginning. So every project that we approach, we try to exhaust every opportunity. We don't go in with a preconceived notion of what this project can be. We're really trying to explore, iterate, and look at how we can kind of bring different ideas together to shape a new future. So you can see how it's almost like an evolution of ideas. From some are really wild ones, and some start to kind of get you a notion of a more, let's say, confined space. So this was kind of the concept that we landed on. We called it the vertical stage village. So normally, a lot of production and film studios are fully horizontal. You have a lot of the support spaces outside. You're moving between sound stages. Productions usually rent several sound stages. So the movement between these different sound stages and how you get a lot of trucks in and out of these kind of facilities is a big part of the success of these type of projects. And you can see it here, the dark gray battery of elevators in the middle basically serve all the individual sound stages. And then we have something we call the elevated street in the middle. So you do have access from the ground floor as well as a dedicated street above. By the way, this is a flood zone, so we had to raise the entire structure. So the whole ground floor is basically floodable and serve as loading and parking. And we came up with this concept of almost like scaling a building up. You can see we have big daylight, we have big windows for this central street, as we call it, bringing in daylight. A lot of the production is basically inside of enclosed spaces. So the kind of notion of daylight was something we really wanted to make sure that people who work here for weeks, for months, have that kind of interaction with the outside and not only spend their time in kind of black chambers. We have a couple of terraces as well for people to enjoy the outdoor in a private manner. Privacy was a big concern. So you can see also here is the kind of evolution of the design. So again, we don't go into a project with the idea that whatever we start with is going to be what we end with. We go into the project with a couple of principles that we think are really important. And then in conversation with everybody involved in this process, we start to evolve the actual design. And as you can see, it's a really big building. So the facade was something we started to think about really early on. A lot of these production facilities are usually just a straight up concrete wall and no more like attention paid and maybe putting a number on the individual studios. So we felt, how can we create something that actually have more of a dialogue with the neighborhood and add something beyond just a big mass? And it's 140 feet tall structure, by the way. So it's a very big building. And this is some of the conceptual renderings. We're very close to LaGuardia. So one of the big considerations was not only acoustics but also vibrations from acoustics. So I will come back to that when I talk about some of the details around the facade, but it was something we were very interested in, and it was a big challenge from the beginning. How do we resolve for acoustics and vibrations being so close to the airplanes landing and taking off from LaGuardia? By the way, it's a very striking view. If you fly out or fly in, take a look in this direction, you will really see what's going on. The entire roof is covered by solar panels. It's 150,000 square feet approximately. I believe if not the biggest, it's one of the bigger ones in the boroughs. And just to give you kind of a little bit a sneak peek behind the scenes, we obviously, since the facade was a really big part of this project, we started the early bid packages very early on. And basically halfway through DD. And then in 2021, roughly, we started the construction. And here is a sample actually with both interior and exterior materials. For us, it was very important that the idea of the exterior somehow replicates on the inside, that there's a connection between how the building looks, performs, and how it feels. So we created a whole kind of matrix of different materials, and you can see there is no paint here. It's all actually real material. So in a kind of a world of where you effectively create almost like artificial stage, artificial environments, a lot of paint, and you live in that kind of artificial kind of environment where you create content, we felt that could we insert kind of a sense of real materials and moments throughout this building. And you can see here how the facade and some of the interior spaces really start to play with each other. This is the central street here, where you can see we actually took the exterior facade system and applied to the interior. It's all galvanized metal panels. And this is just some of the hospitality experiences throughout the building. We have offices, we have green rooms, we have the canteen. It was really important for Robert De Niro that everyone comes together and have lunch together. The teamsters, the directors, everybody involved. So that was a goal from the beginning, to make sure that even though we have clear separation and privacy between productions, that people can come together. Again, as most people in this room probably are aware of, it takes a village, it takes a community to bring a product of this complexity together. This is just a kind of a range of consultants, and most notably, Fortin Tomasetti was our enclosure consultant on this job, while Altieri did a lot of the performance calculations throughout. So just a quick run through here. You can see ground floor, basically a ton of logistics associated with the different sound stages. Again, it was really critical to the client that you could have separate, totally private, separated productions going on at the same time, but also being able to, in a flexible manner, connect the different facilities together. And the same thing in 3D. You can see it's a massive building, and most of it is enclosed. So there is very few windows. It's mostly enclosed, and then a ton of MEP on top, since you have these really large volumes of air inside of the sound stages. So roughly 140 feet tall. And this is just a couple of sections showing the kind of amount of stuff going in here. So every soundstage also have a scene shop attached to it, where you can make a lot of the new sets. And then just coming back to the kind of idea of the facade, we started to play around with this idea of a pleated facade and thinking about how can we create something that maybe becomes a bit more dynamic. And we came up with this idea of a pleat together with a checker pattern. And we realized as you move around the building, you actually get that interesting play of light, reflections, and textures. So sometimes it reads like a horizontal texture, sometimes it's vertical, and sometimes it reads like a checker. So there is some magic built into the geometry of the building. And we started kind of early on to think about how we can install these panels, what different kinds of panels that we need. So we were looking at a few different options. Maybe I'll stay here for 2 seconds. So this illustrates roughly, you can see, unfortunately, the thicker lines is a bit faded out. But early on, we were looking into the idea of potentially cladding in this building in a metal panel system. But we realized that the mass necessary to deal with the low frequency was basically required us to put an extra facade or an extra treatment behind the metal facade, which made the cost infeasible. So we quite early on landed on the idea of a precast concrete facade system, which I think also the client was very excited about, because there was a notion that a precast facade system have a longer time span than a metal facade. So we're looking at a 100-year facade versus maybe a 50-year facade. Again, here you can see it has this kind of slight pleated texture. It goes from 11 inches to 17 inches with insulation in the middle. And basically you have the backup system that holds up the floor, that also holds up the facade. And we have this inserted windows. So the precast panels they were basically all installed as a larger panel, and then we inserted windows. And at the ground floor, we also have breakout pieces out of metal. So again, this idea of using light and play with texture to create that kind of subtle but dynamic experience as you move around this building. Lighting was also a big part of the design considerations for evenings, really creating this, the kind of pleated folds, if you like, really creates this soft notion of a welcoming entrance. And then just a quick notion, we also did an upgrade. This is actually a public park, which was a big part of our project in terms of negotiating with the city to make sure that we create a public access to the waterfront. And then in early 2021, we started construction. This is one of the first pictures from the site. We started with the foundations, obviously. Roughly a year later, the steel was up, so we built essentially each soundstage in sections. So we did the whole steel. I think it roughly took a year. It was a lot of hard work and very devoted crew. And at the same time, we started to do all these mock-ups, trying to figure out how we can get those different textures right for the precast. Again, we were a bit concerned in the beginning. We felt it looked a little bit like Oreo crumbles. So we tried a lot of different manufacturers to really figure out how we can get these textures right. And we ended up in Pennsylvania with a manufacturer that started to essentially create an assembly line, and we did some really exciting kind of first prototypes to understand really how the quality of the concrete and the different textures would really play with light. So we actually asked them to bring it up in the air and spin it around, so we could really get a sense of how it interacts. And then we did a visual mock-up, just testing all the different systems together. And I think one thing that is really striking is that the final panels, they're roughly 10 by 30 to 40 feet, and there is 932 of them. It took them roughly 3 to 4 panels a day, so roughly a year to put all these panels up here. But again, this was in the early, you can see there is still, this is before they actually washed the facade, but I just wanted to demonstrate the under construction images. And again, you can start to see even during construction how you get this amazing light place on the facade. And this is inside of one of these sound stages. It's kind of hard to see, but like the scale of these spaces is really like incredible. And as you can see, you can also connect them together to create these bigger production spaces. And early 2023, we had our topping out ceremony. And this is the client group together. This is just a couple of weeks old. So this is inside of that central street. Robert De Niro, he doesn't look so happy here, but he was very happy, I promise. And his son, Rafael De Niro, who is real estate in the real estate business, has also been involved. And then Adam Gordon, the developer, and the CEO of Wildflower Studios. So just sharing a couple of images here of the final building. They're actually going to have their first production in this building in November. So it just completed as we speak. They're basically like cleaning up the building right now. But this is just some of our most fresh images. And you can see really how they intend throughout this entire design process around the facade, and this idea of actually eliminating the reading of the panels. You can almost not see the difference. So this is basically a gap inside of the middle of the panel, and you have the panels over here, right? But you have to look very closely to really kind of register what is the mega panels and what is actually different texture. So I think the concept really successfully mitigated some of these potential kind of reading, and it was quite forgiving for those kind of smaller mistakes. Yeah, again, we're super happy with the result, and it's really exciting to work on a big production facility like this. Also, it means a lot for the neighborhood. There's been a lot of support. Everybody is very excited about it. So thank you very much. I realize I'm 10 minutes early, but I guess that's a good thing.
Well, when you're 10 minutes early,
yes,
I get to ask.
I know.
Audience, if they have any questions or comments, or you want to share anything with Daniel after his presentation. I of course, I'm going to interject first, but I think it's really interesting challenge when you have such a large surface of non-glazed area to work with.
Exactly.
Right? So it's an opportunity. It's interesting from a sustainability perspective. And also, I feel like you get to add more of your artistic sort of flavor into architecture that way, right? Like
right,
you talked
right.
about, it's an art piece. It's a sculpture, right?
Yep.
So what about this wall for you was, did it add, you didn't talk too much about the sustainability side, but did that add to your development of the design with the client? Was that part of your?
Yeah, and I think what was really striking was that all the alternatives that we looked at, you had to have so many layers. So the added up both cost, but also the sustainable footprint of adding mass beyond a lighter facade system adds up being roughly the same amount of material in the end.
Yeah. Yeah.
So I think for us, it was very it was a no-brainer because the concrete did so much great work. And the fact that it has that long lifetime is really something that meant a lot for the client. So, we were once we started to see the first samples, we felt that this is the best way to do this. But
well, thank you. Thank you very much. If anybody else has any questions, we'll step down. I think they're trying to set up the stage for the next session. But thank you, Daniel. Anybody else? We'll just get out of your way so you can set up the next. Nobody. All right, you're off the hook. You're off the hook. Thanks, Daniel. So as they're setting up, I'll introduce them in a minute, but couple questions for you guys to keep everybody awake. Hello. How many in the audience are architects? Just raise your hand. Wow. Interesting. And engineers? Maybe both. Okay. Awesome. Owner developers? Hi. Great. What'd I miss? What other? Construction industry, sales. Nobody else? That hit all categories? Yeah? Okay, great. Interesting. A lot of architects. I'm glad we have keynote architecture speakers here. So for all of our architects, this is actually very interesting. A little bit more leaning, I think, towards development, public safety. But we have, it's a panel today, our first panel in this session. Gary Mancini. He is managing partner at Thornton Tomasetti. He's going to moderate this panel. I think most of you know Thornton Tomasetti, a globally recognized engineering firm known for its expertise in structural design, building performance, and sustainability. With decades of experience in the field, he plays a crucial role in overseeing large-scale, complex projects across various sectors, including commercial, cultural, and infrastructure developments. Hello. So Gary's going to moderate for us with the New York City Department of Buildings. Facade inspection and safety program is the topic of the conversation. But I will let you introduce your panelists.
Who wants to be mine? So good afternoon. My name is Gary Mancini, and I head up the restoration and renewal practice at Thornton Tomasetti. I'm a structural engineer by training and schooling, but I spent a good portion of my career getting up close and personal with building facades of all types. This is going to be a fairly low-tech discussion. We're not going to have any 3D glasses or Oreo cookies involved with this at all. But for the next half hour, we're going to be talking about New York City's long-standing facade ordinance known as FISP, or the Facade Inspection and Safety Program, which used to be called Local Law 11, and many of you probably refer to it as Local Law 11. I know myself all the time. And our goal is to talk about how FISP has evolved over time, what some of the challenges are with the program, and where it may be heading. And to do this, or help me do this at least, I have a really great panel of experts representing the industry as a whole. So let me introduce them to you, and I'm going to, right after that, talk a little bit about FISP, and then we'll get to the actual panel piece of this. So Kevin Hoey, on your right, is an executive vice president at L&L Holdings, an expert in property management and construction. And you may know L&L from their recently constructed glass tower at 425 Park Avenue. It's really an amazing building. If you haven't seen it, go see it. But they also manage and own a number of other older historic buildings like 114 Fifth Avenue, 195 Broadway, and the amazing Terminal Warehouse, which is just a few blocks up from here and kind of nearing completion at this point, I believe, Kevin. Next is Stephen Verone, who is an architect and the founder and president of RAND Engineering and Architecture. He is an expert in FISP and has spent a career focused on facade maintenance and restoration. And like me, I know he's seen a lot of the good, the bad, and the ugly on building envelopes in New York City. Gus Sarakis cannot be here with us today, so I will skip over him. And we're going to introduce Yigal Shamash from the DOB's from the DOB. He is the DOB's Deputy Commissioner of Enforcement. And Yigal is a structural engineer whose responsibilities include the enforcement of FISP compliance, as well as the investigation of construction and building failures. He is a tenacious advocate for public safety. Some say he actually carries a sheriff's badge underneath his jacket, but I think that might just be a rumor. I don't know. So, regardless of whether you call it FISP or prefer to still call it Local Law 11, I want to be clear that New York City's facade ordinance is a critically important program that has really worked behind the scenes for almost 45 years now to kind of help keep New Yorkers safe. And I think that's important to emphasize right from the get-go. And when you consider the density of the built environment in New York City and the number of pedestrians that are constantly walking around, that's truly a major accomplishment. And while the rule has changed and evolved over the past 4 decades, it still serves as a model of best practices for a lot of other cities around the country. So let me give you a quick history of FISP. So like many other laws in New York City's first facade ordinance was introduced in response to a very unfortunate incident. Local Law 10 of 1980 was proposed and enacted by the City Council shortly after a piece of masonry fell from a building at Broadway and 115th Street, resulting in the tragic death of Grace Gold, a Barnard College student. The new rule that was passed into law mandated that for all buildings greater than 6 stories in height, inspections of street-facing facades must be conducted every 5 years by a licensed professional engineer or registered architect. Now, the first version of the rule did not require any hands-on inspections, only visual observations from the ground or setback roofs if the building had them. And the engineer or architect was required to report any unsafe conditions, which then had to be repaired immediately. So while this first version of the rule wasn't perfect, it definitely put facade safety and maintenance on the front burner for the first time in New York City. Then, after the city experienced several high-profile wall failures in the late 1990s, most notably 540 Madison Avenue in 1997, though some of you may remember that, where a large panel of brick veneer fell off of one of the upper floors and fell down to the street. The rule was revamped into essentially a new facade ordinance called Local Law 11 of 1998. So this new rule included mandatory hands-on examination from at least 1 scaffold drop on each street-facing facade. It also expanded the visual inspections to include all other facades on the building, not just the street-facing walls. And it created a new classification called SWARMP, or Safe with a Repair and Maintenance Program, which obligated owners to repair conditions that may become hazardous within the next 5 years. And this is really important because it eliminated the option of essentially kicking the can down the road and delaying repairs for conditions that would likely deteriorate into public hazards. Then most recently in 2020, partly in response again to a tragic death in December of 2019 when a pedestrian was struck by a piece of terracotta, further updates were enacted and the FISP rule was tightened up in a number of ways. Licensed professionals, now known as QEs, or Qualified Exterior Wall Inspectors, I know there's a few QEs out there, I've seen you earlier today, must have at least 7 years of relevant experience versus the original 1 year, right? And they need to be vetted and approved by the DOB. Secondly, the number of hands-on full height drops were increased to every 60 feet of the building facade on all sides of the building. So this is a major change. And probes became mandatory for investigating masonry cavity walls. And this was intended primarily to target the large number of buildings that were constructed from the 1950s to sometime in the 1970s, many of which have been failing due to poor construction, lack of expansion joints, and missing wall ties. So this is something that's been targeted specifically with mandatory probes now. And the rules also clarify that by definition, conditions requiring repair within 1 year must be classified as unsafe, meaning that pedestrian protection must be installed. Oh, let me go back for a second here. And just for perspective, I wanted to put this little image on the screen as well. It's important to point out that only about 1.5% of the total 1 million buildings in New York City throughout the 5 boroughs are over 6 feet tall, or over 6 stories tall. So the subset of buildings that fall under FISP is actually quite small. This means that there's actually a lot of older, aging buildings that probably aren't receiving the inspection and level of care that maybe they deserve. So just keep that in mind as we talk about this. And as I'm sure you know, if you spent just a few minutes walking almost anywhere in the city these days, it's clear that one of the undesired side effects of this increasing attention to facade safety is the ever-present sea of green plywood and steel pipes that line our streets and avenues. These sidewalk sheds limit natural light, they block storefronts, they can attract loitering, and frankly, they're just eyesores. I mean, they have a real tangible impact on the quality of life in the city. I think all of us can admit that. They do come in handy when it's raining, though, I will say that. So sidewalk sheds are installed, why? To protect pedestrians during construction, right? But they're also required when an unsafe condition is discovered on a building. So there's no question that some sheds are probably up longer than they should be, and the current administration has made a commitment to helping get the sheds down. So how do we get more sheds down but continue to maintain public safety? So to help answer this question and others, we will now turn to our panel. So I'll start with you, Yigal, and hit you with a big picture question on this. How effective has FISP been in maintaining public safety over the past 40 years?
So let's start with dispelling the earlier rumor that you're starting to spread about me with a badge. Definitely have a badge, not wearing it right now, and I had to think for about 5 seconds to actually remember where the badge was and the last time I wore it. It's possible my youngest son took it to school, but no, just kidding. With regards to FISP, from our standpoint, we think it's an incredibly successful program. It is without a doubt that it has saved lives. Our previous chief structural engineer, Dan Eskenazi, published a research article looking back at the history of FISP, numerous cycles, and clearly identified that owners of buildings in the FISP population, you know, it's funny when we think about 15,000 or 16,000 buildings that are, and that's a small number compared to the total number of buildings, but just the sheer magnitude of that number of buildings is substantial. And it's, New York City is unique in that regard. I think Chicago has the second highest number of buildings in their FISP population, also similar heights, and they're 10% of that population. So New York City is indeed unique and standalone. But the results of that published article show clearly that building owners perform maintenance on their buildings in a regular fashion, proactive maintenance in terms of the work that they do on their buildings as compared to building owners that are not in the FISP program, which unfortunately do postpone and do delay necessary maintenance until it's absolutely necessary. So without a doubt, the FISP program has clearly saved lives. It requires owners to do proactive maintenance. And I know building owners, some of them shy away from that. Some of them, you know, are very proactive with their buildings and the maintenance of their buildings. The program as a whole, we think, is widely successful, though.
Thanks, Yigal. So I'll turn to you, Kevin. from your perspective, you're obviously one of the well-known owners and managers in the city. What works well with FISP, and what do you think could be improved?
Well, first off, I don't know if you have a badge or not, because we do everything we can to make sure you don't come by the building.
Can you hear him? No, okay, maybe you need the mic. I don't know.
I don't know if you have a badge or not, because we do everything we can to make sure you don't come by the building. Not that we wouldn't love to have lunch, but for all intents,
Definitely a smart move, by the way. Nobody wants to see me.
For all intents and purposes, yeah, I agree with everything that you've said. The system has worked. The untold lives have been saved. Is there room for improvement for every city law program plan? Certainly, and I think there is room for improvement with the FISP program because, as we all know, there's a sidewalk bridge up around every other building in the city, and when you have exceptionally large buildings, our portfolio has buildings in excess of 1 million square feet that are pre-war landmark buildings. It just seems that the scope of work necessary, it's a 2-year process to do one cycle filing. 1 year prior of investigation and reporting with the design professionals, then you file, then the work takes place. If you have a large building, that's obviously seasonal, so it's either 1 or 2 years worth of work. So now I've got a sidewalk bridge up for 2 years, we finally get it down, we're finally done, we take a breath, and oh wait, it's time for another cycle. So in its design, in its practice, the system works. As you said, it's saved untold lives. But I think there's from the ownership side, there's a little room for tweaking. Nothing dramatic.
Do you think all buildings should be treated the same way, or do you think there should be some variety of how you approach a building?
It really depends on the building.
Okay.
It depends on, there's so many unknowns.
Right.
We pride ourselves on being a responsible, proactive owner. There are owners that are not. We all, it's a very broad spectrum.
Right.
In the industry. So.
Thanks, Kevin. So, Stephen, I'm going to turn to you. What are the biggest challenges with maintaining facades in New York City? I mean, are there certain materials that are persistently more problematic than others?
Well, the biggest challenge by far is securing the funds to do the work that has to be done, because the cost just continues to increase. Various reasons, additional safety requirements, labor availability, costs, the cost of materials and availability of materials. So that's usually the biggest challenge. And a lot of owners are not necessarily budgeting. We're the bearers of bad news where we find X, Y, Z, and the owner says, oh, did you have to call and tell me this now? Couldn't you tell me 2 years from now? It's like, no, not only that, we're required by law to report it in 24 hours to the buildings department, and you need to get a sidewalk shed immediately. So that's the biggest challenge. We also, the challenge of dealing with, well, not all building facades and materials are created equal. And the downside of having such an eclectic building fabric, so many different types of buildings right next to each other. And we love the fact that we're more restoration focused than we used to be. Like when Local 10 was passed in 1980, one of the unfortunate things that happened, particularly on the Upper West Side, so many buildings, if they weren't in a historic district, just stripped off all their decorative stone. So now you have all these flat buildings instead of terracotta. And that was the way out before a lot of those Upper West Side districts became historic. But the reason was because it's so difficult to maintain and restore and deal with terracotta as opposed to even just replacing it. So now you have the repair versus replace, which is a big challenge and a big question, and not even necessarily the city agencies agree. You may have landmarks thinking more restoration and DOB thinking more public safety, and let's get it replaced with, and then what do you replace it with, terracotta or cast stone or GFRC? And then you have materials that are just aging out, like was added to FISP now with on cavity wall buildings, where we've had spontaneous collapses of the traditional white glazed brick from the 50s, and just like the panels just coming out, sometimes with a little bit of warning, sometimes with not, and just aging out. So now you have to inspect all these cavity wall buildings to see if literally the ties are just rusting away to nothing. So it's a challenge, but it's something that we invest in because we appreciate the eclecticism is a big bonus of this city. It's not just a glass of glass towers everywhere. We have the eclecticism which we want to maintain, but it is a challenge.
Yeah, good. Thank you, Stephen. So Yigal, as the enforcer of public safety in our city's building stock, what challenges do you see with older buildings that, as Stephen alluded to, are using materials like terracotta and limestone? And how do we do better as an industry to address aging facades?
In terms of the different materials, with regard to the FISP program, it's the most difficult thing that we see is, does the program fit for the entire population, the 16,000 buildings that we have? And when we were revising the rule in 2020, that was our biggest challenge. We wanted to make sure that the changes that we were making will work for all 16,000 buildings that we have across the board. And some of the challenges that we were facing, and Stephen hit the nail on the head, was with terracotta, number one. Are we doing enough to force the industry to get hands-on onto those elements? At that time, terracotta, and specifically terracotta repairs, was the number one element that was failing on buildings, ending up on sheds, unfortunately on the sidewalk and the streets. And we were seeing that at that time, 2018, 2019, at a rate of almost once a month on FISP buildings. Not on non-FISP buildings, that rate was higher, but on FISP buildings.
And that's due to aging, you would say?
Due to aging, weathering, but we saw a lot of inadequate repairs, or repairs occurring on elements that had no business getting repaired, because of the difficulties, I think, with replacing elements, especially when they're in a landmark district or landmark themselves. We've had numerous conversations with LPC about repair versus replace, and what should be repaired from the department's opinion versus replaced. So we've had those conversations with LPC. But it's a difficult call that the professionals have to make. It's a difficult call and pill that the owner has to wait a prolonged period of time for replacement terracotta units. But it's something that we thought was very necessary to increase the hands-on, and maybe we do need to dial that depending on the building typology a little bit. And I wanted to mention one other thing with regards to costs and then cavity wall buildings. It's interesting with regards to the cost, and what we've heard from building owners is access, general conditions, and insurance sometimes are 60-70% the cost of the repair program. So some things that we were trying to pitch is, if you modulate that repair program slightly and do a more comprehensive program, and push owners to bring the repair and the facade not back to its original condition, certainly, but certainly to a longer lifespan than what we were seeing repairs 10 years ago. The incremental cost is really negligible, a few percentage points from what we're understanding. And then cavity wall buildings, we were seeing them, as Stephen said, have serious issues, spontaneous collapses, and those are the taller buildings, so those are the ones that really have access issues. And that middle picture there was one of the pictures that we had one of our FISP inspectors take. Very difficult to get to those locations and deal with the situation post-collapse.
Well, you spoke about making the decisions on how to modify the law, and correct me if I'm wrong, but the cavity wall, the decision on cavity walls have to do with the probes. That was the first time that a certain class of buildings or type of construction was singled out. In the past, the easiest way to have the public accept the law and have something go through is to treat all buildings the same. As soon as you start singling out, okay, terracotta buildings will be treated this way, glass buildings will be treated that way, you get the pushback from every sector that has an interest one way or the other. I'm old enough to remember the discussions when Local Law 11 was passed in 1998, where hands-on inspection was added for the first time. And there was a push to say, okay, for terracotta buildings, you have to have 100% hands-on inspection. And the resistance to that was, now you're going to treat the terracotta buildings as a bad actor, if you will, as something that's going to require more costs, be singled out. There was concern the real estate value of those buildings would suffer accordingly. And any place that wasn't a historic district, they'd be stripping off the materials. So every time there's a discussion about tweaking the law for this type of building or that type of building, you run into the question of, we're no longer treating everyone equally. And then when you have the totally even-handed approach, then you have problems with certain kinds of buildings. But that's left to the private sector, for the QEs to figure out, oh, for this type of building, we should do this, we should do that. There is some discretion for the QEs to approach different types of buildings in a different way.
Yeah, good point. So, Yigal, I'm going to turn to you on this one. This is maybe a good segue from what Stephen was just talking about. I know there's two important studies right now going on with the DOB. One is related to FISP, and the other is related to sidewalk sheds. Can you briefly talk about those?
I'll start with sheds. I love talking about sidewalk sheds and public protection. Been my well, yeah. So yes, so since actually in the passage of law in 2020, we've been tracking the use of sheds and specifically on local law buildings versus construction sites versus non-local law buildings and the maintenance that they do. So we've been specifically tracking those, and more importantly, and I think, Gary, you mentioned it, is the sheds that are just up and no maintenance is occurring, right? I think we can all agree that construction is a good thing, and sheds are required for construction, public protection, so that's great. Development, love it. Maintenance and repairs of building facades, again, an excellent thing. Owners are maintaining their buildings, and that's, again, something we want to see. But what we noticed going all the way back to 2020 is that there are a small percentage of sheds that just stay up with no maintenance on the buildings. And what we started at that time was a long-standing shed unit. And what we termed at the time was any shed that was over 5 years, we called it a long-standing shed. And we started developing a program where we would take these owners to court. Unfortunately, we were issuing them violations, but they were not maintaining the buildings just with the violations. So taking owners to court, we've taken almost 350 long-standing sheds down since the program started. But we thought that wasn't enough, and we pitched it to our new commissioner, and he pitched it to the mayor, and we wanted to change what the feel of walking under a shed, even though it's great in the rain, great in the snow, right? Always looking for that shed during inclement weather. But again, the feel of walking under that sidewalk shed. And I have kids, I have a family, and for me personally, it you get that little hairs on the back of your head standing up when you do walk under a shed. You don't know what you're going to experience, what's going to go on under there. And so we put out an RFP. We hired two great firms, PAU and Arup, to study everything related to sidewalk sheds. It's a one-year study. And at the end of the study, both firms are going to produce sidewalk level protection. And for me, in terms of public protection, a non-sidewalk level public protection type, whether that's some sort of cantilever off the building, netting, or some sort of other creative idea. So they just started their work. And for us, this is going to be a culture change across the whole city. And it's something that we're very excited about. I think the mayor has had, since the Get Sheds Down picture that you showed, I think he's had 5 additional press announcements on it, and we're really excited about it. The second study, and Gary, you may know the firm that we've hired TT to
I've heard
study.
of them. Yeah.
Unfortunately.
I'm familiar with them, yes. I've heard of them. Good firm, by the way.
The department has hired Thornton Tomasetti to study everything related to Local Law 11. Again, it is a one-year study. And my commissioner jokes, he's a Mets fan. The Mets have had one World Series championship, 1986, since 1980. FISP has had no study done since that time. So one of the things that we're, again, very excited about, putting science behind, is the 5-year cycle the right length? Is the 60 feet interval for the hands-on inspection the right interval? Different buildings, different facade types, different facade materials. So 2 exciting studies that the department is undergoing, and we are just eager to see the results.
Great. So Kevin, are sidewalk sheds, in your opinion, listening to what Yigal just said, are they the best solution for pedestrian protection in your mind, regardless of how pretty they look or not? Or are there other solutions that you'd like to see? And I guess corollary to that, because it always comes down to money, are you willing as an owner to pay a little extra to sort of do something different that maybe doesn't detract from the sort of fabric of the city, of what we want to have people see?
Well, it depends on how much more we have to pay.
Of course. It always comes down to dollars.
Because I'm saving money with snow removal.
Yes, true. That's good.
That's a wonderful thing. Look, on the owner side, we don't want these things in front of our buildings either, because they create the perception that, hell, they're unattractive. The building's a dump, and we don't want them up there.
And something's wrong with the building.
And something's wrong with the building.
Right.
You also have what you mentioned, that you walk underneath these things, and unless they're urban umbrella, which are 20, 30 feet high, well lit, the majority of them, you get the hair stands up on the back of your neck when you walk through some of these in some of the outer boroughs. It's just, nobody wants these things there. Yes, they work. Yes, right now they're the only option. So yes, we'd be thrilled to explore other options, netting on the side of the building, cantilever protection, stuff like that. And yeah, if there's more of a cost to that, but at the long run or at the end, it's more beneficial to the perception, the value, et cetera, of our investments, and we'll spend the money. That's our firm. Mm-hmm. We'll do that.
But you would probably have less of a reaction if the typical shed. We can calculate what percentage of the resistance and the hatred of sheds have to do with this shed. Well, that's even a double height. But the classic shed that the hair on the back of your neck stands up when you walk under. If they were all attractive and double height and lit and translucent ceiling, and some of them remind you of New Orleans, we would have a different reaction to them being around our city. And then the focus could really be where it's supposed to be, on public safety. And I think that's part of what you're doing with the law, discussing changing the law to have a greater variety of shed, if you will, less structurally over the I don't want to say over the top on safety factor, but you know what I mean, where it's more elegant, slimmer, lighter, and that some of the pressure may be that. But just as Kevin is saying, there's a small percentage of bad actors who are going to leave the shed there until they're taken away in handcuffs. Yep. But the vast majority of the owners, and I can say this from personal experience, they want the shed down more than anyone. They're all over us. Why is this taking so long? Why is that taking so long? They don't want the shed there. So finding ways that we can lessen that time, that working together.
I mean, Gary knows the first thing during the middle of a project that we've worked on, and that first question I have is, when am I taking the shed down?
Right.
Why isn't the shed down? Where's the paperwork to get the shed down? And I've driven you nuts on many occasions because nobody wants them up there anyway. So.
Right, and how do we accelerate that, Yigal? What is your thought on that? What is going wrong in that process that we can't get sheds down fast enough?
Well, I think it's a couple of things, and Stephen mentioned cost early on. One of the things that I've heard from the industry and from owners is that cost is not the biggest schedule issue in terms of procuring funds and putting together, but that neighbor-on-neighbor issues recently have caused schedule delays on numerous projects that I'm hearing that is now the number one culprit with regards to schedule. I don't know.
And you're referring to it like accessing someone's site next door.
That's a very big issue.
Yeah.
Correct.
Yeah.
Correct. So we're hearing that to be the number one issue when it comes to scheduling hiccups. Not having your neighbor allow you to put roof protection on their building, or extend the shed the 5 or the 20 foot necessary by code when you're doing the work. So those are the things that we are hearing right now that is causing the biggest schedule delays.
We've actually had, this was unheard of in the past, now where some owners are actually paying the neighbor to allow them to extend the shed onto their property, which I was dumbfounded when I heard. And this is something that it would be great for me if the DOB would say, no, the shed's being installed, you can't do anything about it. Because
that sounds like an only New York City kind of thing.
Right, exactly. So you're negotiating with someone to pay them to put up something that protects them. That's required by law anyway. You'd be fined if you didn't do it. So sometimes the delays can be maddening. Yeah.
So Stephen, hold on to the mic. So I'm going to turn to you next. So from your perspective as a design professional focused on repairing and maintaining facades, what do you see as the future of FISP in terms of technology? Can technology like drones, unmanned rigs, artificial intelligence, can those things help potentially improve public safety in the future?
Well, any kind of technology that comes into play is of benefit, right? As cameras have gotten better and stronger and more accurate, and binoculars have gotten better and stronger and more accurate over the years, the ways of accessing the building for hands-on, whether it's rope or the traditional rig or any kind of technology that's coming. There's a lot of discussion now about drones. My firm's all in on drones. We have a drone group. We're doing a lot of drone work, particularly outside the city. So anything we have that we can use to monitor, one particular good thing about drone is you can monitor year on year whether there's a little bit of crack movement, and a much better way than you can do with photographs. We just don't want the technology to replace the value of having your hands on the facade, particularly when you're dealing on materials like terracotta. And to say, oh, we had a close-up view of it with a drone, and we can monitor that crack 2 years from now. It's like, okay, in the meantime, you're asking someone in the private sector to sign off and say this building is safe, and no one had their hands on it. So drones don't replace any kind of AI, really, any kind of technology, excuse me, unless it's allowing your hands to be on it, won't replace, they just supplement. But I'm very positive about the future because there's so much energy and brain power going towards it. It's so important to maintain the buildings and find ways to keep them safe and find ways to inspect them. And all this thought that's going in, even this is the artist that's being done, the study that's being done, the number of people that are committed to the industry. When Local Law 10 was first passed, it was basically anyone that was an engineer or architect, okay, go out, write a report, file a report. And at some point, DOB, you had to cull the list of the inspectors because they were no longer they were no longer making the grade as to what was required for the technology, for the expertise now. So I'm very gung-ho on the future of it, and the more technology bringing in, the better.
Right. So, Yigal, what are your thoughts on that? I mean, if you can get a lot more data, right, with drones, and you can process that data with AI, right, and you get tons and tons more information, can that help you make better decisions? What are your thoughts from the DOB's perspective? Can drones and AI eventually replace the human element?
I think, and we've spoken with numerous consultants and university researchers. I think the technology isn't there right now. Completely agree with Stephen that they're currently right now replacing hands-on inspection is not something that we're seeing technology can do. But who knows in the future? 100% agree. Any technology, we're all for. We have our innovation group with our OTCR unit that has been looking at a wide variety of technology from drones to robots scaling up and down buildings. All great, all tools in the toolbox of the professionals, and the more information in my mind, the better. But at some point, it's probably data overload for your teams, right? 6,000 pics on a building, and then you have to have folks go through all those pics, and maybe that's where AI comes in, and being able to identify and be able to look through those 6,000 pics and be able to identify which ones have deficient conditions and which ones don't. So that certainly would be very interesting. But for us, technology is a tool in the toolbox. It's only as good as the professional that the owners hire. And when I started at the department, we took a hard look at the QE list, and we were able to cull the bottom of that list, and I think we have the list at about 480, 500 or so QEs that we're pretty confident will do the right job with regards to facade inspections. But it's a daily challenge. It's a daily challenge.
Yeah, and in some ways it's analogous to the medical field, where you can have AI look at X-rays and radiographs, of patients, and with a certain very high degree of confidence, have it pick out problems, right? But in the end, you want your doctor telling you that you have a spot that needs checking further, or you may have cancer, right? It's not going to be the AI that tells you that. So we have to be careful what we get out of it. But I think there's a lot of promise in the same way for inspections of facades in the future, where you can get a lot of data and scientifically sort of understand that much better than we currently have the ability to now, just doing it with traditional.
It's very important, Gary, as you know, that the public sector and the private sector have to be on the same page with this, because whatever is passed on what will make for a passing building, let's say, the way things are written now, the private sector QE has to sign off on that building. So if you tell that private sector QE, you no longer have to put your hands on this by law because a robotic test was done on it and everything is sound. It's now the QE relying on AI but still holding the liability. Right, so it's a tricky thing. Or if you change the law to say certain types of buildings don't need to be inspected for every 10 years. Now you're asking that QE to say, and the wording is very strong. The wording says this building is safe for the next 10 years. That's 10 years of freeze thaw, right? So it's a delicate balance trying to figure out what the public sector wants to do to not make it onerous for the owner, but then the private sector where the QEs are being asked to sign off on these things. And that's why it's a discussion and an ongoing back and forth, because we all have to be on the same page.
Great. So we have a little under 4 minutes left. So maybe what I'd like to do, I know there were a few of you who wanted to sort of chime in with some thoughts and questions. I'll open it up to the audience to ask any questions of this group if you so desire. So do we have anyone? Yes, sir. Yeah, I mean, I can probably answer that best in this group. There are a lot of different ideas out there and a lot of different facade ordinances. Some cities focus on materials and how that impacts the longevity. Some cities look at the systems of the construction. Some look at age, just simply saying a number of years, and there's a cutoff, right? So there's a lot of different things, and actually this study is looking at all those possibilities. I will say that knowing what the other cities do and what New York City does, New York City has by far the most robust and thoughtful system. And the number of sheds and the number of buildings that undergo this every year is a testament to that. I mean, there's a lot of much more eyes on these buildings than there are in a lot of other cities. So I will say that in fact, it does serve, frankly, as a model for a lot of other cities. When they decide to begin a facade ordinance, they turn to New York first and say, let's start with this and then sort of chop it down a little bit to make it fit our needs. But there are, to answer your question, there are other ways of looking at it that New York maybe isn't. New York does have a sort of one-size-fits-all, but it's very rigorous. And so the question is there different sizes that can fit different buildings? That's kind of the thought.
But even New York made the cutoff at some point, because the chart showed we have 16,000 buildings in the FISP world and 1 million buildings in the city. So unfortunately, if you're walking down the Lower East Side, if a brick fell off the fourth story of a 4-story building, it hurts just as much if that building was 7 stories. But it made a decision that they're out of the program right now. So that's what the typical city does. They, like Gary said, they're modeled off New York, but usually they're not as stringent. Just a visual or,
Right.
But it is 100% part of the study that TT is doing, Thornton Thomas City is doing. We have them reaching out to other jurisdictions and asking them questions about what those jurisdictions are doing. And I think we have one international, right?
We do.
City that we're talking to and seeing what they're doing and seeing what works and what doesn't work. I just wanted to mention one other thing with regards to the shed study. At the end of the study, our full intention from the department is to implement the 4 sidewalk level and the 2 non-sidewalk level designs into the building code that would allow owners to pick and choose which design they want to use, and they would again, our intention right now, they would not be proprietary. They would be in the building code and be allowed to be used depending on the situations.
So I'd like to get to one more question. We have like 30 seconds left. So it'll be a quick question and a quick answer, if anybody has one. Okay, yes, sir.
So I think Stephen hit the nail on the head. If you just went 1 story down and included the 6-story buildings, it would increase the population tenfold.
Yeah, so there's just a practical element to that. Can the DOB handle receiving that many number of files? And do we have enough QEs and engineers and architects that can handle that volume, tenfold volume, literally, if you go down 1 floor? And forget it, if you go down to 1 million buildings, it's almost impossible. So, but it is one of the things we're thinking about and talking about, and is there a benefit or not? There's a reason why that 6-story cutoff happened, right? Because of the numbers, right? It's all about that. So I think we've come to the end of the discussion. So I'd like to thank our panel, first of all, for sharing their great insight. I hope most of you found this valuable. Thank you for listening. And thank you again to Zak Façades for organizing this event. And in case you want to follow up with any of us, our contact information is up there so you can snap a picture of that. And that's it. Thank you very much. Enjoy your lunch.
And we're going to take about 1 hour for lunch. So thank you all, and we'll see you back in a little while.
Hey everyone, welcome to the afternoon session. So this is session 3A. I hope you guys enjoyed lunch, and I hope you guys also save some room for dessert, because we have a delectable selection of talks this afternoon in session A. So just a bit of housekeeping. For those of you who want to move between sessions, you can do that, but just be courteous to the speakers in each room. So do that quietly in the back, hopefully between talks, but you can continue to move around. So without further much ado, because we have a very busy schedule in session A, I'd like to introduce our first speakers. This is a project that's very interesting, living in Brooklyn, seeing this project come up and getting to see it kind of come out of the old Gowanus environment into this, what it's becoming now, which is this brand new development, is very exciting. So this is Philip Schmerbeck, and who's the USA studio director of Herzog and Meuron, and James Seger, partner at PBDW, here to discuss the Powerhouse Arts project.
So thank you all for joining the session, and Jim and I are happy to be here to share some insights on this little adventure in the Gowanus. Powerhouse Arts really was a collaboration between Herzog Meuron and PPDW as our executive architect and preservation architect. We had also collaborated for years, coming on close to 2 decades now in the Park Avenue Army. So when this project came along, it seemed like the perfect sort of marriage of our skill sets. And so this was an opportunity to sort of bring some of that modern and historic preservation, adaptive reuse experience to Brooklyn from Manhattan. I'll let Jim give you a little history on the site and the project.
Good afternoon, everyone. So the subject of the project is the Brooklyn Rapid Transit Power Station. It's an adaptive reuse of that for Powerhouse Arts. Located in the borough of Brooklyn, it was originally conceived to provide power to the Brooklyn elevated rail and streetcar system. Located in the Gowanus section of Brooklyn, defined by the Gowanus Canal, which was dredged out of swampland in the mid-1800s, developed into an industrial area, very heavy industry during the latter part of the 19th century, early 20th century, became a very polluted area as well. The canal was designated a Superfund site in 2010. And alongside that, there was discussion about rezoning the area for residential, and that zoning change was enacted in 2021. So the area has really evolved, or is in the process of some major evolution currently. The site of the power station is in yellow there. The building was designed by Edward Murray, completed in 1904. This is sort of your classic power station, the boiler house section on the left, the turbine where steam was generated, turbine hall on the right. In the foreground on the left is the canal, and in between the two is a coal yard where to bring in materials. Classic view of the waterfront at the time. You can see the canal was obviously central to the development of industry in the area. It's where they brought in all the coal and also brought out the coal ash through the canal. Building on swampland was, posed certain challenges. This is on the right, the construction of the foundations of the building back in the early 1900s. It's a closely spaced grid of wood piles driven into the muck, and that was then capped with a 6-foot thick concrete mat slab to support the two structures. Looking at the interiors of the original facility, the boiler house on the left, it housed, I think, 8 or was it 16? I don't know. Boilers, steam, coal-fired boilers. The water was drawn from the canal to create the steam, which was then pumped over into the turbine hall on the right, which is essentially a big open space with the turbines. There's a gantry for maintenance, and then the power was sort of, the electricity was piped into these mezzanines on the far end of the hall that had transformers that kind of prepared the power for distribution to the street grid. The building produced power until about the 1940s, until about 1940, at which point it became a Con Ed substation. The boiler house section was decommissioned and subsequently demolished in the 1950s. There were some attempts at using the building for something else. It was a recycling plant for a while, but it became disused as of about the 1980s, and it was abandoned for a few decades until we started the project. But in the early 2000s, it became a haven for squatters, it became a renowned area for graffiti artists to perform their craft. That was the Batcave era. And this is the condition that we found the building in when we started the project. The roof was missing, all the windows were missing. It had been exposed to the elements for decades, and but had really great bones. It just needed, a vision and some TLC to take it forward.
So seeing it from the air when we started, it also, I think, set up some ambitions and some vision for the project, because basically we had half of the original historic structure, and you can see in this image from the air, as per the rezoning, much of the industrial character of the neighborhood was actively being erased and removed to make way for new residential high density construction. So this project offered an opportunity to prolong the industrial legacy of the Gowanus, because the program itself that our client came to us to develop was light industrial fabrication space. So much of the low-rise post-industrial structures being used for fabrication by artists and small fabricators was being displaced in light of the new rezoning. The other aspect of our early work was also to work directly with the Powerhouse Arts and their artists and their workshop techs to already develop the program in parallel, program detail in parallel with the design process. And they actually started shops early during the concept design process to sort of test fit those programming moves and that operations, and then we could then really fit the building to the purposes that they were learning and verifying in parallel in Red Hook. And I think our other primary goal was also to kind of maintain the character. So we started with half of an original structure, and that was to really reconstitute that full program of 170,000 square foot of workshops. We really ourselves in the competition process proposed to reinterpret the original historic boiler house to sort of bring all that volume back together under one roof. That meant also bringing new contemporary materials next to historic ones and letting them sort of coexist harmoniously, but also still with some amount of contrast. That also meant leaving the vestiges of those past uses. The artists, a lot of it was ad hoc, ephemeral graffiti, but also the damage and wear and adaptations over time, so that by the end of our sort of design process and construction, we could kind of bring it back together holistically, and that in very straightforward way, materials could express themselves but sort of exist historic and contemporary side by side. And really that gives you a 3-building complex comprised of the original turbine hall, bolstered by a recreated, reinterpreted boiler house, and then a gatehouse out at 3rd Avenue, since we really had only 2 minor connections back to 3rd Avenue.
Just to go back one, am I on? The access from 3rd Avenue is kind of blocked by the storage building, so that kind of created a bit of a challenge in terms of the visibility of the site from 3rd Avenue and for site circulation. So just take you through kind of how that played out. We have these narrow strips coming from 3rd Avenue on the right out to the site, which is against the canal there. The organization of the site, following kind of the original blueprint, worked very well actually for bringing trucks in. We needed a large area where the coal yard used to be. We call it the forecourt, for trucks to maneuver into the loading dock, for fire trucks to turn around, and then they kind of do a counterclockwise loop around and back to 3rd Avenue. Cars would have access to the parking garage underneath the entire complex, but entering there underneath the boiler house. And it made sense, actually, in light of all this, to kind of reuse the original foundation. It kept the building compact, and also meant that we didn't have to make more interventions into the contaminated soils on the rest of the site. So looking at the building kind of in a macro scale, you've got the boiler house, the recreated boiler house on the right. It's a cast-in-place concrete structure sitting, again, on the original foundation. It's got a lot of windows on the north to bring in that great north light for the studios. There's a shared core running down in this photo, the right side of the boiler house, that serves both turbine hall and boiler house sides. And then that connects to mechanical on the roof, which is housed partially in these 2 volumes that sort of evoke the without mimicking the original smokestacks. Looking at the turbine hall, we've got this great sort of interior facade because it was one big space to begin with. It's adorned with, the sort of the wear, the grit, the original finishes, the graffiti that was added during the Batcave era. We wanted to feature all of that in the new building. And there was also an infill structure added, also of cast-in-place concrete, to kind of help fill out the program. Quickly go through the sectional layout. Parking at the lower level, it's a floodable basement, even though the site is slightly above the floodplain. The large workshops are at the ground floor, so they have access from the loading dock and from the forecourt. There's a narrow administration level and small metals workshop. These floor levels were set by the mezzanines in the turbine hall, so we just carried that through. The public spaces above that, the grand hall and the loft, printmaking kind of overlooking the loft, taking light through from the north elevation, and then up into the high-rise section with ceramics at the top because it had the highest ventilation requirements. 2 entrances. The entrance on the right there into the turbine hall is for the staff and visitors. You go into a new lobby. There is an open stair that leads you up to the grand hall from there. And then you've got the loading dock off of the forecourt on the left, which has direct access to a large freight elevator serving all of the shops. Moving up through the building on that open stair, on the second floor, there's a small lecture hall, small lecture and exhibition hall, which is surrounded by the admin, and then the small metals. the main shops, the main public spaces on the 3rd floor. There's a mezzanine above the grand hall that's opposite this print shop, and then you get into the high-rise shops, ceramics at the top and mechanical.
And obviously the original volumes of the building didn't have so many floors. We had a turbine hall that was one large free span up to the roof. The boiler house was a vacuous sort of lattice that had large boilers, but it did have mezzanines for humans to sort of tend to the machine. So those mezzanines became those platforms that we set all those new program floors to. So we had to literally fill the vessel up from the inside to accommodate all the program. You can see the historic drawings on the left, quite a bit of Victorian era stylings. It was a new building topology at the time, so it was really a machine sort of dressed in Romanesque clothes to make it look like a building. So the windows, large, grand window sizes that really weren't required by maybe perhaps modern standards, but at the time, this building produced electricity, but it still operated under daylighting, which I find pretty interesting, which was great for the artists. The very large windows in the boiler house were maintained from the original design and carried around in the fenestration of the boiler house. It was very functional. It brought a lot of light into those the northerly exposure of all those workshops stacked up within. We worked with Pickler, Stahlbau Pickler. They also worked on our prior Leroy Street project in Manhattan. They were the lowest cost bidder, even coming all the way from Bolzano. 9-foot unitized windows hoisted into place with an economy of scale, identically organized around the building. Early concept design models. How do we materialize that facade of the new boiler house? Were really our focus of our early material studies. We landed on concrete, but we started with brick. And in the end, our most cost-effective material and adapted and rugged material was poured in place in situ concrete. And then we studied ways to how do we kind of bring back that holistic whole of the power station itself, which is comprised of the boiler house and turbine hall. We had the bricks, we had the primed steel. The steel comes red, even if the architect doesn't specify the color. We kind of went with that, and then we added the sort of primary ingredient into the concrete mix. So the red oxide, same pigment that makes the red clay bricks red, and the primer red is easily added into a standard gray mixed concrete. We used red aggregate as well. And then we also use a form retarder. So to sort of reinforce the monolithic quality of the final ensemble of the boiler house facade, remove all the form lines of out of form finish, we coated all of our standard unitized formwork with a form retarder, and then underwent quite a series of mock-ups. These are done in multiple stages, multiple scales, starting with 12 by 12s, moving up to standard tombstones, and then working with several different concrete bidders at the time, letting those tombstone mock-ups be both sort of R&D for the design team, for us to really research the sort of qualitative aspects of the facade concrete that we were looking for, but at the same time utilize the means and methods of the bidders that we're going to make for value and cost-effective bids. And then once we had selected our final contractor, jumping scale and incorporating the window designs and the VMUs and even PMUs into one sort of consolidated final mock-up that still utilized different aspects of the form retarders, different aggregates, slightly different mixes. But you can see really all those ingredients in a microcosm, and sort of finalizing our final washdown methods, which the team would be able to deploy consistently with predictable results at the scale of the pores of this very large footprint. because those were very big pours on site. So being able to wash down all that concrete within the time frame was critical to getting just that perfect amount of exposure of the aggregate within the concrete mix. Let's see if I can get it to actually move to the next slide. Seems to be frozen.
Maybe just click on it. There you go.
Yeah, let's do it manually. It is a high rise because the turbine the code strategy was sneaking in under 75 feet with a low rise building, which meant we could expose all the interior structural steel without additional fireproofing if we sprinklered the building. On the boiler house side, treated as a separate building, filed as a high rise, and it's therefore also making up for some of the thermal inefficiencies of the original turbine shell. So the boiler house is an insulated, poured in place concrete shell. So the first layer, 10 inches of standard mix gray concrete, standard formwork, easy to pour, literally the cheapest concrete that we could bid the project out for, because it was a very aggressive budget we were working with. And then coming up with a method for the concrete contractors to then come back with a second thermally isolated red oxide concrete outer facade with insulation in between. So the basic method was to really top out with the superstructure and then come back and reuse those same tie holes to form the additional 6 inches of red concrete on the outside. Of course, everything was tested. I've got 1 minute, so I'm going to blow through the rest of this. Even the best things you can do in VMU, I think, have to be redone in situ with the contractor. So I think that's something critical of our process, is staying with our partners, with our executive architects, all the way through to the end of the project, being on the scaffold with the contractors, seeing the problems as they're arising. And I think the big issue here was how to really wash down that much concrete surface to get that reveal of the, let's say, the inner crust of the concrete. And I will just end with some final images that show a little bit of that sort of juxtaposition of contemporary and historic. Here you're seeing the interior of the boiler house. That's the gray structural concrete with the large pickler windows. The turbine hall prior to infill. This was the stabilization effort and the ship in the bottle approach to the turbine hall superstructure. And this is ending on the sort of culmination of the completed project at the front entry, with some of keeping that existing character of the space, but also building a building that's sort of lasting for the next 100 years. So taking something that could last 100 years exposed to the elements, but then putting back something that can also, with modern construction methods, last another 100 years. Thank you.
Great. Thank you. Thank you so much, Philip, Jim. That was a wonderful presentation. And for those of you who haven't been to the building yet, I really highly encourage you to see it. The photos don't do justice. It's an incredible adaptive reuse project. So on that note, by the way, for those of you who are joining us, this is session A. I'm not Julia Gamelina, unfortunately. I'm Sherry Yang of SOM, replacing Julia because she's out sick. But we have a very interesting next presentation on the theme of adaptive reuse. I have Cheryl Saldanha, who's the Building Science Practice Lead at SGH, and Michael Syracuse, partner at FX Collaborative, to talk about NYU's Rubin Hall. Thank you, guys.
Great. Well, great to be here today. Thanks for joining us after lunch. So, we've seen a lot of interesting, engaging, high-performing, exuberant, expressive projects today, but I want to talk about Rubin Hall, which is really indicative of so many buildings across our city. 100-year-old building built in the 1920s as part of that building boom. And really makes up like the fabric, the texture, and the embodied carbon of our city today that we walk through every day. So this project is about taking this 100-year-old building and setting it up for the success for the next 100 years, just like the project we saw before this, but it's very applicable to a lot of different buildings across our city. So first I'll start with a little bit about the client. Obviously, the great projects happen with great clients, and NYU, New York University, they're one of the largest landowners in New York City, and they own over 200 buildings, 60,000 students, and what they do in terms of sustainability, in terms of construction, really has an influence on what we all do across the city, and they really see themselves as setting the model for what all projects should be. So in that regard, they also have an aggressive climate action plan. They've had targets of reducing their greenhouse gas emissions, and they've exceeded those targets with an overall goal of climate neutrality by 2040. So each project that they take on, they look at how can it contribute to these goals. So a little bit about Rubin Hall, as I said, constructed in the 1920s. It's a 16-story building, 150,000 square feet, 650 students. It's home to first-year students at NYU. And it's in the Greenwich Village Historic District, which brought in some landmarks requirements and influences on the project. The project goals were to preserve the historic character of the building on the exterior. There was no remaining historic fabric on the interior. Achieve Passive House and LEED certification. We're on track to be the largest passive house retrofit in the world with the completion of the project. Include all electric mechanical systems, be a durable and low maintenance building, construct it in 14 months because there was a finite window of when students moved out of the building and when students had to move back in, and maintain that bed count of 650 students. So those were the project goals. So when we think about existing buildings, we're dealing with an existing metric of an exterior envelope. And in this case, we had about 20% of that envelope on the facade was windows, 66% was walls or columns embedded in the solid walls, and then 14% of that is slabs. So those all started to influence what the performance of each one of those systems has to be. I'll start with the windows because while they comprise about 20% of the facade, they also took a lot of our effort because windows are obviously a key piece of the historic character of a building. We were fortunate to have a photo on the left from 1926, shortly after the building opened, that really became a reference for us in terms of what the building looked like. Because about in the 1960s, when NYU purchased the building, they replaced the windows with non-historically appropriate windows. That was before it was in the historic district. And this is the building on the right as we found it a few years ago before we started the project. So getting into the windows, there's lots of different aspects of design performance that influence what these windows would have to be, whether historic appropriateness to be good stewards of the building or as required by Landmarks Preservation Commission, things like configuration of the windows, the details, limits on how much we could change the glazing area from the original design, to performance, contributing to a high performance building. Goals of local law 97 compliance, passive house compliance, which influence things such as air infiltration, thermal performance, and then being able to maintain this building. It's a high-rise building. They don't want to be repainting the windows every 3 years. Things like accessibility. This is student space, so need to comply with accessibility requirements throughout. And then maintenance and operation of their geometric sort of constraints. It's tough to grasp the size from those photos, but these are 6 foot by 6 foot double hung windows, so relatively large, which comes into play in a lot of different ways. And then, how do you clean the windows from the interior, and other performance aspects. So as we had to sort of absorb this internally and talk with the client and our consultants about it, we also had to explain this to the general public, because we went through Landmarks Preservation Commission. And while Landmarks has seen passive house retrofits on Brooklyn townhouses and other low-rise buildings. They've not seen that for high-rise buildings that are high performance, and have high demands, high wind loads, and the maintenance concerns that this building presented. So we created a flow chart of why all these sort of typical solutions that come to mind were not applicable for this building, to explain it, again, to landmarks and the general public who was present at those hearings. As we started, we brainstormed as a team of what all the different solutions would be to operate the window, to get a triple glazed window, to have it meet all of those requirements. Brainstormed sort of every way that a window could possibly operate and meet these requirements. Then we eventually got it down to sort of 3 different options of varying operations to allow the ventilation in a swinging configuration, because that seals up best. A typical double hung window is not a good sealing window. Meet those accessibility requirements and also look like a historic double hung window. So it was critical that it had all the details and aspects and framing of those windows that we saw in that historic photograph. We eventually arrived at the solution on the right, a whole window tilt-turn configuration that we worked closely with Schuko on. Triple glazed, the entire window in a typical operation pivots in for ventilation, and then through a custodial lock can also swing sideways to be able to be cleaned. So you see here, drawing on the left of the original historic windows, our replacement window in the center, and the details of it on the right. Highlighted here are some trims that we added on in response to Landmarks Preservation Commission requirements and feedback to sort of make it, create some more shadow, make profiles, and create some more historic character to it. But really critical, and one of the big challenges was this offset glazing planes that would be characteristic of a double hung window. Here are some photos of a mock-up, early fabrication, and you can see these are super high performance. That's a significant thermal break in the framing. And this is how the building looked on the right when we first encountered it. These were the renderings that we shared with Landmarks. This is a photo from a few months ago when 650 students moved into this building as their first home in New York City. I'll turn now to that other 66%, the exterior wall. I shared this floor plan and that piece of information before that we had to still meet these 650 beds in this building. So it is a very dense building. It was the most affordable dorm at NYU, so we had to preserve that bed count. Most of these rooms are triple rooms, 3 students in each room, 3 dressers, 3 beds, 3 desks. So every inch counted in terms of insulation that we added to the exterior wall, and started to guide what materials and what that assembly would be. When we did some probes in the building, air infiltration, super critical to a high performance building. As we dug through the existing facade of terracotta and brick, we could determine that it was super leaky. I mean, you can see lots of holes throughout, a cinder-filled floor, and a big challenge of how to deal with that existing fabric. Oh, keep going forward. We arrived at a solution of that's shown here. Everything really comes together with fan coil units, insulation on the interior face, and those windows at that exterior wall. And we arrived at a solution adding a gypsum fiberglass face gypsum on the interior, spray foam insulation, a variable transmittance vapor retarder interior to that, and then gypsum board on the interior face of that. This is a photo during construction, maybe about 6 months ago, showing that spray foam insulation, the risers for the fan coil unit as well, before the interior finishes were installed. Some additional details of this, which we can go into in great depth, but with a limited time today, we will move on to the lessons learned during construction.
So with all that background, we're going to walk through some of the lessons learned, some of the major lessons that we learned, both during design and then into construction phase. So I'm going to go through the first 4, and I'm going to leave Michael to give the grand finale with our blower door test. So starting off with the window support. So the original windows on the building were single pane glass, steel frames. So pretty thin windows compared to what we were trying to put in, right? With this high thermally performing window. This photo is showing double glazing, but as Michael mentioned, we actually had triple glazing on our project. So much heavier windows, and we have to design them to withstand the new wind loads in the building code, right? The new New York City wind loads. So the attachment to the masonry wall surroundings came into question early on in our design. So we looked at some of these probes. Michael mentioned we have terracotta backup, we have some brick areas. And if we look closer, the terracotta backup is hollow and we have thin walls. So not the best substrate to attach these heavy windows to. Now, we could have, filled the terracotta with grout and done some pull tests on them, but that has, a risk to the schedule of the project, because if it doesn't work out, then we're kind of back to the drawing board, and that would have been a huge cost, and schedule delay would just not be good because students are going to move in. So what we did instead was we decoupled the window attachment from the wall. We used that metal stud framing that was going to be installed with the insulation at the interior. And you can see in the photos, we have heavy gauge framing around the rough opening. And we have these steel plates that are outriggers, essentially, cantilevering out, and the window is attached and supported to those steel plates. So we're no longer attaching to the existing masonry on the building. Next, we're going to talk about the plaster and insulation. So I'm going to start with the plaster, and this is related to the air barrier detailing on the building. So we were very fortunate. About a year before construction started, we were in the design process. NYU gave us a dorm room and said, go ahead and use this as a mock-up. Mock it up with your design concepts, and also so we can see what some of the finishes are going to look like. But it gave us a very helpful opportunity to understand a little bit more of what's going on. We actually blower door tested one room, and with the layers of paint and the plaster actually being pretty continuous, it didn't perform half bad. But as soon as we started cutting into it to do the installation of things, as you saw with some of Michael's photos, super air leaky, didn't perform very well. Also, when you zoom in on some of the details, we have holes where the electrical conduits are penetrating the wall, for example. Spray foam shrinks and it pulls away from certain surfaces. We tried using different membranes and tapes to try and reestablish continuity of the airtightness of this plaster layer. And in the end, we just realized, this plaster is giving us a lot of trouble. Remember, this plaster, most of it is original to the building from the 1920s. This is horsehair reinforced plaster. Over the years of the building not being conditioned in the summer, it's going through many temperature cycles, moisture cycling. That's causing it to deteriorate. It's debonding from the backup wall, so we have areas where it's blistering. Again, worried about the risk this presented on schedule, because if we were to try and go in and patch areas, it might just, unzip the whole wall and be a real risk to the project. So instead, we attached a 1/4-inch thick layer of gypsum board, fastened it through the plaster, and used that as our air barrier. That was our primary air barrier on the building. And all the yellow lines that you're seeing there, those are just air barrier tape strips at the perimeter edges of the board. And here's a photo during construction of it. So you can see all the membrane strips. We patched all of the fastener holes to make sure that this plane would be airtight. Going back to this for a sec, on the left-hand side, there's a photo there showing the plan view of the demising walls. So between each dorm room unit, we have a wall that intersects our exterior wall. We weren't going to be demolishing that, so our air barrier detailing actually turned onto the demising wall on either side and connected with the interior finishes. So basically every dorm room has to be its own box detailed to be airtight. And so we repeat that on every floor, all the way up the building. But then we get to the top of the building and the bottom of the building. So the top of the building, we have a penthouse. There's penthouse apartments up there. That's highlighted in pink because that was a later phase. So we were doing the initial project for all the main dorm rooms. But we had to pay attention to the air barrier detailing at that roof level and how we were going to phase in the penthouse later. Then down at the cellar level, so the left-hand photo there is actually a plan view of the cellar. So you notice the air barrier detailing here in the thermal envelope doesn't extend to the outside walls there. Reason for that, just like every typical New York City building, we have a lot of sidewalk vaults and light wells. Very difficult to get those to be airtight and thermally insulated. So we went with an interior partition inboard of that so that we had a nice plane, we could get everything to be continuous and well sealed. All right, now let's talk about insulation. So we know we're adding insulation on the interior side of this old masonry building. We got to think about what are we going to now do to that masonry. So we actually took samples of the brick, sent it to our lab. We took the material properties, plugged that into a computer simulation. We simulate different temperature conditions, moisture conditions, weather conditions over the course of a year, and then check out different scenarios of types and thicknesses of insulation, as Michael mentioned earlier. The tight, trying to fit all this furniture in the rooms, we have to be very careful not to get too thick with the insulation. But at the same time, we're trying to meet passive house here, and we need to offset all of the thermal bridges in our envelope, right? The slab edges, we can't insulate across those demising walls. So we had to kind of dial in the insulation thickness to provide the thermal performance, but not cause issues to either the masonry or increase the condensation risk. Because when you add insulation, you increase condensation risk. So in the end, we had two different thicknesses of insulation, different insulation thicknesses on different sides of the building, again, to account for the rooms that needed to have that tight insulation or tight furniture layout fit. On the right-hand side, this is an infrared shot from like February before we started construction. So this was like 20 degrees roughly at nighttime. So just showing you kind of what it looked like before. We're hoping this February we can get another shot so we can show these side by side so you can see the before and after. Really excited for that. Okay, so with this next lesson, and I know this is really tiny on the screen, you're not meant to read it, so don't try and strain your eyes. But really important lesson on this project was our contractor partners. So we specified to have what's called a building enclosure construction manager as part of our team. And what they did during the, both during the bidding and then also the submittal phase of the project, they just very simply color-coded the different materials and systems based on the different contractors that were going to help us out. It's a very complex detail with all these insulations and membranes and tapes all coming together at this window that's cantilevering out into this rough opening. How do we make sure everything is connected and sequenced well? We had a carpenter, we had an insulation installer, we had the window installer, we had the waterproofer. So again, having these color-coded documents and then having several meetings where we all kind of looked through each other's shop drawing packages together, make sure we knew who was going first, second, third, so that when we got on site and did that mock-up, it went much more smoothly. So then we did the first mock-up all together. We also tested it. So we specified including window testing. This is your window sort of air and water tests on the building. But something different we did here was not just testing the window on its own. We also included that perimeter tie-in to the wall, right? So all that complex detailing that's coming together at the window-to-wall interface, we made sure to include that with the air and water tests to make sure that we were getting the performance that we know we needed from the project. And we didn't just do this at the mock-up, we also did it regularly at certain milestones throughout the construction phase. And with that, I'll hand it back to Michael to get the big finale of our blower door test.
So, at the end of the day, like I mentioned, students moved in 2 months ago. We achieved, passed a blower door test, decreasing the air infiltration from 6 air changes per hour in the original building to less than 1 air change per hour, which is just below the passive house threshold. We end up with a building that's over 39 EUI, which is 56% less than a sort of typical building, code-compliant building. That was our baseline. We, with the all-electric systems, we have an operational carbon that's 45% savings over a typical building versus when using today's electric grid. And we've constructed a project that meets local law 97 requirements, no fines through at least 2034 and likely past that as well. They just have not achieved those. They have not set those expectations yet. So Really, again, it's a project that can be a model for so many buildings as we think of what their future can be in New York City. So thank you.
Great. Thank you so much, Michael and Cheryl. That was a really engaging talk about, as they said, there's so many projects in the big city of New York that could all learn so much from that presentation. So next we have Bob Zhang, who is the sales director of North Glass, and he will be telling us about the global trends of architectural glass facades. Thank you very much, Bob. Welcome.
Hello everyone, this is Bob from North Glass. Thanks for Zak World of Façades to having us here, and thank you for everyone joining the sections. So talk about North Glass. We are actually a innovative glass fabricator. We are located in China, and the North Glass was founded by 1995. We're almost 30 years, and actually we're starting from the tempering furnace business, and we are turning to the glass fabrication in 1999. We start our first glass fabrication facility in Beijing, and also we do have different glass fabrication facility in Shanghai and Luoyang. On 2012, and we moved from Beijing to Tianjin because we need a much more bigger space to build some bigger machine and to make some bigger glass. 2020, we are successful upgrade all of our machine up to 80 foot. Today we're going to talk about a couple of sections, something about standard curtain wall glass, and we're going to talk about something about curved glass, jumbo size glass, and the last section we're going to talk about the special glass. So about the curtain wall product, I mean, we do have some job reference showing here, like Leidenhall buildings, the Chaoyang Park Plaza, One Blackford, other Duda House, and also Corey Cut-Up Towers, 2 Tokyo Place, Blue Front Shibara, which in Japan, and also the National Bank of Kuwait. So we're going to talk about more detail about some of the project, but the project we just showed, we do have different type of low-E product we have been used. We work with Guardian, we work with Saint-Gobain, we working with PPG, we work with Vitro, which was PPG, and also we do have our low-E coating as well. Next page, we are showing about something like North Glass in-house coating, which is most popular coating we had using on the previous job. We have pretty much standard reflective and the VLT of the coating product. Some of the project like the Two Taikoo Place, this project is in Hong Kong, and we had over 300,000 square feet glass. The specialty of this glass is you can see a lot of glass panel is 10 feet by 10 feet. So the best things we did for this project is we developed a special type of tempering furnace which is really helpful for like square glass, and you can see the reflection on those images. At the lower images is the glass was making very flat. That's make our client is extremely happy. That's give us a better opportunity on the future projects. West Cologne Terminus, this project is in Hong Kong as well. Pretty big project overall. We had over 600,000 square feet of glass. We have North Glass low-E coating. We have North Glass solar control coating on the glass. And it's pretty much similar kind of challenge for us is we do have a lot of square glass. And also, if you look at the top and the bottom building, you see a lot of shaped glass, and also that glass is curved. So how to bend in the glass is one of the things we are very good with. Showing some other project we did in North America, the Google Bayview at the project in Mountain View, California. And we did 75% of the project. You can see the project glass is not very special, but one of the important things is the glass performance, because this is in California, very strong sunlight. We have overall around 67% of VLT, and the solar Huygens is only 0.28. Keep talking about some project we did internationally. Mobility provision, we finished the project by 2019. We had around 40,000 square feet of glass, which most of the glass panels curved. It's just single curved. Back to some project in the United States, Resnick Sustainability Center at Caltech, and also the Yale's Tower project. So when we talk about the curtain wall product, one of the important things is the appearance, about the flatness. That's what we just talked about. And another important thing is about the warranty of the product themselves. So when we talk about the insulating glass, we have two pieces of glass, and we do have spacer in between of the glass. So next, I'm going to talk about one of the advanced spacer technology which we are using for most of our curtain wall product, which is 4SG wall match spacer. So the 4SG spacer, it's one component spacer, which compare with traditional spacer system. We have aluminum spacer, stainless steel spacer. We have to apply the PIB on the spacer. And when you see on the image here, during the day and night, when the temperature change, the glass will be expanded and squeezed, and you can see the PVBs keep moving. That's potentially a risk for the glass to have the gas leakage. And this percentage, if we put argon in, that means argon will lose pretty quick. But with the 4SG spacer, what we tested about the 4SG spacer, the gas leakage rate is actually lower than 0.1% for each year. And another thing about the 4SG spacer, it's extrude spacer. It's one component extrude spacer. That means we are very flexible with the shape of the glass, because when we're making the ideal glass, actually we have the first piece of glass set over there. We have the machine to extrude the spacer on the glass surface. And then we put the glass together. And also the 4SG spacer is kind of chemical bond with the glass surface. So thinking about when we make a curved glass, or when we make a 3D double curved glass, between the two-piece glass must be some tolerance. With the traditional spacer, after you apply the silicon, when the temperature changes, the PI began to moving. But with the 4SG spacer, because it's chemical bond, the longer time we have the glass unit, will be more solid bond in between of the spacer and the glass. Next stuff. Okay, so talk about jumbo glass. So when we talk about jumbo glass, I think we never can get away from the Apple. I mean, we really appreciate Apple to pushing us to increase our limitation of the glass. This is the Apple campus project we finished on 2016-17. We totally did 718 pieces of glass, and it's roughly around 150,000 square feet. The smallest size of glass on that project is more than 20 feet, and the biggest glass we did for that project is over 55 feet. So again, talk about jumbo glass. I mean, on 2010, it's actually a year has to be memoried for North Glass people. This is before 2010, we are making curved glass. We are talking about 8 feet by 15 feet. But by that year, we did the Shanghai Pudong IFC Apple store, which we actually push our limit. We built a new machine. We develop a new technology. We push our limitation from 15 feet to 40 feet. So that's actually the first curved glass with 40 feet in the worldwide. And lately, 14 years later, Apple decided to reduce the Shanghai IFC retail store. And luckily, we did a project for Apple again. and pretty much similar design, pretty much similar size of the buildings. But you can see from interior, right-hand side was the old buildings already been taken off, and left-hand side is the new buildings. The difference is Apple decided to remove all the fins, and we have much less connection in between of the glass. And to make the building is more transparent here. Yes, size-wise, I mean, again, from the very beginning, we almost same as everyone else. We do the glass by 8 feet by 15 feet. That's the maximum size. 2010, we start from 1999. In 2010, we go to 40 feet, actually 43 feet. And the 2020s, we go to 80 feet. That's both for flat and curved glass. And at the meantime, we built some interesting machine which can have the glass have up to 27 feet arc length, and the width of the glass right now we can do with 4 meters, which is over 13 feet for each piece of glass. A lot of people come to ask if we can find 13 feet wide float glass. The answer is yes, we do, and we did something already. Keep talking about jumbo size glass. One Tokyo place, it was the biggest structural glass in Hong Kong. It was, and the glass was 40-something feet. I know it's more than 12 meters. It's 45 feet roughly. National Museum in Berlin, Germany. That project from the image, probably you cannot tell what the specialty is, but actually that glass the width of the glass is almost close to 12 feet wide. 12 feet wide, which close to 3.6 meters. And we did that project, I think, before COVID sometimes, something 18th or 19th. Yeah, some more projects with oversized, the Beijing Library. This is actually, until now, that's the biggest structural glass project we narrowed down. We have roughly around 80,000 square feet glass for like oversized glass. The biggest panel you can see is over 50 feet tall. And that project was really quick. It's around 80,000 square feet of glass. I believe we finished the project around like 3 months from the date we start to complete. Okay. Next one, the last jumbo size glass project. So Guangzhou Chamber Commercial Centers, that's actually the biggest glass we never made. The glass is 77 feet tall. Yes, it's pretty big glass, and yeah, a lot question again, how can we ship it? Can we ship to North America? Can we ship to other places outside of China? Yes, the answer is yes, and we do have very professional logistics who's very experienced to transport those kind of product, and yeah, that's the people who's professional to do the job. Quick talk about some curved glass project. Yeah, 2050 M Street project, that project I did on 2019, Rex Architect project in DC. We have roughly around 1,100 curved units, all the same radius. And we have reflective coating, very high reflective, around 30%. And also we do have low E coating on the surface number 2 or 3, surface number 3 as well. So yeah, just some pictures. People coming to the factories, inspect the glass, see the quench marks. Next project, the Pantry Hotel, not far from us. That's one of my favorite project as well. All the curved surface. We have concave and convex bent glass. We have tinted glass. We have North Glass in-house coating. Denver Art Museum. I love this project as well. I just like curved glass project. a lot. Sorry. Around 25, 27 feet glass. All the glass is convex bend. Very transparent project. It's nice. It's nice building. It's worth to stop by in Denver one day to give a look. Old project we did on 2016. The reason I'm still pointing out this project is because you can see we have like W shape in middle of the buildings. That means we have concave, and we bend the glass back concave, and also we have to bend the glass back concave way as well, because we do have two different type of low E coating on the glass. And back to that time, the concave and the convex bending is still kind of challenge. I think right now, probably some more people can do it, but we still think we are the best, one of the best to do the curved glass. Okay, so exciting point here, special glass. We're going to talk about something more than curved glass. We would like to call it free-formed glass, curved glass and some point is complex shapes, and also the laser grooving. So this is something for the grooved glass. We're using some new machine to make a laser machine to do the grooving, and also tempered glass with like super tight radius. And the last thing is the casting glass. Casting glass is really nothing new, but we just start to making casting glass again, and let's talk about that at the end. New performance art venue in Australia. So in generally, if you don't know this project don't look special. But let me tell you some story. So for this glass, the height of the glass is over 20 feet. And roughly is around 23 to 24 feet, I believe. And the radius of the glass is 5 feet. But at the same time, glass is pretty wide, so all the glass is half cylinders, it's half circles. It's perfect half circles. Thinking about your experience to talk with glass fabricators, a lot of glass fabricators say we do curved glass, we can do 25 feet. Yes, a lot of people can do it. But thinking about the piece of glass, half cylinders with 5 feet radius, that's something I think only we can do it at this moment in the world. And yeah, my boss went to the job site, I think a couple of weeks ago, and he took some pictures. Unfortunately, I forgot to put a picture in the presentations. Next project, Louis Vuitton in Japan. It's hard to see how special of the project, but look at the entire facade of the building. We do have quite a lot of regular flat glass, and also we do have curved glass and double curved glass at the top and bottom of the buildings. We do have digital print on the glass surface, and also we do have Louis coating on that. Pretty large luxury brand retail store, and that's one of the things, one of the kind of project we did a lot. I'm not sure how many people know this project. It's pretty amazing. It's a big project, 2 buildings. Overall, it's over 600,000 square feet of glass. We are currently processing that project right now. You are the professionals on design, consulting glass, and you will able to tell from the shape of the building how many curved glass there it is. And same times, I wouldn't want to tell you how many different size radius of the glass we have. But in general, 600,000 square feet glass with a big amount of double curved glass. Yeah, again, talk about free-form, double curved, or 3D bending. I don't know which words you like, but we generally talking about one kind of product which is bending by different directions, bending by different radius. And the good thing is with North Glass, we are starting from tempering furnace manufacture business. We are very good on machine designery, and also we design our own machine. And actually, for last couple projects, what I just showed you with free-formed, double-curved, 3D curved glass, we make it as all tempered glass, all heat-strengthened glass. That's one of the things to make the project much easier when you think about wind load or all kind of structure considerations. This is a Huawei project, Red Beam. I don't know where it is, but I know it's in China. And the challenge for this project, we have concave double curved, and also we have double curved glass bending by the convex way. So when you see the red area was convex bending and the blue area was concave bending. Nike project was complete by 2018. I still put this project in the presentation. It's ready because of this glass is one of the complicated applications for a single IGU unit. So when you look through this glass, you can feel a lot of bubbles on the glass surface, and also we have like a V-grooving on the glass surface as well. So go to next page, you probably see something on your left-hand side, right-hand side, sorry, my left-hand side. And we have V-groove on the glass surface, and also the glass surface was slumped by a kind of wave. And after that, we did chemical tempering for that glass because we just, from our understanding, back to that time, we cannot do heat strengthening for those kind of shape, and we decided we do chemical tempered for the outboard light, and the inboard light was piece of flat laminated glass. Finally, we make it IGU, and the contract put on the buildings looks pretty nice. Something about the curved glass, tight radius. So a lot of people will ask me if this is annealed, is slumped, annealed, or is it tempered? The answer is yes, this is tempered glass. And the radius of the glass, around 4 inches. Yeah, 4 inches, like this big. So yeah, we can make it up to 20 feet for H pieces. A lot of people like to use for like exterior wall, and some of the project like the National Speed Skating Center, which was using on like lead tubes.
Do you have that many more slides?
Yeah, one more slide, almost done. So sorry about that. So last minute talk about the casting glass. Casting glass was, the product was in the market for many years, I think probably older than me. And we just recently to restart doing casting glass by ourselves. And we are able to do custom patterns, different shapes. We can make it like really big, like up to 27 feet is current size we can do. And also we can do bend. We can bend the casting glass as well. We can laminate the glass. We can make it like insulating the IGU unit as well. We do bring some samples in our booth. If anyone interested with casting glass, please come stop by, and we love to show you something. All right, thank you so much. Thanks for everyone to be here.
Thank you, Bob.
Thank you.
All right. Sounds like Bob is challenging the designers in the room to make things curvier and bigger to see if he can do it. So thank you very much. The next we have Alberto Alarcon here from Carrare, and you will tell us a little bit more about embodied carbon. Thank you very much.
Thank you. Hi. Sustainability, embodied carbon, carbon footprint, climate change. This topic today, this is not going to be the section on my presentation, and I have 15 minutes to talk to you a little bit about laminated glass, carbon footprint, and how can we match these two topics together. Bob did a very great introduction to laminated glass, and he said that we can keep away from Apple, and I think that's very true, and you will learn why today. Again, my name is Alberto Alarcon. and with Curary, the advanced interlayer solution. And let's go talk about the numbers first. So CO2 emissions. Our industry is responsible of the 39% of the CO2 emissions. 29 of that part is more with the operational carbon of the buildings, and I think we have done a lot of things around it. But the 11% is related to the materials and the construction. If we took a closer look to this, the facade is 15 to 30% of the carbon emission. Of course, the superstructure and the substructure is the most part of it. But in this 30%, a 7th part is related to glass. So before to go into how we can improve carbon footprint with glass, I will talk a little bit about the history. Laminated glass, I'm sure that everyone in this room knows what's a laminated glass. In case you don't know, it's a sandwich. It's 2 plies of glass and plastic film, we like to call it interlayer, that goes in the middle. And when you put multiple plies of interlayers and glass, you can have like multiple laminated glass. And this interlayer provide safety, was the reason what's invented, safety glazing. But you can also give other performance to the glass, like colors, acoustic performance, and special applications, like is the topic of today. So let's talk a little bit more about the interlayer and how it came to our world of construction. So it started this invention by an accident a lot of stuff we have today was invented by accident. Laminated glass was invented by accident too. In 1903, there was a French guy. He was a chemist. He was a painter. He did a lot of stuff. And when he was doing his paintings and stuff, he has a flask of glass. And he put methanol, he put methanol, but he also put cellulose nitrate inside of this glass. And he forgot about this glass. It evaporates with the time. And then one day he dropped this glass. And he realized that all the little pieces of glass would stick together. So this was the very first laminated glass. And he didn't do anything related to this until 1909, when he was reading a newspaper. He saw that there was an article about the windshields of the cars. It was just a new glass, and it was very insecure and causing more accidents than the collision of the glass. So he patented this. He put 2 pieces of glass with nitrocellulose, and he patented, and he called it triplex. If you know a little bit about chemistry, was not a great solution because nitrate cellulose is explosive. So eventually, PBB came in place in the 20s, and today all the windshields of the car is with PBB. So then it evolves with different other materials. So in 1992, Hurricane Andrew hit Florida as a Category 5. So the market realized that we need something stronger, some stiffer, that can support, the loads, the wind loads, and also the impacts of the flying debris. So in 1998, DuPont invented Century Glass, and then about 10 years ago, Curary acquired that division of DuPont. And then other materials came in game, acoustic performance, wear-friendly glazings, and also sustainable interlayers. But this is part of the history and the applications. So luckily you have 2 persons responsible in this room. I think I saw James somewhere here a few minutes ago. But yeah, we have this material for hurricane glazing. But then, as Bob said previously, we can't get away from Apple because Apple was one of the responsibles. Steve Jobs was one of the responsibles to push to keep these structural interlayers as structural glass. So in 19 I forgot the date, but well, the first Apple store was in 2000. was 2001. Was 2001 the first Apple store. And then Steve Jobs realized that he needs something to catch attraction and invite people to come into the building. So with the technology available for hurricane glazing, and one of my colleagues, Steve Benninson over there, and James O'Callaghan, I think I saw him previously, they developed the know-how to bring this technology for structural glazing. Then this Apple Store was the first structural application, Soho Store, and then with other players in the game, they realized that they want bigger glass. As Bob mentioned, there was no technology over there, so it was a curious story that the first big autoclave they used was made for the wings of the airplanes. So so this customer in Germany, they asked permission for use this autoclave for the first biggest glass, and then in 2012 they rebuilt the glass stair, and they make it much more clean. They reduce the connections, the metal connection. They reduce also the amount of glass. And the main reason, and I'm not going to get into the details, it is called the deflection coupled value, is how the glass performs with a structural interlayer. It's not the same with the PBB center glass. In a knot, it allows the glass to be 20 times more stronger to the bending. So you can do structural glass with it. And another example I always like to talk is about this cube. The first, in this picture, you can see, now maybe you can recognize this structure. So the first time they used center glass, they used PBB to build this cube, this glass cube, and then they rebuilt it in 2011. So this is how it looks now. So it's kind of the same thing as the evolution and the application. It had been, this is the second design. It has built 3 times now because a glass was broken in 2014, and they need to rebuild this Apple cube. But you can see that here is because of the center glass that it doesn't matter, the glass is break, it preserves structure and stay in place. So that's the benefit of this type of structural glass. Then we have other different projects like this one, the edge, all the glass guards, glass floors, also with center glass. But what I want to say with this is that, yeah, maybe I talk a little bit more about structural glass, but the thing is that if we use the same technology for structural glass for more common application, we can down gauge the mass of the glass. And now we have the commitment in Cura, in the AIS division, to reduce it in our carbon footprint in 75% by 2030, and we're going to be net zero by 2050. So we have put in place a lot of things. We have put, we measure, we make the life cycle assessment in our facilities, and we can have now the values of how much embodied carbon our interlays have. So you can see here that PBB is a little bit higher than center glass. So that's one benefit. Center glass is with lower carbon footprint. And well, we made this. This is life cycles assessment. It's cradle to gate. Is what is possible now. We have the EPDs available on the website. But with this technology, we can make all the calculation, replace PBB from the laminated glass, like in this example. And with that, with calculating the wind load and calculating the line load, you can see that I'm not going through the math, but we've reduced from a 12 millimeter heat strength glass to a 10 just by switching the interlayer. We also were available to reduce the thickness of the interlayer. So when you put all that and calculate the carbon and void of the glass, of the interlayer, and in this example, we are not talking about the metal, because with center glass you can also remove the top rail, and there's another benefit. So with this, just switching the interlayer and the thickness of the glass, we're reducing 23% the carbon footprint. This is just a railing, of course, but we can also do it in bigger buildings, in taller buildings, like in this case, for the Montparnasse Tower in Paris, is still in concept design. They're supposed to be built by the Olympics, but of course, they didn't have it. But there's a study made by TESS, and they make this same example. So they know all the facades, and they know the wind loads in the very specific areas. They design, and they took the most efficient coating wall in terms of modulation. They calculate the wind loads, they calculate each facade, and then they made the same example of the balustrade. They switched the interlayer for PVB to center glass, and they realized that they can have the benefit of the carbon footprint reduction. So they reduce in 15% from the facade carbon and void. So in the previous example, we can see that just by switching the interlayer, you can reduce the carbon footprint. You can be lighter in the structure. I mean, I talk about the glass mass, but you can also reduce the metal connections or the metal framings. And with that, you can have also more flexibility in the design. So that's part of the with the center glass, and I'm very happy to announce. I'm not allowed to tell because the launching of this material is going to be next week during Glass Tech, but we're almost there. But we have developed the first low carbon footprint PVB. You can reduce in 90% the carbon footprint of the interlayer.
Sustainability is no longer a choice. Industries are urged to reduce their carbon footprint. We're not just responding to this call, we're leading the way. Introducing Trossifol R3. Reduce, reuse, recycle. Crafted to reduce emissions and drive innovation, R3 symbolizes our commitment to cutting-edge technology and environmental responsibility. Designed for both architecture and automotive without compromising performance. Is not just crystal clear. It's carbon clear, reducing CO2 impact, with full transparency for informed choices. Trossifol R3 offers up to a 90% carbon emissions reduction. Every step is a commitment with our planet. We're improving our packaging solutions to build a more sustainable future. We're aiming to reach 35% returnable packaging by 2024. Initiatives to enhance transportation efficiency and reduce CO2 emissions have already been implemented. We focus on reusing and recycling cores, wood packaging, P-film, and other recyclable, reusable materials. Lead the future. Lead the future with Trossifol R3.
And time. I did it in 15 minutes. So thank you very much. If you have any questions, we have a tabletop outside, and be more sustainable. Thank you.
Great. Thank you so much, Alberto. Great. So now that we've learned about laminated glass and its embodied carbon, we'd like to bring up David Hewitt, the Director of Business Development at ES Windows, who is going to tell us something that maybe Bob Zhang doesn't want to hear. It's about making glass flatness a standard. So, David Hewitt.
Good afternoon, everybody. Again, my name is David Hewitt with ES, and we're going to talk about making glass flatness the standard. So just what we just saw a minute ago with Alberto was interesting as far as the the amount of laminate we're seeing in today's markets. And so we're going to go through the abstract, which is basically to talk about the process and how to ensure that the glass flatness is superior on a building. But before I do that, I want to just talk about the way things have evolved over time. So obviously, you see the oculus here and the cathedral in Reims, France. Originally, there was no glass, right? So it was just openings that were designed in buildings to allow daylight to come in, right? So then, obviously, leaded glass in the cathedral became, centuries later, a popular form for diffusing daylight into the building. And then you can see the Flatiron Building, everybody's familiar with that one, and also the Rockefeller Center. Those are buildings that early skyscraper technology allowed the use of glass to be more prominent. But it still was punched openings in small lights. So glass IGU coating technology, I should say IGU technology as well as what you saw from H.B. Fuller, and also the coating technologies allowed more glass to be employed on facades. And then today's architecture, we see larger lights, which you saw from the previous presentation, very large pieces of glass, and much more daylighting being employed. That's an example of a project we did in Miami. I think it's Norwegian Cruise Lines. So the market demand, basically, we're seeing larger glass, but we're also seeing higher wind loads. So whether it's hurricane impact area, coastal areas, or just taller buildings with geometry that creates end zones that create much higher wind pressures. So that makes the glass even more important to have heat treated. So the other thing is the technology in these low E coatings, and in order to keep the radiant heat out of the building, these reflective low E's are more prevalent as well. So obviously that can amplify distortion in the glass. And then we see hurricane impact, of course, and then acoustic. In every major city, we're seeing a lot of acoustic glazing being utilized, as well as security. And you can see in the picture there the autoclave of, it's not quite as big as the last one we saw, but that's a typical autoclave. So what causes the glass to be distorted? Okay, so it's going to be the glass thickness. Oftentimes we go to 8 millimeter or 10 millimeter on the outboard light to alleviate that issue. Also, the barometric pressure, changing elevations as it's produced to where it's being installed. Multiple plies of heat-treated laminated. So when you have any distortion in the glass and you have 2 or 3 lights as a ply of laminate, then you amplify that distortion. So another reason why it's very critical with laminated glass, and that's a good time to have a visual mock-up. Also, the reflectivity I mentioned from the low E coatings, you can see the distortion very easily if it's reflective. And then surrounding buildings can amplify or magnify the distortion that you would see as well. So let's get into the process now. Understanding heat-treated glass. So heat-treated glass is basically just either heat-strengthened or fully tempered glass. And many people may know this, but just to cover the basics here is when you're talking about heat-strengthened, it's 2 times stronger than annealed. We rarely see annealed glass in architecture anymore. Sometimes you'll see it in punched openings with windows that are higher than 42 inches off the ground, in like single-hung windows, for instance. But generally, it's going to be heat-strengthened, mainly because of the coatings. The coatings absorb heat, and the difference between the edge of the glass and the center of that glass, you've got to have it heat-strengthened. Tempered is roughly 4 times stronger, and then therefore it is safety glass. So the reason it becomes tempered or safety is because of the compression level, the surface compression level of the glass. So when you're dealing with heat-strengthened glass, it's between 3,500 and 7,500 psi. And then the higher level in tempered is 10,000 or greater psi. So all that stress on that surface of the glass is contained so that if anybody's ever seen a tempered light break, it breaks into small pieces, as you can see on the picture there. That glass becomes small pieces that become obviously safer than annealed or even heat strengthened. The instrument to the right of that break pattern is an instrument that determines the stress level of the glass. And if anybody's ever seen somebody else walk into a sliding glass door that they think is open, they'll bounce right off of it. So that's how strong tempered glass is. Obviously, if you take a sharp metal object and tap it, it'll explode because all that surface compression is released. So tempering standards. These are the ASTM 1048 is the one we use for making sure that it complies or exceeds that standard for what gets produced and then shipped into the field. There's another standard there, ASTM 1651, for roller wave distortion, and I'll talk about that in a few minutes more. And then the European standard EN 121-150. These are all standards that glass producers and temperers adhere to. The tempering oven itself, there's a wide range of types. Convection is the most popular. They blow hot air onto the surface of the glass as the glass is conveyed across ceramic rollers into the oven. And high-speed continuous is the most common. You can see a picture here of what a high-speed continuous tempering furnace looks like. The ceramic rollers that it rolls on, and then going into the load end of the oven. So the tempering process can distort the glass. That's because all that stress you introduce to the surface of the glass, you can get distortion on it. So it's obviously a lot greater than annealed, but again, we don't use much annealed anymore in architectural. There's several measurable items that we look at when we take tempered glass into the factory, and that it would be bow, warp, peak to valley roller wave. And that peak to valley roller wave is basically, I think there might be another slide here that explains it, but that is as the glass heats up, it sags on those rollers, and that's what causes that roller hearth distortion. The key here for the QA/QC of making sure you have the flattest glass possible is to get the best raw glass or float glass. So that's on ASTM 1036, which has specifications for defect-free float glass to start the process to the heat treating process or tempering process. So if once the glass is cut, if there's any fissures or any oysters or anything on the edge, it can break in the oven. So what you do is you basically run it through a belt sander as part of the process, and you seam the edges. Then you also wash it. So washing it is critical to make sure there's no defects on the surface as it gets heated up. And then that's when the tempering bug or the ANSI Z97.1 or Consumer Product Safety Council information is on the corner of the glass. It's either sandblasted or ceramic frit. And that's what designates it as safety glazing. Most manufacturers will also have their logo or their brand name or other information as far as the production runs. So the key to making sure this thing is good quality in the field is making sure that every light is 100% inspected. And I'll show you how that's done here in a minute. Obviously those rollers, because of the glass becoming semi-molten as it goes through, have to be free of any defects or any debris. The glass is heated up to 600 plus degrees, 650 degrees Celsius or 1200 degrees Fahrenheit, so it gets semi-molten. And then it's rapidly cooled in the quenching process. And the quenching process is what introduces that stress or that surface compression to the surface of the glass. So if it's heat treated, if it's heat strengthened, it's cooled more slowly. If it's fully tempered and you want to be greater than 10,000 PSI, then it's cooled more rapidly. And then that's how you get the surface compression over 10,000 PSI. You can see a break pattern on that picture there. The other scenarios, well, as I mentioned, the glass can sag on those rollers. So there's some tempering ovens that we use that actually float the glass with air below so that it doesn't sit on the rollers as much as it would on a more traditional oven. So that helps create the ability to keep the glass as flat as possible. So architectural quality, it wasn't that many years ago that it was 5/1000ths of an inch. Now the standard's 3/1000ths of an inch. As far as the center of the glass, 8/1000ths at the edge of the light. And then bow and warp is less than a 1/16 of an inch over 12 inches. And you can see in this picture, the technicians are using a straight edge to measure the bow. traditionally, and these are still employed even with high-tech instruments, but traditionally we've always looked at doing the flatness by zebra board. So the zebra board's at the off end of the production run of the oven, and you can see on the left the diagonal lines that are in the image are flat, or straight I should say, and then on the right they're wavy. So you got a pass-fail there just on visual. You can also use a handheld micrometer to measure the peak and valley across the light of glass. And we still use these on the line, but now there's new instruments that provide digital imaging inspection, like a Light Sentry or Osprey, that measures the glass surface and creates a topographical map of the glass. So you want to be below 120 millidiopters or even 100 millidiopters as far as that topography that you see on that glass that is read by a laser. And it also measures anisotropy. So if anybody's familiar with anisotropic, that glass is an iridescence that you see. If you're wearing polarized sunglasses on a sunny day and you're looking at the facade, you'll see that iridescence, or you'll see that strain pattern that is introduced in the tempering process. This instrument will measure that and reduce that, and also again, the ability of the machine to float the glass over those rollers helps reduce the iridescence. And I believe there's probably, I know there's being codes developed or standards being developed for that. So again, 100% inspection, making sure every light complies with the flatness, that the internal specifications, whether it's 0.003 of an inch, whether it's less than 120 millidiopters, you want to make sure that each light is tested for that. And again, those standards, 1048 and 1651, are the standards that are our minimum. You want to exceed that, okay? There's oven sensors. So for statistical process control, there's oven sensors that run back to the computer system on the tempering furnace that the technicians use to monitor continuous, to make sure there's nothing, an anomaly causing the flatness to increase or distortion to increase. So float glass and oven manufacturing certification programs, we do that with paint suppliers. Our PPG paint suppliers does it for us. They audit our lines, and we also have the equipment manufacturers on the oven audit our lines, as well as the float glass. So the whole idea is you've got partners in the raw glass, you've got partners in the equipment that tempers the glass, and you've got partners in doing those audits to make sure that it's a continuing education, in essence, for the people that run the lines. So operator continuous education training, I mean, that is super important to make sure that the operators are doing it the right way and repeatedly. And then they got to have the total quality mantra of making sure that they want it to be perfect before it goes out the door. So preventive and regular maintenance, PM, on these machines and these ovens is crucial to make sure that you can get the best output in the flattest glass possible. Also, multiple tempering ovens. So basically, when you take one down to do PM, you want to keep your production running. Obviously, you want to do it and still run your business. So that's crucial to have multiple ovens. The 3 Ps, people, process, and product. I mean, basically, people must know the process for creating the best quality and flattest glass. And the process should be repeatable, so it should be consistent. So ISO certification is good for that. And then the product's got to be something that can be done repeatedly. When you get into heavier glass, or when you get into multiple plies of laminate, then you've got a situation where it's more difficult to repeat that process. So it's the product as well. So those 3 Ps are crucial to getting a successful flat glass. And then finally, this is just some bad graphics there, I guess. But anyway, that is a example of low distortion heat-treated glass. That's spandrel glass that is tempered, and that is heat-strengthened coated glass in the visionary. But that's the end result. I think if I probably went through quickly a slide earlier where I showed a project in Washington, D.C., where you could see the reflectivity across the street, and it was very distorted. So this is a 4-sided structural glaze system, which helps if you're dealing with a pressure wall that has pressure plate and it's four-sided capture. Sometimes you can get a little distortion around the perimeter of that pressure plate. Four-sided it doesn't have that pinch point along the glass. And that is it. Thank you very much.
Great. Thanks so much, David.
Thank you.
So I guess there's a saying that you measure twice and cut once, and maybe you can say zebra board twice and install once. All right. So thank you all for staying with us. We are now switching over, and I know many people in New York have, there's a lot of jokes made about our airports, but now we apparently have some of the best award-winning airports in the world as of last year. So here to talk a little bit more about facades and aviation is our moderation panel, moderated by Tali Medjakovsky. So I welcome the panel to the stage, and I think in a second we have to also set up some chairs. So maybe I can take a vote. Who likes the new LaGuardia terminal? Which terminal in LaGuardia do you guys like best? Actually, do you guys like LaGuardia best? A show of hands for LaGuardia as the best airport in New York. What about JFK? Anybody for JFK? No? Not yet, right? And then finally Newark, the new Newark terminal. All right, I think you're from New Jersey. Just kidding.
Hi, everybody. Thanks for staying for our panel. Thanks to Zak for inviting us to have this panel. We're focusing a little bit on a specific building typology today with airports, and focusing a little bit more on facades and aviation. And as we were just introduced, there's been a lot of activity in New York with the three major airports, new construction at each of the three, LaGuardia, Newark, and JFK. So we've assembled a really great panel today covering all aspects of the facade industry. So we'll give quick intros so you know who each of us are and talk a little bit about our experience working in aviation. I need the clicker, which is somewhere, I think. Or I might use this. Right, so, and then we'll just have a discussion about some topics specific to do with facades in airports. And hopefully at the end we have time for some questions as well. So, quick intro for myself. I'm Tali Medjakovsky. I'm an associate principal at Arup. I've been a facade engineer for over 2 decades now, and I started my career working on airports, and I now find myself continuing to work on airports, and in one instance, it's actually the same airport. So hence the reason for this panel. This was one of the first projects I ever worked on as a structural engineer. This is the Ben Gurion Airport in Israel, and those are my mushroom columns. I don't have a picture of it, but there was a very glassy Dragonair headquarter building at Cheplack that I worked on as a straight facade engineer. And then this is where I find myself working for the last several years, which is actually one of the projects I worked on as a structural engineer in the design of the lateral system when I was starting out at Arup, which is JFK Terminal 4. And now we've been working on several projects at the same Terminal 4 building, both for Delta as a private owner-operator client, but also for the IAT who operate that terminal building as well, and doing several additions and renovations of the existing. So that's you.
Next. All right, so is my mic working? Hopefully. Nico Dando with Grimshaw Architects. I've been a principal with the practice for 20 years. I started off working with Tali on the Fulton Center many years ago, and have continued to work in the transportation sector, and most recently completed Newark Terminal A, which I worked on from about 2017 till the beginning of last year. And we'll be speaking a little bit more about that project to address some of the architectural aspects associated with those facades. I don't know if you need this, but
I don't know either. Hi, Josh. Voice. Wow, that's loud.
I work with Joseph Gardner, and I've been working in the industry for 17 years with Gardner, mainly in project management, and also now running the U.S. operations. I was involved in the LaGuardia Airport from the sort of the ending of the project. Thank you. And we had various scopes, as you can see on the screens. We started the project in 2016 and ultimately finished it in 2022. So that's my experience there.
Those are also from LaGuardia.
Several nice pictures from LaGuardia, yeah. Okay.
Other introductions for...
All right. Hi. All right. I'll see if I can find mine. It looks like we're out of order, so sorry.
Gotta go back. Gotta go back.
Oh, I'm going backwards. Okay. I don't know how to do this. I'm Sarah Palmer. Sorry. I work for Delta Airlines, so any of your answers to the original question are not incorrect, because I'm supposed to like all of the places that Delta has our hubs. But currently working at JFK. I did have a piece in LaGuardia as well, so if the pictures work, we can flash those on. But Tully worked with me at JFK, and so did Suzanne, or is still working with me at JFK. And my history is I used to work for Skanska, which is a construction management company, for about 10 years. Then I worked for another small GC for a little while, and I've been with Delta for about 5 years now.
Hi, Suzanne Castellano. I'm with Turner Construction, 26 years. I've spent the last 3 years out at JFK. Working with both Tally and Sarah. We had a multi-phase and multi-area project. So we've done curtain wall over at Concourse A, some expansion at Concourse B. And we built some new buildings with curtain wall over at the head house. And our latest one that just opened this summer, Delta Premium Lounge. Aviation in general is a different construction area than a lot of projects. So there's a lot of different rules that govern it, and we're going to talk about that in a little bit.
Yeah, so the panel is meant to give us a complete circle of all of the people involved with the design and the construction, particularly for aviation projects. So we've got an architect, facade engineer, facade contractor, main contractor, and an owner-operator client as well to give us the holistic picture. So somehow I'm not able to sync the slides with the screen, so I'm sorry for that. Okay. But we were going to start with Sarah just to talk a little bit about your experience as an owner-operator. What are some of the goals that you have for facades when you're looking to upgrade a facility and make it state-of-the-art?
Yeah, so I think between JFK and LaGuardia, we had a lot of the same goals, but at LaGuardia, although the terminal was running the whole entire time, it was basically a new build around an existing terminal. And so a lot of what we were able to do was make those big glass walls and make sure that, you know, the vision that we had was really being able to come to life there. At JFK, we had to use an existing building and have a little expansions throughout that existing building. So a lot of what we needed to do, although, our thermal and all of our requirements there were able to be amplified, we still had to have a, final condition that looked a lot like the original condition. And so there's certain things that our customers would like the big glass walls and being able to see out to the airfield. And so when we made the premium lounge, for example, when you look inside there, basically our entire bump out and the entire view that we get to show our customers is just big glass panels. We also wanted to find ways where we didn't need to have the blinds go down where the sun is blazing at us during, the midday. And so all of our glass is, it has interior shades, electrochromatic shading within it, which is really cool. When the customers realized that, they were very excited about it. But then we needed to do things that were also, realistic for the environment that we're in. So the glare on the window is a problem for pilots, obviously. When they're coming in, they don't need to have the sun reflecting off of it and getting into their eyes. So we needed to make sure that we took that into account. Specifically at LaGuardia, we had to make sure that we designed so that any blasts or an explosion or something to that effect wouldn't affect the building. And so I can't tell you where in the building that is, but there were a lot of security requirements around that, and obviously any other threats that we might need to have. And then we care about the environment as well. So we also installed a bunch of bird etching. Specifically at JFK, there's areas where the birds during that glare time would get a little too close to our windows. So we put etching in it, and we don't have that issue anymore. So just a bunch of different nuances that when you're in that wide open airfield space that you need to think about.
Yeah. So why don't you speak a little bit more, Nico? He's got some visual aids. Hopefully we can get to them to talk a bit more about the architectural requirements, particularly about glare and the ability to achieve the allure of airplane travel with transparency and balancing some of the security requirements that we have for that as well.
All right, great. I'm going to stand. It's just a little bit easier to see the slides at the same time. So a lot to cover there, especially in this particular case. Terminal A is quite interesting. I mean, it addresses some of the same things with existing conditions, but in a different way, because it was a new terminal, but it was fitting into the existing, historic complex that was designed in the 60s and 70s, and was actually, which was originally quite a nice site plan for the 3 terminals that were there. And so one of the main things that we were trying to do is actually tap into that legacy of modern architecture while using contemporary systems and conforming to contemporary standards. So you'll see the essential language of the architecture evokes some of that original cast-in-place structure that's still remaining in the other 2 terminals. Of course, those are also intended to go away at some point in the near future with the major new expansion that's planned over the next decade. But that was the basic point. And as with any other airport of this style and type, the security criteria that we've started to allude to really become paramount in the design of the facade, while also addressing the transparency that we're desiring. It's a common use terminal. And so the intent is that all of the check-in and all the other facilities are interchangeable between the different airports. So everything's programmable and can be switched around. And so the transparency becomes even more relevant to the design so that people can orient themselves easily in the wayfinding remains intuitive. So with that, to sort of compound the complexity of the issue, it was a west-facing building with a lot of light coming in at a low level at different times of year. And so the reason you see these large overhangs is not just for the dramatic effect of having large overhangs in an airport type of environment, but it's actually playing a large role in mitigating some of the solar performance and the daylighting conditions within the facade itself. And similarly, on the drop-off canopy is an example where we're also using other types of glazing. In that particular case, it's a monocrystalline laminate PV system that's been placed into the canopy itself. Demonstration technology for the port of what basically trying to show that they were forward thinking in their approach to all of these different systems. I should point out that obviously, as with all of these projects, designing the facades takes a cast of thousands to really put together all the different requirements. So first of all, on the consulting side, shout outs to Heintges. I see one of our collaborators in the audience there, and Atelier 10, as well as STV, who were the record architects working with us on this day-to-day, and on the fabrication side, working with Perma Stelisa and Tudor Perini, Bellwether, BGT, Onyx, who's also here today, and also Gartner in the beginning. And this is actually kind of interesting with respect to the question of how we design for the security criteria, which we can't talk about, but where it becomes, where we can speak about it is in the approach to the integration of the structure of the facade with the glazing system. So originally, when we first designed it, we spoke with Gartner, in the early days about integrating the structure of the facade with the actual glazing system so that they're one integrated system. That ultimately didn't pan out for various procurement reasons. And so we ended up with two separate systems, which is much less efficient, right? So the strongback system that you see supporting the glazing system is much more robust as a consequence of having to design the facade independently of the lateral system that's supporting the facade and keeping it from falling over. A few other key points with this one is that you'll see both in the preceding picture and in this one, we're also using the skylights in conjunction with the glazing system to reinforce the daylighting and improving the overall ambiance of the space. And all of those systems, the facade systems, the skylight systems, had to be performed to a very high acoustic standard, right? So the intent here was to lead people through the space intuitively and ultimately end up with a view out towards the air side. But all of these glazing systems had, by Port Authority standard, had to be set to a very high OITC and STC ratings, as did all of the roofs and all of the other facade systems that we incorporated with all of this, while also, as Tali asked, addressing the daylighting, which was achieved through a series of different measures depending on where we were, what the orientation of the facade was. We basically had facades in every single direction. And so there's a combination of the actual performance of the low-E coatings themselves, the frits, the actual brise-soleil and the shading systems, all achieving the desired daylighting effect in as many different locations within the airport as possible.
Great.
Who's next?
Josh is next, because we were going to talk a little bit about some of the things that you mentioned there. Integrating the facade design with the supporting structure for the facade. This is an ongoing theme for any building that has to resist an extraordinary event. And there's several solutions that can be developed in order to address it. So you want to speak a little bit about that one in particular, and that was at LaGuardia, and any other characteristics that come up and that you remember from the facade design delivery process from the perspective of the specialized contractor.
Yeah, just to build off what you said, Nico, your facade there at Newark is a structurally glazed facade. We took a different route at LaGuardia. We have a cable net facade, a one-way cable net facade, which is, you might know, is cables that are strung from top to bottom with hidden brackets and then tensioned. One of the things that we found in the beginning of the job that was pretty challenging was that that we were involved in the design assist process. They had already released the structural steel on the job, and when we came to them with the loads for the cable facade, the loads for the structural steel couldn't handle the loads. So even being involved that early on in the process, we were still a little bit late to the game, so we had to find an innovative solution to deal with that. So different ways to skin the cat, so to speak, or to stop the blast, so to speak. The cable net facade in this particular area I can't say too much about, but there is a fuse at the top that helps plastically deform to catch the blast and save the people inside. So that's one way we dealt with that. But just to elaborate on these airport projects are they're quick to design, but they're long burns sometimes too. And as you guys are aware, these were done in active airports, right? So we were designing facades that literally had roads running through them at the same time. So we had to get on early to understand, okay, what are the parameters here? Where do we need to stop this facade? How are we going to support it structurally in the meantime? How are we going to make it weather tight for sometimes several years? So this was a 6-year project. We had 11 different phases. At least 3 of those phases were stopped in the middle of the construction and had to be temporarily supported. So the earlier on, the better that we get involved in these jobs. It just makes it easier to understand the intricacies of the project and to make sure that we're, taking into account the design parameters and also, understanding cost and schedule and all of the other intricacies that are involved. So the earlier the better.
Yeah. I'm smiling at Suzanne because this is all sort of her remit as being the general contractor. There's like this dichotomy of needing to work fast and work early, it being fast track, not having enough time, and being on an active site. Can you speak a little bit about some of the experience that you've had dealing with balancing all of those seemingly opposing issues?
Right. Well, we had different constraints in different portions over at JFK. When we had to get Concourse A up and running, we had a limitation in that there was a lease agreement in place that wasn't going to be extended. So we were in a position where we needed to get done by a certain date, and there was no give on that date. Because of how the whole project went down, because it was a project that actually started back in 2019, was going to have a fairly reasonable pre-construction period and then get to have a reasonable construction period. And then all of a sudden, boom, a year later, COVID happens, the job gets put on hold, the focus goes on LaGuardia, and then 13 months later, the call is made, we have to build the project, and the end date doesn't change.
Sorry.
but right, so the constraints for Concourse A were such that like we had to figure out how to take the drawings that we had and get a trade partner on board to make sure that we had everything in place. And then honestly, we bought that wall in November of 2021, and we had wall coming to the job the summer of the following year because we opened in January of 23. So, yes. So it meant, and look, it put us in a bad position with each other because we both wanted a great wall, but we both had different reasons for wanting that wall and different ways of how to get there, because we knew we just had to figure out how to get it fast, and design team obviously wanted to make sure it was done correctly, as did I. But and we had contractors for each phase of the project because of the way the contracts were let. We had to go out and buy it each time. So we had one contractor, they handled all portions of the wall. The wall over at Concourse A was a metal panel system. There was some punched windows. There was exterior wall portions. There was a storefront portion. There was only, I think, a limited portion of the GFRC there, but we bought that all within one contract, and that one person was then responsible to go and find all those other pieces, put the whole thing together. I think on Concourse A and Concourse B, it was rough, but I think they really did a great job of putting that whole thing together, taking responsibility for the whole system, for the integrity of the system, for the weatherproofing of that whole system, even though like they had different contractors from that. And I think that was probably one of the reasons why, even though it felt painful at the time, it really was a very successful wall. Some of the other constraints when you're dealing with aviation, though, also is you have to worry about like the size of your crane, because of the FAA rules. And so when we're worrying about the size of a crane, then maybe the way we're going to erect the panels is going to have to be different than what we all thought. And until we had like the approved piece of paper from the FAA telling us what the height of the crane could be, when we got through the approval process, which takes about 3 months, you don't really know what you're like trying to engineer those panels to make sure. So there was a combination of different systems that we had to use because we were limited by the height of the crane. And the other limitation is like, because for example, like Concourse B, we were just putting on chunks of building onto an existing building. Like A was an extension of the concourse, so it was kind of easy to create the separation between the two. But at B, we were widening the actual existing thing. So we were really kind of always operating within an existing operation. So a lot of the work that we did over at Concourse B was was done at night, and then there was only certain portions of that work that was done to the day. So like that was like an additional coordination piece that kind of happened there that like you don't really understand until you're like in the heat of it. Move over to where we did the Delta Premium Lounge, which is on the back face of the front building, the head house building. So that ended up being another contractor. We did the same thing there. We went with the same approach. We had a little bit longer of a timeline because that was like the last phase of the project. So we did have some time to get into some more of the engineering, to do a little more look into the details and to make sure everything was more coordinated and put together. But it was a more complicated wall. That particular building has an operable skylight, which is kind of in my existence, but it works.
I missed that.
I said it was a bane of my existence, but it works. Two, it's weather tight, but it had like a long lead time. There's only certain people that do that, and like working within the constraints of their own design with the constraints of the design of the building, like took many months. And because that portion of the building was just so close to the actual tower within the airport itself, that provided further intricacies as far as constructing, because if it's drizzling out, I'm still installing wall. If it's drizzling out and I'm next to the tower, I'm shut down for the day. And like, that's not something that that's not something I can predict, and it's not something that like you could explain to someone, because it's the call of the tower that tells you if you can work that day or not. So like those kind of things, that they're just very specific to aviation and very different from when you're, in the city building against buildings, or like every job has different constraints, but I did feel like the aviation ones were a little extra special.
Yeah, so limitations on where you can go, when you can go, what you can go out with,
right?
How you can then install, what system is then appropriate.
Who
did you
can
find any of
install?
that? Yeah, did you find any of that at LaGuardia?
Security was a nightmare. Logistics, very difficult. When can you go where? When can you get this delivery where? And, how to navigate that active airport. Under construction, we had when we were building the pedestrian bridge B, we had constraints on when we could work due to the last flight coming in. Mm-hmm. So sometimes, the flight would come in at, midnight, and sometimes it would come in at 4 a.m. because it had all these delays up until that point. So very difficult to quantify how long you can work, and how many working hours you're going to get, the production, that sort of thing. It's all variable, very much so.
Forgot about that.
And there's also no direct way if you go back to, I don't know if you have it.
I'll try.
If you go back to the last one, when you look at JFK in general, there's no direct gate that you can get into to get to Terminal 4. You kind of have to go a roundabout way to do it. Mm-hmm. So if they have to, for a wide load, shut down a runway or something, you're not just affecting Delta's terminal, even though it's not just Delta's terminal, but Delta and Terminal 4, but you're affecting all of the other terminals around as well. So it was fun, for sure.
Yeah, from a design standpoint, the other thing about working on an existing building versus a new building is the interfaces and the matching. So you have a little bit of a design straitjacket on, if you will, because you're trying to match to the existing. And you might have a technical straitjacket as well, because the existing building, for example, the south wall of this Terminal 4, has been there for 25 years, and it's not, it's an existing building that's seen a few things. So we're trying to build a new thing onto it that's fully functional and operational and watertight, airtight, and work out all the interfaces with it. And yet you're doing a air infiltration test against something that's super leaky, right? So there's a lot of interesting detailing that needs to happen between the new and the old.
But even new to new, one of the things that we spent a considerable amount of time on was making sure that all the glass looked the same, even though it was all being sourced from different locations. So between, the large scale curtain walls, the smaller ones, the storefront, the doors, the side lights, the glazing for the canopy, those were all coming from different locations, different fabricators, different processes. But at the end of the day, that glass all had to have the same tonality, the same color, the same overall appearance. So it took a lot of testing, a lot of visual mock-ups, a lot of checking of samples to get all of those things to match. All of, happening in parallel, again, with all of those complicated, phasing and timing situations. So it did really rely on working very, very closely with the fabrication team. So it was design build, obviously. But we were there with, for example, the Perma-Stelisa team from day one. We were effectively evolving the facade design while they were already starting to do the shop drawings, right? And just kind of working back and forth together to get it delivered when it needed to be.
Yeah, the other thing I was going to mention from what you were speaking about was the acoustics. Because we were matching an existing building, we didn't have an opportunity we didn't really need to improve upon the acoustics over the existing building. So it'd be interesting to hear a bit more about what you were designing to specifically for the new build.
Yeah, I mean, it was much more rigorous standards, both for the STC and the OITC. They basically, and that was both an external standard as well as an internal standard. So no noise could sort of migrate from back of house areas into hold rooms and public areas. And within the hold rooms and all of the concourses, effectively, there had to be minimal distortion to any of the acoustics or the PA systems coming from the airplane noise. And the biggest challenge there was less the facades than the roof construction, because the tendency, obviously, in those kind of like one-story, effectively kind of environments, is to have a fairly lightweight roof construction. But that's actually where a lot of the sound comes through. So all of that roof basically had to be reinforced with additional layers to address the acoustic criteria.
So are you having any feedback, Sarah, on the new lounge space that has the operable roof about sound?
No complaints about the sound. They're really loving the space. So everybody fly Delta One, go in the lounge. No, but no complaints about sound from it at all. It's being very, very well received. So.
And do you want to speak a little bit about how much of a design role your team had in directing the architects to deliver something that would work for you and your customers?
Sure. So, I mean, our model was, I think, interesting from an owner standpoint. Basically, what Delta did was I work for corporate real estate, and we directly are talking to the construction management team and the designers. Everybody works for us. We also hire all of the contractors directly, and so and the special inspectors and everyone else basically that's on the project. They all work directly for us. We hold the contracts, and so. In regards to, the design elements, we are directly there 100% of the time, breathing down everybody's necks, making sure, the decisions that are made are not for necessarily, the better of a budget or a schedule or whatever. It is all directly related to the better of the program. I'm sure some would probably argue that that's not the best way to do it, but for us, it gives us a lot of control and so we can get the product that we want at the end of the day. So.
And I know Delta's built some new spaces, not just in New York at LaGuardia and JFK, but also in LA and Atlanta recently and somewhere else in the Midwest that I can't recall. Do you have any insight that you can share with the variations between the different projects?
We use a lot of the same designers and some of the same contractors. Obviously, per region, things change, but not necessarily mandated to use, obviously, Arup or Gensler or any of the designers that we used on our program, but the continuity helps, right? Because if you want something to look and feel the same and you use some of the same parties, it's nice to have kind of that broader reach. Not mandated, of course, but it's been influential. But we have terminals that we're working in all around the United States and around the world, so it definitely differs depending on where we go.
Yeah, there are some similarities a little bit, I think, with the electrochromic glass, which is one solution towards addressing glare. You spoke a little bit about some of the other ones at Newark.
There was mostly Frit and other, just sort of conventional static measures for reducing the glare, but certainly there was daylight analysis done on all of the spaces, right? So full modeling of all the different conditions within the building to make sure that we could actually address that, because so that all of the wayfinding signage was legible from the inside, and then we're also not conflicting with retail signage and all of those great things. So, when you're trying to achieve a high level of transparency and have those great views in and out of the terminal, that's wonderful, but it creates some serious challenges from a glare perspective, and so that did need to be addressed. There was only one instance where we had to rely on supplemental shading on the inside, just because it was, such a, it was basically the low angles of the sun were almost impossible to address any other way. Mm-hmm. Yeah, but.
And at LaGuardia, Josh, what was the treatment for the glass for the cable net wall that you showed us?
Just add coatings,
Just low-E.
Yeah, just low-E coatings. Yep.
Yeah.
So we've got 40 seconds left.
Anybody have any questions?
I would love to open it up to any questions from the audience, if anyone has a question.
Otherwise, I'll just say a couple more things about phasing, because why not? I mean, the phasing stories are really funny, right? I mean, in our case, for example, the phasing of when we had to open gates was the exact opposite of when the parts of the site were released. So they went in opposite directions.
There you go.
We had that, and then the entire airside plan changed when we'd already started releasing the steel mill order. Right, and basically the operator came in and wanted to change the mix of the gates and the plane styles. So these are the things you're dealing with while you're trying to finalize design, that the actual layout and the whole basic organization of the airport is still in flux as both the operators and the Port Authority in this case are figuring out the basic parameters of how the place is supposed to work.
Yeah, I think that's interesting because a lot of, before I started working for Delta, I didn't really understand how it all worked.
Yeah.
And the way that, airlines buy into how they can fly is that they buy into these airtime slots, basically, where they can take off and when they can land. And if you don't fly those slots, you leave those slots. So people, other airlines can then buy them if you're not using them. They go back up for bid, basically. And so it's really important to keep those slots and not mess up those slots because of a construction timeline.
Yeah.
One thing at LaGuardia that we ran into, you mentioned COVID earlier. So the reason why Delta was able to accelerate the construction and get it done before some of the other operators that are now, and terminals that are now doing their work, is because we took advantage of the slots. And so during COVID, the FAA dropped some of their mandates of how many slots we needed to actually fill. So Delta, rather than stopping and not doing anything during COVID, decided we're going to jump right in and take advantage of that. And we poured our money and our time and our efforts into taking advantage of not having to fly the slots. So then rather than having, let's say, 38 gates total that we have to fly at LaGuardia, we were able to fly 20 gates total. And at 8 flights, 8 takeoff and landings a day, that is a lot of time that you can close down gates and be able to expedite work. So that's a good point, because you never get that opportunity. So.
Mm-hmm.
Yeah, I was going to say one last thing just about the fallout from COVID. I don't know if you guys want to speak to this at all, but we found that lots of substitutions and there were procurement issues that needed to be had with materials because of the supply chain. Which greatly affected everything, right? Everything. From the contractor side on what they could get, to the design team on how it's performing, to the final installed product, and then coordinating it all from the main contractor side.
I mean, sometimes material suppliers flipped in the middle of a submittal review process. We would have one approved and be like, nope, can't get that anymore. Let's try something else. Right? And then you go through it all again.
All right.
Thank you so much. I think we,
Thank you so much, panelists.
Thank you.
That was a really great discussion.
All right. Good afternoon, everyone. My name is Kasia Burzyńska. I'm a building envelope consultant at Walker Consultants, and today I'll be the session chair. We started a little earlier, so I will save the early birds hearing my introduction twice, and we'll cut straight to the chase. Our first presentation today will explore the blending between couture and building envelope design, and highlighting innovations in ultra-high performance concrete. a statement of exploration of these dynamics of opposing forces, such as the fabric versus the perceived solidity and permanence of building facades. So to kick off our session today, please welcome Jordan Rogov, partner and co-founder at DXA Studio, and Tigrin Kostanyan, intermediate architect, also at DXA Studio. Welcome.
First, want to thank Zak World of Façades for inviting us today. It's a pleasure to be able to share a passion project of ours. When we go home and talk to our families about these sort of things, their eyes kind of glaze over. So it's nice to, talk to people that are similarly enthused. I'm Jordan from DXA Studio, and I've got my colleague Tigrin here. We're going to take you through a project of ours that, again, was a real passion project for us. It's located in a landmarks district in New York City, and so many of you are familiar with landmark projects. A lot of people look at that as a really burdensome process, it's a lengthy process, sometimes more expensive than building in a non-landmark district. However, for our studio, that's really a research-based and analytical studio, we saw this project as a real opportunity. And it kind of matches our skill set, and we had a lot of fun with it. And like any project from the beginning, there are lots of unexpected twists and turns, and this project in particular is really exciting. So we thought for today that we could walk you through the really unique design process for this project and how it manifested itself in the built environment. So starting with the Ladies Mile Historic District, our site is 10 West 17th Street. It's 17th Street between 5th and 6th Avenues. So the Ladies Mile District really came into being in the mid-1800s, and its kind of golden era was the 1870s, 1880s to the early 1900s. And what made this place so special, so unique, is that it was kind of the center of the first the birth of ready-to-wear clothing. Prior to the inception of Ladies Mile, people would go to tailors, look through a catalog, pick a style they like, and the tailor would custom make that clothing for them. So this made fashion kind of unaffordable, unachievable for a large bit of the population. So that changed dramatically over the course of the development of the Ladies Mile. What we had on the Ladies Mile were these commercial palaces located along 5th and 6th Avenues that were the first department stores in the United States, Lord & Taylor among them. The mid-block buildings that you see are known as store and loft buildings. They were manufacturing buildings. And at the peak of this era, some 75,000 tailors and clothing makers were located in those buildings. So our site exists as kind of one of those store and loft parcels with the same kind of massing and zoning requirements. So here's for those familiar with applying for landmarks and the appropriateness argument that you need to prove in order to get approval. You are familiar with these landmarks maps. So our site is kind of the southern edge of the Ladies Mile Historic District. Previously on the site was a three-story, what's known as a no-style building. So permission was given to tear that building down. And prior to our involvement, another architecture team got an approval in 2016 for a building on that site. Over the course of us getting involved in this project, we presented a number of projects at LPC, and the commissioners actually issued kind of a clarion call and said, we're tired of seeing buildings in the Ladies Mile that are hiding in plain sight, meaning they were looking for something more ambitious, something exciting, and something that could match the ingenuity and the rich history of the district. So we got really excited about that and wanted to create something that reflected that ingenuity, that kind of pushed the envelope, so to speak, and celebrated this incredible history of place. So our approach to design is not really a regurgitation of previous historic styles. We try to kind of get to the nuts and bolts of what the compositional elements of the building. So understanding bay structure, rhythms, composition, building datums, proportions, those sorts of things, so that we can create a framework for applying a much more contemporary design, including kind of more innovative materials and construction methods. So to give you just a really quick window into what a big deal this part of the city was, this is, I think, in the 1900s, this photo. This is along 6th Avenue when the first version of the 6th Avenue subway was an elevated train built almost exclusively to shuttle the thousands of people that flooded this district to go to department stores. And once again, this is the first time a large portion of the population was able to afford fashion, was able to afford clothing. They might have been limited to 1 or 2 outfits, but now the price came down dramatically with this kind of innovation and mass production. So this district really thrived for an extended period. This slide is to give you a sense of just the kind of initial fashion that was being produced in the Ladies' Mile. And this is kind of a continuation of the Victorian and Edwardian era. So any of you that watch Downton Abbey and see the kind of ridiculous outfits that everyone had to wear, can identify with this. The first few issues of Vogue really focused on a lot of the styles that were available in the Ladies' Mile district. In fact, they're all filled with advertisements for a number of the clothing manufacturers and department stores. Along the bottom row here, you see images of the various times of the day for these outfits. So really, life was kind of a series of scenes, and you needed to dress to impress in each one of those moments. The wealthier you were, the more outfits that you were able to amass and change over the course of a day. One thing you'll notice right away is all these outfits really kind of disfigure the human form, or exaggerate it to almost what looks to us now as like a ridiculous extent, but this was of the era. Also, the outfits in a way were designed to try to make people look older and more dignified. So that's when the Ladies' Mile started, but there was a reform movement that started in England and Ireland, known as the aesthetic movement. And really the face of that movement was Oscar Wilde in the upper right-hand corner. He wrote a treatise on fashion that was published in 1885 called the Philosophy of Dress. And then he came to New York City the following year and famously said at customs when he was coming to New York, when asked if he had anything to declare, he said, "Only my own genius." So he came and kind of dazzled the people at that lecture, and word got out. It was published in the New York newspapers. And his approach was really to rethink the way fashion happens, that it shouldn't be about status, the status game of all of these outfits. They shouldn't be these large bustles and corsets and all of these uncomfortable things, that it's the human form we should celebrate. And actually encouraged us to kind of rewind back to the era of Greek and Egyptian outfits that accentuated the human form and were very simple in nature. But most importantly was an expression of youth and vitality. The turn that we weren't expecting in all of this research was that the silent partner to the reform in the fashion world was the reform in architecture, really kind of led by Adolf Loos. The rethinking of ornament and tradition and all of the articulation and framework that architecture and design was being done in. He challenged that and actually said to be a healthy society in advance, we need to dispense with this adherence to ornament. So other kind of fathers of modernism followed suit, and actually all of them had some sort of sartorial connection, including Mies van der Rohe, Frank Lloyd Wright, Corbusier. And so understanding that relationship really intrigued us because it's not something that's written widely about. So as we started to think about how do you marry these worlds of fashion and this incredible history with the world of architecture, we looked at some exemplary projects, including Christo and Jean-Claude's wrapping of buildings. And what we really loved in their approach was to kind of take away that ornament and just simply express the form of the buildings underneath them. And obviously through sculpture and stone, like trying to convey the idea of materiality and fabric. And so getting to the design, before we run out of time, we looked at the skin of the building, the envelope of the building as almost a cloak or a fabric. And we were able to express these kind of historical cues of proportion, composition, datums through that fabric and actually peel the layers away down at the bottom of the building and express that kind of classic tripartite arrangement that you have in the district with a metal base, because it was cast iron was actually applied on many of the storefronts in those late 1800s. And then at the top of the building, tried to synthesize a few considerations. One, that we're this transitional point from the commercial palace buildings on the avenues down to the kind of smaller store and loft buildings where the manufacturing took place, but then make that move an exuberant one that kind of conveys an action of draping to again reflect the idea of materiality in a cloak for the building. So just to go through quickly, zooming back from the building, you can see, while not explicitly stated, there is a relationship and kind of observation and reinforcement of the datums and organizational principles between the buildings in the district and in our building. So here's just kind of a palette of materials that are selected. Like all the buildings in the Ladies Mile, we went to a simpler secondary material on the lot line and rear walls, which is masonry, but it's sympathetic to the ultra high performance concrete. And then finally, the process was extremely iterative. We did hundreds and hundreds of models to try to get the right balance of opaque and transparent and have enough kind of meat on the bones to be able to express the fabric. And so to get into that process, I'm going to turn it over to Tigran.
Thank you very much, Jordan. Hello. Good afternoon. It's an honor and pleasure being here today, presenting our work. I would like to thank Jordan Rogo of the XA Studio for nurturing an environment where design exploration can thrive, and projects like 10 West 17 can be done. The idea of using the Ladies Mile garment history as a driving force for the project was a concept that we landed very early in the design process. On this slide, you can see our earliest materialization of this idea. Big challenge was, going forward, finding an effective way to model this. We started a set of experiments with different software. Our starting point was Grasshopper with Kangaroo physics simulation. That didn't go anywhere. Marvelous Designer. My colleague was convinced that I'm making up names, and IT thought it's a virus. But it's a really robust software, specifically designed for garment design and garment simulation. Unfortunately, not really great for architecture. Around the same time, Blender released Cloth Brush or Clothing Brush tool for their sculpting workflow. Thought this is a great solution for what we're doing. It wasn't. At the end, we ended up using a very simple setup. We finally landed on using Blender with a simple smoothing modifier stack, some creases, and small commands and scripts that could randomize the vertices on the one axis only. This workflow automated some part of our modeling, allowing us to have a lot more iterations than we would have if we had to sculpt manually everything. With the right modeling technique figured out, we started the iteration process. Over a few weeks, we produced hundreds of permutations, some fully rendered, some combination of rendering and sketching, some painted over with Procreate. None of those are AI generated. We actually went through the process of rendering and trying every idea and every way that we could express the fabric over time. maybe with the exception that Virgin Mary, we didn't make that one. As you've already seen through Jordan's presentation, this is where we landed. But there are a few challenges. When we started pricing the project, we realized that the very idea of the design of this flow of fabric necessitates custom molds for every panel. When we priced it, we were at 211 molds, which was really not feasible. So we hopped on a train, we flew to Canada to our fabrication partner, Spring Valley in Canada, had a brainstorming session for a few hours, and we landed on a solution. One part of the solution was to use mold dams. By using a single mold to cast different length panels, we're able to reduce the panel size significantly. So back to New York City, we remodel, we recalculate our molds, and we're at 90, which seems still unreasonable. But while we're flying back, our partner in Canada figured out a way how to cast the molds a lot more efficiently than typical cast concrete molds and fabrication would be done. They chose to cast directly into CEC carve form, foregoing the casting of expensive rubber. This way, 90 molds were actually affordable, and since the molds were made out of foam, they couldn't withstand many continuous reuses, and many molds with small amount of use were acceptable. So, back to figuring the rest of assembly, some of the unique details. Parapet here in particular was very challenging because we have a very large swoop going on that reaches 10 feet tall in some areas, and some details showing some unique conditions that are enabled by utilizing UHPC panel. There's curved glass guardrail that is on the upper floor, and we're able to attach it directly into UHPC panel by using casting place threaded inserts into the panel bolted directly into glass, simplifying the design, creating a very elegant system, also simplifying the construction. And I'll leave you with a photo of my desk with the facade sample permanently parked on it, and pass the stage back to Jordan, who will talk about DXA's history with the experimental facades. This was a very quick overview, so if any of you have any questions or comments about the facade fabrication or modeling, please reach. Thank you very much. Jordan?
All right. So this project is slated to start construction imminently, and we're really excited to see that go up. Other projects that have been completed, just very briefly, we have a project called the Maverick on 28th Street. It's only a few blocks from here. And for anyone going to Open House New York this weekend, this is one of several projects that we'll be giving tours of. This project was done during the pandemic, and to shrink the timeline for installation, we developed a system of mega panels that already had all of the waterproofing and fenestration installed. We similarly made those up in Canada, brought them down. It was a lot of fun seeing trucks with parts of our buildings driving around the city for that period during the pandemic. And we were able to, shave 2 months off the project. So very simple principle, just a precast mega panel. And the site was is located directly across from FIT, which are some low-lying buildings. So we have in perpetuity a tremendous amount of exposure to the sun, and so we did a very geometrical facade that changes over the course of the day with the movement of the sun. Going down to the Tribeca district, another landmark project we did was a bronze clad rain screen passive building. This building's under construction and will be completed in February. Our take on the cast iron kind of interpretation was to do automated milled, very thin, very precise bronze paneling, which really concealed a lot of the inner workings of the passive technologies used to get that designation. And we used the vector line work for the milling drawings actually as the ornament. So the way that they're created, it actually captures the development and manufacture in lieu of ornamentation. And then finally, a project that we did that hasn't started construction yet, but we hope to soon, is Willem de Kooning's old studio. And actually, the entire building was populated with abstract expressionist artists and was kind of the hub of the ABEX movement. So in addition to restoring the building down below, we did a design for a vertical enlargement and then a high-rise adjacent to that, like I said, we hope will be built soon. The idea was to, like the relationship between architecture and fashion, this is the relationship between architecture and visual art, and painting in particular, and trying to capture the dynamic qualities that the abstract expressionists kind of brought to the fore during their period in New York City. And I think that's it. So thank you very much. Thank you.
Thank you very much, Jordan and Tigrin. We will now continue the discussion following the route of quality assurance, quality control, again, strong collaboration, problem solving. Our next speaker will share strategies for navigating challenges in the QA/QC process. So please join me in welcoming Bersu Seren, Assistant Project Manager at Vishaan Façades. Thank you.
Good afternoon, everyone. I'm Bersu Seren, a mechanical engineer and assistant project manager at Vishaan Façades. Today, I'll be discussing quality control and assurance in the field installation of building envelope systems. Facades not only define the appearance of a building, also plays a critical role protecting it from environmental elements, including wind, rain, and temperature differences. Ensuring proper quality and control in every phase of facade installation is essential for durability and safety. That's the reason why we would like to discuss this topic today at Zak Facade, New York. We are the only company that stands out by offering unique on-site QA/QC inspections in the New York market. What makes us truly exceptional is that our innovative approach, providing real-time inspections through professional team of 15 experts at our New York City office. This team, including our technical director, our project managers, our quality control engineers, work hard to deliver exceptional quality on every project. In today's presentation, I'll be covering the significance of quality control in field installation, essential components of an effective quality control procedures for facade installation, strategies for addressing challenges, and ensuring smooth integration with industry standards. At Vishaan Façades, we focus on delivering high-quality aluminum solutions for various architectural needs, including windows, doors and storefronts, louvers, and railing systems. With more than 20 years of our experience, we ensure the best service to price ratio. This is an image of our manufacturing plant in Istanbul. I would like to show our extensive product range at Vishaan Façades, including window and door systems, louver systems, storefronts, and railing systems. These products are designed to meet highest standards, providing ALMA and FRC MCA tests, durability, and safety. I'll be explaining 3 important components that define the significance of quality control in facade installation. Following market standards, ALMA guidelines are essential to maintain facade's performance. Our strong commitment to quality control builds long-term client relationship and maintains our position in a highly competitive market. Applying consistent quality control procedures at each phase of installation of each project contributes to our success. As you can see, at Vishaan Façades, we follow international standards for quality, safety, and environmental responsibility in our facade installations. By having those international standards shows that we follow market standards to meet industry standards. In addition to international standards we follow at our manufacturing facility, we also apply 3 procedures in the field. These procedures are divided into 3 steps: pre-installation procedures, field installation control, and post-installation procedures. Before we start any installation, we ensure that the site is ready by checking rough openings and the condition of waterproofing materials. This step prevents issues that could affect the facade performance later. During installation, we follow AMA 100.07 standards, which includes procedures for windows and curtain walls. This standard covers proper joints and anchors between building envelope and fenestration products. After installation is completed, we conduct AMA 5012 field tests to ensure that the facade is functioning as expected under environmental stresses. I'll be introducing the AMA standards during and after the installation of facade envelope systems. AMA 2410 provides guidelines for installing windows in concrete, focusing on flashing and sealing to prevent water intake. Also, AMA 503 procedures for the field testing curtain walls to meet water penetration requirements. During installation, our quality control engineer followed the Vishaan's guidelines and market standards to inspect installation of unitized curtain walls, punch windows, and railings. Our engineer have authority to pause the installation if necessary. Here is the example of performing spot checks in the field. This image highlights an incorrect installation of the coping material according to the manufacturing detail. After this issue was found, immediately this issue was resolved. During installation, documentation is an essential part of our quality control procedures. We maintain field site installation control log, and this log records all project-specific details and inspections. This is an example of log from one of our projects, show that the panel on the south and north elevations have been installed, and this log has been shared with all stakeholders. As we proceed, after the installation is completed, floor by floor, Vishaan QA/QC engineer performs a final inspection, and the QA/QC engineer is supposed to fill out this Vishaan sign-off form. After the installer and our quality control engineer approve the work, sign-off process is completed. Of course, at Vishaan Façades, we believe that quality begins long before the material arrives on site. Our packaging and shipping process ensures that each material is properly labeled with the Vishaan manufacturer QA/QC label. This label confirms that the material has been inspected and ready for installation. Proper labeling also ensures that the material follows the correct installation sequence, preventing delays and confusion on the job site. I would like to show our non-conforming report. This report is used to identify any issues when material failed to meet required details. If any material is found to have any inaccurate dimensions that could cause delays on the field, Vishaan QA/QC engineer fills out this NCR form. And this NCR form shared with the Vishaan manufacturing plant. And this form solves the problem by communicating with departments to prevent future issues. As I bring this presentation to a close, quality control in facade system is a multi-step process that starts long before installation and continues until the final sign-off. At Vishaan Facade, we take pride in our approach, which maintains the reliability and durability of every facade system we install. It's been a pleasure to sharing this presentation with you. I would love to have you at our booth to take any questions.
Thank you very much, Bersu. We know as professionals that effective QA/QC processes are so essential, especially now that the industry is so strongly focused on sustainable solutions and materials. So QA/QC is really paramount to ensure proper installation that can also maximize the environmental benefits. And especially as we see new emerging materials that are aiming to reduce carbon footprint. The next presentation will discuss the world's first low carbon glass and its role in advancing sustainability and achieving carbon neutrality. So please join me in welcoming Hisham Mujib, International Specifications Manager at Saint-Gobain. Thank you.
Good afternoon, everyone. Let me start off by thanking Ahmed and his wonderful team for bringing the best and the brightest minds of New York City's facade experts to discuss the most pressing topics of today, embodied carbon. Well, it is no secret that buildings contribute about 40% of global greenhouse gas emissions. Now, we, as a part of the construction industry, have taken a lot of effort to reduce the operational carbon through legislation like energy codes or local law 97 or with green rating systems. And now estimates show that by 2050, the ratio of embodied carbon to operational carbon will be 1:1. That means it's high time we start focusing on embodied carbon of our buildings. And in order to reduce the embodied carbon of our buildings, we need to use products with low global warming potential. Now, the only body in the USA which incentivizes contractors to use low embodied carbon glass is GSA. Is there anybody from GSA here representing GSA? General Service Administration? Now, well, credit where credit is due. They have at least set a framework on which we can build on. So GSA has divided glass manufacturing companies into 3 different categories. And the most stringent limit that they have set for the top 20% limit is that the glass manufacturer can emit 1,331 kilograms of CO2 equivalent for every metric ton of glass that they produce. This raises the question, where does Saint-Gobain stand compared to these numbers? And the answer to that question will be revealed at the end of this presentation. So, since I've raised some curiosity now, let me start with the introductions. I'm Hisham Mujib. I recently became the head of Sales USA. I've been in the construction industry for about 17 years, and I've been with the glass industry for about 10 years now. I have 2 colleagues joining me today. Victor Badiano, who's the business manager North America. And then I have Anup Srikumar, who's the International Specifications Manager supporting me in this region. We represent Saint-Gobain, which started 350 years ago by King Louis XIV. The first project that we ever did was the Hall of Mirrors in the Palace of Versailles, so we have a pretty strong legacy to fall back on. We've come a long way in this 350 years. We are one of the leaders in building material manufacturing. We produce roofing, false ceilings, you name it, anything We even produce performance plastics that have reached Mars. We are present all over the world. We have about 160,000 employees. And one of the most important factors is that we are very, very committed to achieving carbon neutrality by 2050. And we are not trying to do this by offsets, by just planting trees. We are taking significant steps in our manufacturing facilities to become carbon neutral. In fact, we have signed a lot of PPAs, and I think this year we'll have the first zero carbon gypsum manufacturing facility in the United States. Right. One thing that unites all our product lines is our purpose, which is making the world a better home. And because I represent Saint-Gobain Glass, is a short video about glass, Saint-Gobain Glass.
Build. Build to make dreams come true. Build to provide shelter, to protect the ones you love. Transforming materials, shaping them, giving them form. Build. Build with care. Build for the long term. Build for change. For over 3 centuries, Saint-Gobain Glass has been bringing extraordinary dreams to life, constantly innovating to offer the products you deserve for your project. Now present all around the world with 13 manufacturing sites and a strong international collaboration. Wherever you are, our experts work with you to facilitate the shift towards sustainable construction with glass solutions that deliver sustainability and performance. A solar and heat control range allowing the perfect combination of temperature and daylight. The world's first low-carbon glass with a verified environmental product declaration. A temporary surface protection on to-be-tempered coatings that eases its processing and increases productivity, reducing the environmental impact. A full range of exclusive solutions to meet the growing demand for bird-friendly glass and glazing. Saint-Gobain Glass supports you and your customers all throughout the project, even from the start when it's just a drawing. Our digital solutions help you find the right product and bring your dreams closer to reality. Dream, transform, impact. Saint-Gobain Glass cares about building better for people and the planet.
All right. Welcome back from that short commercial break. Before we started producing low embodied carbon glass, we wanted to first understand the contribution of glass to the embodied carbon of the building. And for that, we partnered with Arup, a leading facade consultant, to do a study of embodied carbon on 16 different buildings with different facade typologies. This report is free to download. Now, as you can see here, we considered different types of facade with different window-to-wall ratios, with different glass build-ups, TGUs, DGUs, with aluminum systems, steel systems, and timber systems. And this is the material breakdown results of the embodied carbon. Now, I'll give you a minute to absorb this. On the x-axis, you have the wall types. On the y-axis, you have the embodied carbon. As you can see, the first bunch of wall types is aluminum unitized curtain wall systems. And about 80% of the embodied carbon is coming from 2 materials. One is by glass, which is indicated by red color. And the second one is aluminum, which is indicated by purple color. And you can probably notice that the wall type 11 and 10 are having much more embodied carbon than the rest. That is because these are double skin cavities, double skin facades with air cavities. So the bottom line is glass can contribute anywhere between 24 to 60% of the embodied carbon of the facade. And that relates to glass contributing anywhere between 4 to 12% of the embodied carbon of the building. Now, hence, we thought that we should have an offer for low carbon glass. Now, how do we reduce the embodied carbon of glass? To understand that, you will have to understand how glass is manufactured. When you hold a piece of glass, it's nothing but sand, silica, right? So we take sand and soda ash and lime, and then we put it into a furnace and heat this combination at 1600 degrees Celsius to melt this. Now, unfortunately, this is a very, very energy-intensive process. I wish I could tell you that this energy is generated through nuclear reactors, but it is not. We do use fossil fuels for this. Now, after that, this molten silica floats on a tin bath and then it's cooled slowly to become glass. So the bottom line is that 2/3 of the carbon emission that takes place during the production of glass happens due to the energy required for combustion. And 1/3 of the carbon emission happens during the manufacturing of glass due to the chemical reactions that takes place in the furnace. Now, in order to reduce the carbon emissions that happens at combustion, we try to electrify the process as much as possible. We have an R&D project that is going on to completely electrify this process as well. But so far, we have not reached there. But in order to reduce the carbon emissions that happen due to the chemical reactions, we must recycle glass, right? So now, when you recycle glass, you don't use sand, but you use broken glass that you collect, and that is called cullet. Every single ton of cullet that we use in our furnaces, we reduce carbon emissions by about 700 kilograms. And we reduce virgin raw materials by 1.2 tons. Now, if the architectural community starts specifying glass with low GWP numbers, the demand for cullet and circularity in the glass industry will increase. So the power is in your hands, actually. There is an element of risk involved in this. When you take external cullet into your furnace, if there are any impurities, they could damage your furnace, they could reduce your yield of production. But we at Saint-Gobain have taken the risk and mastered the art of filtering this cullet. And that is how Orae, the world's first low carbon glass, was born. So to summarize, we use very high recycled content, about 64% of external cullet. We try to electrify the furnace as much as possible. With that, we can reduce the carbon footprint of glass by 42%. By the way, I just missed one point. I think there's a panel that is going to be speaking about what to do with 120 tons of glass when the glass is removed. Well, this could be one solution. There could be others, but yeah, something to think about. So the other thing that you have to note is that we reduce 42% of carbon footprint. At the same time, we maintain the aesthetics, quality, and performance of clear glass. We do not compromise on any of this. So we can produce low embodied carbon glass with the quality that can be coated with double and triple silver low E coated glasses. And now for the big reveal, the slide that we're all waiting for. Where does Saint-Gobain stand compared to the GSA values that have been set? Our clear float glass, just the regular float glass that we produce in Europe, is still much better than the limit set by GSA. And when you see Orae, we are less than half compared to the limit set by GSA. So now the architectural community does not have an excuse to not to specify low embodied carbon glass, right? And this is my last slide with which I just want to make 2 points. Number one is that Orae is not something that is on the design board. We have had many successful runs of low embodied carbon glass production, both in Europe and now we are having that in India as well. We've had many, of course, Europe is generally a step ahead of the United States when it comes to sustainability. So the developers there have reached out to us and they've had asked us to produce glass for them, for their projects, and we have completed projects now in Europe with low embodied carbon glass. And there are companies which share our values, which have signed partnership agreements with us. So these are the stakeholders in the construction industry that have had some agreements with us. I would like to give you examples of two. One is Hydro. They're doing an amazing job with recycled aluminum. So by using recycled aluminum from Hydro and using low embodied carbon glass of Saint-Gobain, you can potentially reduce the embodied carbon of the facade by about 50%. Lendlease is another developer from Australia who has committed to have all their new buildings within a certain limit of embodied carbon for their facades. It's around 700 kilograms for every square meters. So if you think your company shares the values of ours in fighting carbon, so we're more than happy to partner with you as well. And if you still have any more questions on low embodied carbon, we have a booth outside where you can reach out to us. Thank you.
Thank you very much. So it's inspiring to hear about the cutting edge technologies. And let's now zoom in to the small connections, small details, small transitions, which are also vital in achieving carbon neutrality. So to explore how carbon neutral silicone sealants can shape a more sustainable future, we are joined by Skylar Will, Associate Technical Service and Development Scientist at Dow. Welcome.
Good afternoon, everybody. So I just want to first say I think I should be partnering with Saint-Gobain because I'm doing carbon neutral. They're doing carbon neutral. I think that's a good fit. So carbon neutral. I mean, we've been talking about it already, what it means. It's through a transparent process, as I drop this glass. Transparent process of calculating emissions, reducing those emissions, offsetting the residual emissions, the net carbon emissions, until they equal zero. And a sustainable building, by its design, its construction, and its operation must reduce or eliminate those negative effects overall, and may even generate net positive impacts in the climate and the environment, preserving resources, improving the quality of life for the occupants. And then to say a building is sustainable is quite easy, even quite seductive, but what does exactly mean to be a sustainable construction? This is an AIA course. It's going to be a little dry, but I won't try to bore you guys too much. I'll try to get through some of the nitty-gritty here without making you guys fall asleep. You can see from the slide right here, the world's going to need about 45% more energy as the world population grows. So does the energy demand. Every new shirt that's made, every cell phone that's produced, every house that's built results in tangible energy spent. Obtaining more energy means burning more fossil fuels, which means releasing more CO2 and greenhouse gases. And that built environment is what's responsible for about 39% of the global CO2 emissions. 28% you can see right there is from the operational carbon. Those are the emissions needed to heat and cool, power the buildings, and 11% is from the actual material and construction of the building. If you need a refresher on those two terms, the embodied carbon encompasses the carbon spent in the manufacturing, transportation of materials, installation of the materials, and even demolition. The operational carbon is what it takes to run that building: heating, cooling, ventilation, maintenance, lighting. And then unlike operational carbon emissions, which can be reduced over time with building energy updates, the use of renewable energy, embodied carbon emissions are locked in place as soon as that building is built. And so it's critical that we get a handle on embodied carbon now if we really hope to achieve zero emissions by 2040. This is where our journey starts. So this is literally Dowsil's production process of silicone and how we kind of get that advantage. We have a significant contribution to silicones that lies in our integrated production process, which includes the local sourcing and processing of raw materials, the quartz, the charcoal, the wood chips there, using renewable, non-fossil fuel energy. And that process is powered by 100% hydroelectric power, which results in our silicone feedstocks with reduced embodied carbon, aiding in achieving those carbon neutralities without needing to be offset. And then offsetting, again, just in case you need a reminder, can be categorized into about two types: the carbon avoidance projects, which reduce carbon emissions through methods like funding renewable energy, carbon removal projects, which directly remove carbon from the atmosphere, such as tree planting, direct air capture technologies. And that distinction between these two is crucial in the decarbonization debate. The other kind of problem is that there's a lack of a global standard for net zero versus carbon neutrality, which adds a lot of ambiguity. And then while carbon neutrality can be achieved through carbon credits, net zero requires eliminating all those feasible emissions, with any residual emissions being offset by carbon removal. So how do we substantiate this claim that I have carbon neutral sealants, right? It's not just us saying it. We don't want to be greenwashing, just be telling you guys this. This is actually how we go about this journey. As a quick aside, there are some legislative proposals that aim to reduce greenwashing by ensuring companies actually do provide accurate information about their environmental impact. This is something that's very important not only to myself, but to Dow as a company. This measurable aid commercial, the buyers, the investors, and just society as a whole in making more sustainable decisions. And hopefully, it's expected to increase consumer confidence in actual green labels and environmental information. Because currently, I haven't ran these numbers in a minute, but I think there's over 200 environmental labels in the EU and more than 450 worldwide. So that's a lot that consumers can see, which ones do they like, believe, etc. And so following the PAS PAS 2060 standard, our life cycle assessments are audited by third parties. The standard established by BSI, British Standard Institute, in 2010, it guides those greenhouse gas emission offsetting and carbon reducing planning. And at the moment, it's the only internationally recognized certification for organizational carbon neutrality. Verified, credible carbon neutrality claims enhance market confidence and trust, while the annual audits ensure continuous progress in reducing and offsetting emissions. Certification systems are very important. They allow for the measurement and comparison of the sustainable performance of the buildings through qualifiable criteria, making it easier to compare buildings certified under the same system. That's a key term there, has to be under the same system. It gets real tricky using different criterias. Those certified sustainable buildings outperform conventional buildings, and certifications also help in ensuring higher quality during design and construction phases while advancing those sustainability agendas. And then LEED, we're in North America, LEED's a big one. These standards reward carbon neutral products with up to 2 more additional LEED points. So it encourages manufacturers to understand and reduce the life cycle impacts of our products through transparency and optimization. And so Dow, we offer carbon neutral services focusing on life cycle assessment LCAs for materials. We adhere to the ISO 14040 and 14044. And these analyses are available for structural glazing, insulated glazing, and weather sealing, weatherproofing projects across the globe. The documentation currently covers many of our high performance silicones. We're adding more of them kind of as needed, or just kind of as we find the time and the resources to do so. And so just if one's not specified right now or under this right now, it doesn't mean it won't ever be. And then these audited LCAs are also used to produce our EPDs, our environmental product declarations, following the PCRs. Although, like I mentioned, a global harmonization issue does exist when comparing EPDs and even when comparing LCAs, just because those PCRs, those product category rules, may not match between them. So even comparing an EPD or an LCA to an LCA can be a little tricky. There's a bit more to it. Oh, there we go. I might just have to use this now. So Dow, I was going to say is introducing, but I think we've already introduced the first ever carbon neutral silicones for facades, offering carbon neutral services for the individual project. It actually covers the 3 applications: structural glazing, IGUs, and weather sealing there. And then with that internationally recognized standard, the PAS 2060 carbon neutrality and its annual audits, proves not only the carbon neutrality, but also underlines the strong commitment that Dow has to continuously reducing carbon emissions. You can request these carbon neutral certificates for your project for many of our products. If you want to know which ones, come find me afterwards. I've got a whole list of them. And these certificates can help contribute to additional green building credits as well. And as silicone sealants so far, it's growing every year, has 50-year-long performance at the moment, which also plays a really big key role in the carbon balance between what has been emitted during the production to the end of service life for the silicones or the building. Here's the quick overview of the process of if you want to go down this service, how it all works. You just engage me, your distributor, somebody who's got a connection at Dow, and we'll start getting you down this path for your project. It is important to note that these carbon neutral silicones not only contribute to a lower carbon footprint of the building through their sourcing and production, as you saw, we're backwards integrated. It's also in the way that they're used in a sustainable design. So when we talk about sustainable design, it's not only using the preferably low embodied carbon materials, it's also important that we enable that material or that resource efficiency. Building more clever by preventing or reducing the material usage first. Which that in turn will lead to a further reduction of the embodied carbon. And so once that's kind of been optimized, the focus should be on ensuring efficient building envelopes, reducing the operational carbon related to the energy use and emissions of the buildings. And this was the substantial part of the footprint that we saw earlier and we'll see a bit more about. With increasing energy efficiency and a switch to renewable energy sources in the longer term, material efficiencies will become much more important. There we go, now it's working. In the next step, we'll look at kind of the systems of choice and how those can further contribute to the energy efficiency of your construction. The one thing I'm not going to talk about and we're not going to touch on is aesthetics. That's a personal choice. So what we want to focus on is the actual facade requirements. The structural requirements, thermal requirements. There's a few more from like acoustic performance and a few other things, for instance. So first, the general contribution of silicone sealants to energy efficient buildings, building envelopes, is that enables the IGUs. The building weatherproofing, air tightness is important to insulation. Air leakages represent up to, or can represent up to a 50% energy loss in buildings. And most construction elements can't be produced to tolerances that actually allow for airtight fits. So you kind of need these silicones or other sealants to fill those gaps to improve that air tightness. Furthermore, sealants enable that durable multi-pane energy saving glazing. I'm sure a lot of you are aware. Those highly insulated double and triple glazed IGU units result in substantial energy savings, and those sealants help ensure that the IGU remains tight and efficient during their entire lifetime under very different thermal or mechanical load conditions. And those glass elements can directly be bonded and sealed to the building envelope, which further helps ensure airtightness of the building. Getting into some more of the nitty-gritty, again, I'm not going to try to bore you with all the math. You can see that if you really want to get into it, by all means, find me after this. But just to give you a broad overview, this preliminary work that we did, this study, indicated that silicones, the structurally glazed silicone facades, could deliver higher thermal efficiency compared to a traditional mechanically fixed facade system. We compared several state-of-the-art commercially available bonded, SSG bonded, and mechanically fixed facade systems, focusing on the thermal performance, structural integrity, raw material usage. And we tried to get a representative system for the APAC, Asia-Pacific area, and North America. These were selected to cover a majority of projects worldwide. So we didn't just cherry pick, we did try to get as broad of an overview as possible. Systems were chosen to offer both the bonded and capped versions with similar dimensions and performance. And then thermal models were performed using the same double IGU center glass value. I think it says it's a 1.1 and a representative warm edge spacer. And then those results was that the benefit of the SSG versus the cap system can vary between about 10 and 25% depending on design. So a significant difference between a structurally glazed and a cap system. And then in this next step, we evaluated how that bonded glazing can help prevent or reduce material resource by comparing a capped and a bonded version of the frames in terms of material use. So the structural adequacy of both systems was first confirmed for stress and deflection requirements following American codes and standards. And then a simple aluminum weight calculation was performed at equal capacity and structural loading. The cap system requires a higher amount of aluminum. I feel like this isn't anything crazy to believe. And that's mainly, the cap system requires more aluminum mainly due to the presence of the cap. And this was quantified to reach up to about 15% for the considered systems. A full comparison of the raw material usage would really need to be looked at with other elements of the system as well to quantify things like the use of EPDM gaskets, for instance, or even the silicone EPDM gaskets, and what's their longevity over the 50-year life of the SSG or the life of the building, when a lot of EPDM gaskets or non-silicone gaskets may only get 16, 17, maybe 20 years before they need to be replaced. So there's definitely more work we can do on really fleshing out more of these savings from a fully SSG unit. A little bit more math, but just the key point here is that industry formulated sealants, about 8 to 12, but we can just call it about 10 kg CO2 equivalent. Depending on the formulation, and that typically varies due to the amount of calcium carbonate that's added to the sealants. So if we take that on to be about an average of 10 kilograms, then we can translate that into a per square meter of facade. And so that's about 20 kgs CO2 equivalent per square meter of facade just in silicones. And so then using a carbon neutral silicone eliminates that completely. And then if we wanted to quantify the difference in aluminum, embodied carbon between using the captured and the glazed facade, you can take that unit, multiply the weight of the aluminum per meter in facade, multiplied by the embodied carbon, and then you can extrapolate to whatever your facade size is, 10 or 20 or 40,000 square meter project, and you can come up with that number. Just as another quick side, Dow specifically, I said it's very important to me. It's very important to the company as well. That is our path to zero there. I can safely say that we are making those strides and are keeping to these targets right now, and I really do believe that we're going to make that by 2050. And so I've a couple more slides here. I think I'm already over time, so I'm going to be quick. This last one I want to touch on very quick. We have the first carbon neutral silicones project in North America, the insulating glass manufacturer with pressed glass and the Cherry Hill glass as the glazer. This used our products 982, 983, and Dowsil 795 for each one of those for the structural glazing, weatherproofing, IGU, and our carbon neutral silicones program certifies silicone products as carbon neutral, which again just contributes to the sustainability goals that we have, that the building has, that the owners have, provides that carbon neutral certificate, adds value to the building owner. And then the opportunities, just to name a few, are any IG or glazer buyers. You can partner with Press Glass or Cherry Hill for those carbon neutral certificates. Specifiers can start specifying carbon neutral silicones with these partners. And then finally, I just want to say thank you. Really appreciate you guys having me up here to talk about this. Any questions, anything, please come find me at the booth.
Thank you, Skylar. And we will need a couple of minutes now to transition into the panel discussion. On the strategies for reskinning facades in New York City and how a recycling of 120 tons of glass could be a cost-neutral process. And I will now hand it over to Christoph Tim, principal at Skidmore, Owings & Merrill, who will moderate the discussion.
So thank you very much for being here and for your interest in this, what I think like really, really important subject of circularity and reusing glass, recycling glass, keeping glass in a circular economy. I wanted to tell you a little bit of a story about the genesis of this panel. It was in 2022. I was sitting on the balcony of my apartment here in the financial district during the pandemic, and I was watching the workers across the street taking out glass, recladding basically this commercial office building, and repositioning it into a residential unit, residential project. And so this was going on weeks after weeks, for months it went on. You can see the worker here kind of like hanging out of the facade here and cutting, I think it's the silicone or the gasket somehow, and then taking out the glass. I was doing a little bit of research because of course it sparked my interest. This is not an SOM project, so this is just a project that I happen to live right next to. And so it sparked my interest. I did some research and got myself onto the site because I wanted to see the progress on site. And so I went on site and toured it. And as I was coming down, I was in the hoist with a bunch of workers who had an A-frame stacked with a lot of glass, and the glass that they had just taken out. And so I was wondering, I was asking him, so what do you do with this glass? And they said, like, goes in the container and just goes to landfill. And I just couldn't believe it, that this is what we're doing with so much glass. It's all like so much the same size. It's all clear, clean. This is monolithic glass, not insulated glass. So it should have been really simple to recycle. But I was told that no, they're not recycling. It's just going into landfill. How disappointing this was. A few months later, I had an SOM project now, and it was a reclad. And what came up was like, okay, we have to take the facade off. And I calculated immediately, it's a big office building. I calculated 120 tons of glass. And I was thinking to myself, I don't want to have the same thing happening on our project that was happening on this project, apparently. And so I started researching a little bit. And so this is fundamentally the genesis of this panel, my interest in the subject. And so with that, I wanted to set the table a little bit. I wanted to introduce my panelist here is Jeremiah Watson. He's the CEO of Infinite Recycled Technology here on the left. Second is Sydney Mainstar. She's the VP of Sustainability and Design Management at the Durst Organization. And third is Dario Barbic, who is a Director of Architectural Sales at Guardian Glass. So now I'm going to take my seat here because we want to make this a discussion here. I want to start with you, Jeremiah. You sent us a nice video about what your company is doing. And so I thought I play this here to the audience, and maybe you can talk about this a little bit.
Well, absolutely. So we came into the glass industry by accident. We had a customer that we were recycling some other material for, and they said, we have all of this waste. And in their case, it was laminate glass that they were producing. And they were landfilling it. And they said, help us figure out a way to get this recycled, the same way you may have seen that building. And so we looked all over the country to find someone to do it, and we found that there was just nobody in that space. So we took 2 years, developed technology and equipment that would cleanly separate the glass from the laminate inner layer, and the business was born. And after that, we began to realize, yes, laminate is a real commonly landfilled product, but so are IG units. And then as we got further into the industry, we realized there's not much recycling happening on the architectural front at all. And so we have just continued to develop technology that will allow us to recycle that type of glass.
But in theory, how long would you have been able to take on glass? How many years is it already?
So we opened our doors in 2020, and that was in Minnesota. We opened a plant in Florida in 2022 and one here in New York in 2023. So we have lots of space to grow the business.
Okay. So what's interesting to me is like understanding of what happens to glass if you put it in the landfill. Maybe you can talk about that.
Yeah, I mean, glass won't break down naturally. Realistically, it won't break down. They estimate it'll be there for 1 million years. We don't know. But realistically, it will not break down on its own. And it's a great product. It doesn't lose quality as it's being recycled. Not to maybe jump to any other point you're making, but it should be recycled, is the point I'm trying to make.
So let's jump into the details. You know, maybe you can talk about what kind of glass you do recycle. Oh, good news. No problem. Jennifer Cass, Senior VP of Sustainability and Resilience at the New York City Economic Development Corporation. She just made it. Fantastic. Thank you. Sorry, we had to start. No problem. So yeah, I was just about to say, let's jump into the details. Maybe you can talk about what kind of glass actually can be recycled, that you recycle, and can be put back into the float glass stream.
Yeah, so we recycle all types of architectural glass. We recycle glass post-industrial from manufacturers, even pre-industrial in some cases, from floats. and then we recycle it out of buildings as it's being retrofitted or replaced or rejected, change ordered, all of those things. We can recycle it with the frame attached or not attached. Not all of those processes get it clean enough to go back into float glass. So some of those may be going into a product like fiberglass, reflective beads, abrasives, still replacing virgin material in the product, but not necessarily going back to float. But we do have the ability to get a large portion of that clean enough to go back into float.
So just to summarize, just to be clear, for years I've always been told that you cannot recycle coated glass, so that's no problem. Dario,
no, it's not.
No problem. That's great. Laminated, no problem. So the only type of glass that's problematic, I understand, is fritted glass. Correct?
Yeah, for the floats, that's absolutely correct. There are other consumers that can use fritted glass, so it can be recycled, just not into float glass.
Okay. So how much of glass do you typically recycle in a year?
Next year we'll recycle between 150 and 170,000 tons. So a fairly significant volume of glass. Unfortunately, most of that is still post-industrial. So post-consumer is the area that we see the most need to grow into.
Right. Okay. So you touched upon something already, the quality of the collet, the inclusions of materials. Maybe both of you, Dario and Jeremiah, you can talk about like if there's any standards for collet that apply. So you have, as a floater, you have stability of the material that's coming in. And Jeremiah, maybe you can talk about that. Like to what standards how do you shake hands with your customers?
Well, I would say it takes a lot of, first of all, trust, but verify. So Guardian would be very concerned that the product that we would provide them would be up to their standards. Once it gets into the furnace, of course, if there's a material that shouldn't be there, it doesn't want to come out. So it can cause a lot of damage. And then really, I think, I'm sure Dario can tell you a lot of stories, but really it's the floats being willing to accept the risk factor that naturally inherently comes with taking back recycled cullet versus virgin material.
Okay. And you're fine with that, trust?
No, he's exactly correct. If you guys think about glass manufacturing process, in one of our plants, and we have 8 of these just in in North America alone, we make about 600 tons of glass a day. That's about 330,000 square feet of 6 millimeter glass. And so one defect, when our employees, we check what tools they use, if it has nickel in it. So our batch is very sensitive. However, I think there are lots of economic benefits in using collet. Obviously, the metal and ceramics, for example, for fire-rated glass, are 2 enemies of our internal process. And so with pattern like Infinite, they have internal quality processes and they can meet our spec, and it will help us bring the melting temperature of the glass and at an economic point.
But I think it's kind of interesting that the glass industry is almost based upon recycling a pre-consumer glass. That's been done all the time. Maybe you can talk about this, why that is.
Yep. So if you look at the glass manufacturing process, roughly half and half of embodied carbon comes from mining the sand and all other ingredients that go into glass, and the other half is the energy of melting the glass. So with that being said, that energy to melt the glass is a huge component of carbon. And by having internal collet or collet from our direct customers that's verified, we can bring the melting temperature of the glass from, let's say, 3,200 degrees down to 2,900 degrees Fahrenheit. And when you stop and think that every 100 degrees of Fahrenheit is directly proportional to the amount of carbon that we consume to melt the virgin material.
So maybe you can, okay, that's great. But can you talk about some other technical issues that may come with more cullet? Is there any problem? Could you technically just use all cullet
Sorry, can you repeat?
Could you technically use all cullet to make new glass? Or is there any technical?
Right now, we are so far away from being technically, maybe when we get down to 50% cullet, maybe we could get to a technical issue, have the material and batches mixed. But right now, the cullet represents very small portion, especially post-consumer cullet represents a small portion. And when you stop and think, part of the reason we are having less and less cullet in our own process because we are being more efficient with yields in our plant. And that's actually a good thing from carbon point of view, since our EPDs from 5 years ago versus the ones that we published last year, 23% less embodied carbon across our fleet of plants. And big part of that is because we became more efficient in melting glass and reducing amount of cullet, because all the cullet that that's not cullet is a shippable product. And so we can actually almost take all the cullet, and we are actually seeking more cullet from our customers and maybe even post-consumer sources.
Can you talk about a little bit like the savings, the carbon savings that you can achieve? Hisham, two presentations ago, he talked, I think, about like a 40% savings for glass. Is that what you're seeing too for your kind of?
It could be depending on amount of cullet and the sources and color and type of glass.
But one thing that probably keeps us from using more like low carbon glass is cost, obviously. So can you?
Actually, the cost is we actually, when you stop thinking, we want to carbon is cost of glass. When you stop thinking, energy is our number one expense in our own process. So the less energy we use, the lower cost for us. But it's just that there's not enough recycled material that we can use in our own process to consume it. So I think this is in a way we are at the point where we actually, if we have a process in place, like, and I think that's where company like Infinite comes in place, if they can provide us with continuous and verified source of post-consumer product, then it could be cost neutral or cost beneficial.
So it could turn out to be a win-win solution.
Exactly.
I mean, if we get more cullet, Jeremiah, if we get more cullet, then the glass gets cheaper. It sounds like
exactly
and greener.
And the project that we discussed, for example, Jeremiah and Infinite has a project here in New York City, and their processing facility is in upstate New York, and our plant is in Geneva, New York. So, it would be a good story and actually realistic story if we can make glass from building here in New York City, take it to here in the state of New York, and be glass and manufacture or melt it back into glass and be used on a project in New York City. I think that would be. It's not just marketing; it's also good for environment. It's good for carbon.
Great, thank you. Want to pivot to Jennifer here. You recently co-authored the Clean and Circular Design and Construction Guidelines for the New York City EDC, which is a key objective within the New York City Green Economy Action Plan. Can you please summarize the primary objectives, your goals of these new guidelines?
Sure, and want to apologize again for my tardiness. There's a misunderstanding, I think, at the door. We recently published these guidelines. You can find them at EDC's website if you just Google Clean and Circular Design and Construction Guidelines. And as Stefan mentioned, they're published in conjunction with our Green Economy Action Plan. So within the guidelines, we have three goals. One is targeted at reducing our overall construction materials disposal, so trying to recycle as much of the material that we see either through what you might call demolition, we're starting to call deconstruction. And then we have a second goal that targets specific materials, including concrete and brick and dirt. And our third goal is to use as much sustainable materials in a building construction process as possible. And so when we're thinking about circular construction, we're definitely thinking about reused and recycled materials as much as possible, but we're also thinking about biophilic materials such as mass timber, hempcrete, and the variety of things that are being researched out there. So we're taking a holistic approach to this, but we set up these goals to really look at something that was a little bit of a stretch, but still achievable. And very happy to hear about the movements in the glass industry. And I wanted to concur with your statement about looking at cost versus carbon. We find the same thing in general, that, there's this perception in the industry that to make something, especially in the construction industry, to build something more sustainable, that's going to be a cost premium, but we really don't find that to be the case. And most of the industry partners that we speak to find the same thing, that you might be substituting a different type of cost, like labor versus, material, but overall, it's not driving up the cost of a project. There's certainly other factors driving up our construction costs, but sustainability is not one of them. And overall, especially if you look at the life cycle cost, you're seeing a savings.
But so how is glass specifically addressed in the guidelines? Is there like an upper limit for substrate or for?
We don't have a specific goal for glass. With this being the first issuance of the guidelines, we really were looking at more broader goals and seeing how our consultants react and how the industry reacts, and letting people be flexible in how they address the solutions. These are meant to be guidelines for any construction project that EDC undertakes, and we do a variety of different typologies. So we might build a building, we might demolish a building, and we might build a waterfront esplanade, which doesn't have a lot of glass, right?
So basically, if I'm an architect working under a contract for you, I am obligated to follow these guidelines. It's a must.
That's right. We think of it kind of as a make best efforts, similar to our MWBE program. But if someone does not make best efforts and is not really striving to find a way to reuse and recycle material, we're going to push on that as much as we can.
I mean, New York City is a leader in a lot of things. And I was just wondering, as you were drafting these guidelines, were you in touch with other municipalities elsewhere in the country? I'm sure they are interested in what New York City is doing.
Yeah, we reached out to people around the world, actually, and in New York City as well, because we wanted to see what was achievable in the local market. And we also, we had a partner in Jacobs in writing the guidelines, and they did a lot of research as to what requirements and standards have been set around the country. So we looked at those as sort of benchmarks for what is achievable across the country as well as in New York.
So I want to come back to the question I asked earlier. Like, so if would I get a contract with you? And I know the answer. I wouldn't, as an architect, I don't get the contract unless I commit to these guidelines. So they are must do for projects from you. But you're hoping also for like other New York City projects adopting these guidelines?
Yeah, that's right. They're a must do for any contract that a design consultant, a construction management consultant, or an EDC contractor working with EDC on any of our projects. But and I should clarify, there's no incentive. You don't get a bonus if you use the guidelines. You have to do it. Okay. So bone up. But we do hope to set an example and serve as a benchmark and a leader and drive the market with our projects. We have a $6 billion portfolio. So we really feel like we have an opportunity to do that. And the first project we're implementing the guidelines on fully is the Spark Brookdale campus. It's a full city block reconstruction on 25th Street and the FDR Drive. So, just with that project alone, we're going to be demolishing an entire CUNY campus and rebuilding 2 buildings, a pedestrian bridge, a public plaza, and 2 city blocks. So, and a flood wall. So we have the ability really to push the market and affect change.
Interesting. I think these guidelines are not so well known. That's why I want to go a little bit in the weeds a little bit. So let's say I'm an architect or a facade planner. What am I expected to do under these new guidelines? Am I to reduce the carbon, to get more collet into the flow? What are the expectations for me to do here?
Sure. So I'll try to thread this through the glass lens, since that's why we're here. I'm not an architect. I'm an engineer, so bear with me a little bit. But we just got our first circularity audit. This is the first one we received at all. So it's the first one that we have had for EDC and the first for the Spark project. So they essentially did a walkthrough of the campus and looked at record drawings, looked at aerial view, street views, and we're able to quantify the type of materials that are in the building right now. What they found was we have about 50,000 square feet of glass. And the calculation on that is equivalent to about 1 million kilograms of CO2. So much more than we were expecting. And but it's a concrete and brick building, so a lot of the material coming out of there will be heavy carbon sink. So as part of the circularity audit, and part of their role is to quantify the materials as well as identify ways that material can be reused or recycled, either on-site, off-site, or brought off-site temporarily and then brought back on. And that might be through a, probably not with the glass, but with some material. We have a lot of marble in the building. Is there a way to preserve the marble and bring it off-site temporarily for storage and then bring it back on-site? Or is there a way to find a marble storage facility or an architectural storage facility that someone might want to buy that marble and create a market for that. And then all of these things will be brought into the design process. The consultants, whether it be an architect or an engineer, they have to do a life cycle analysis and weigh different factors and find what things have the best bang for the buck in the carbon sense. They also have to do a life cycle cost assessment. So they're also looking at the cost perspective. But they will also be delivering a materials plan, and that will be in conjunction with the construction manager. The construction manager is responsible for collecting all of the EPDs on the project, as well as ensuring that just like anything else, the architect's plans are seen through, and they're not getting substitutions for a material with a lower recycled content, or material that was planned to be recycled is being dumped in a landfill. So all of those things will be written into the specifications, and just like any other deliverable.
This is great to see that the city is pushing this hard, and I want to pivot a little bit now to the private sector. And so, Sydney, you are with the Durst organization, and you have run projects promoting circularity in the past. What's the driver for you in the private sector to pursue this direction? Why are you doing this?
So I think to know why we're doing this, you have to know who I work for. So the Durst organization is a generational family-run real estate developer, owner, and operator here in New York City. We have about 13.1 million square feet of office building in our portfolio and about 3,400 rental apartment units. And when you are a generational family company, you are constantly thinking about what is going to happen a generation from now. So when you're thinking at that time frame, I think you're inherently having to think about the impact of choices you make now and the reality of what happens beyond the immediate. So when you're thinking circular, I think it's a direct connection about, okay, I can't just be immediately seeing what is being installed on a construction site. I have to think about what's happening before, and I have to think about what's happening after, because there are certainly externalities and impacts that happen during both those phases of a product's life cycle, even if I'm only seeing, let's say, the plate glass that's going into my envelope.
This is great to hear that organizations that you think like are very commercially oriented, but are actually very, very interested in the future and long-term development, sustainable development. So I wanted to show a slide that you gave me. Besides the technical and commercial aspects that we talked about already here, from using more collet, there are also moral considerations for using collet. Can you elaborate on this a little bit? What your research has shown to you?
Sure. So I may have gone down a rabbit hole when I started to really get into materials and glass, and I'm a materials nerd. So bear with me. I am not a sand expert. Let's just all make that clear. But I think when you start to, again, think about the impact of what you are buying and specifying as a product, and then what happens to it afterward, you end up finding details like this that are on this slide. So one of the things you see is that sand is the second most mined natural resource in the world. The majority of that is going into concrete, but about 10% goes into glass. I think what you don't realize when you start to look into sand is that it's actually pretty nefarious. There are literally sand mafias that control illegal sand mining. It's incredibly detrimental to our natural resources, to riverbed depletion, coastal erosion. There's an incredible book out called Material World with a whole chapter dedicated to sand and how, well, okay. Go read it. There's an insane chapter about like how 500 million tons of sand, they cannot figure out where it came from for entire country projects. When I think, so anyway, all that to say, when you're thinking about reducing the mined content of these products and taking something that is inherently has value and it is not being valued, it's essentially thrown away in a landfill, it feels like a nice match to be able to, one, address mining concerns, but two, frankly, use something instead of just throwing it away.
Let's come back to the projects after this, the sand discussion. Yeah, but which is, I think, like I didn't know. I wanted to show this because I had no idea about this, and so I wanted to show that slide. It was interesting to understand that. But so maybe you can talk about these projects where you implemented circularity. Maybe you can talk about like some of the details that need to be that are different from a conventional project.
Yeah. So we have a couple of efforts we've been working on to really think about how to do this on big construction projects. But the one I should talk about is really our most recent one, and that was in partner with Infinite, and I will say Saint-Gobain, who spoke earlier. We demoed about 65,000 square feet of interior office space, and we recaptured all of the office front glazing through Infinite. That is about 22 tons of glass, and we are going to, it's going to be sent for manufacturing into new fiberglass insulation. Now, it's not going to make a lot. It's going to make like 2 baths of insulation. Let's be clear, it's 22 tons. But what is so fascinating is it's not that it's hard. Well, now that Infinite is here, it's not that it's hard to actually capture and recycle this glass, but there are a lot of constraints and let's say people trying to do things very quickly with let's say, a labor force that doesn't really care where your demoed stuff goes. And so the reality of executing this on a fast project with a very, very intense timeline is that we needed to actually have a lot of conversations early on. We had everybody at the table, including the demo contractor, the CM on the project, me as the owner, Infinite, months before we started demolition. We had to get it into the writer for the demo contractor so they knew that we were going to do something different with that interior demolition. And we had to make sure that we had the loading dock correct, the logistics of removal. We knew the sequence of how this was going to happen. And actually what turned out, which is what I'm trying to tell everybody that will listen to me, is that it's totally doable. It does not impact your schedule. It does not impact your budget. And actually the sequence of doing an interior demolition project, you can take the glass out. It doesn't have to be whole. You can smash it. You can put it in wheelbarrows. You can put it in hampers. You can get it to the loading dock. You throw it in a 30-yarder, but you cannot use packer trucks, which is how typical interior demo happens here in New York City. So if you don't get it into your scope award early, you're going to miss your window. Anyway, so it's logistics. Honestly, it's logistics and conversations.
Yeah, it sounds like you've learned a lot doing these projects. And I also know from our discussions before that you're working together with architects and others in developing some specifications on your projects that implement recycling procedures.
Yeah, so I think the big ethos of the company I work for is that we cannot be the only ones doing this. This only works if we broaden this and invite others to be doing what we're doing, which means sharing what we're learning, giving resources, and trying to assemble a group of stakeholders that are invested and willing to do what we may have piloted. So we had our second working group where we are drafting specifications for architects to use in their construction waste management spec to get into those contract documents, to have that conversation early with the demo contractor. We are also trying to figure out how to incentivize manufacturers to put this in their product. So as you saw with the Saint-Gobain presentation, can we figure out how to put a minimum specification of post-consumer plate glass into the spec to show that there's demand for this product if it's included? But yeah, so hopefully those will be out momentarily. And if anybody wants them, please come talk to me. Happy to share.
That's great. So we've now heard from all of you. We're getting close to the end here, but we have a little bit of time left for a discussion here. So we started talking about the 120 tons of glass and staying in the city for a minute. There's no doubt that there will be a lot more projects like we've seen, like I started talking about here in the future. We will see more demolition of glass facades and entire buildings, actually. Do you think circularity will be a central concern for owners initiating these replacements?
Is that for me?
This is for all of you. Central concern, like.
I hope so.
Yeah, absolutely. And I think when you stop and think, the landfill costs keep increasing. So there's a cost benefit in all of this. Obviously, the cost of our ingredients and energy is going up, and the cost of landfills. And I think at some point in time, and that I think we are very close to that point in time, we are here. That will balance off. It will be advantageous economically.
Yeah, I think there's so much work being done, to the point about the earlier presentations about operational carbon and emissions, but there's sort of a hand-in-hand process that's about to go underway with people doing retrofit on their envelopes and needing to improve the performance, that you can achieve this additional benefit by being able to reclaim this glass, recycle it, and put it into something else, which then that processing energy, as you mentioned, also reduces the embodied carbon of the product itself. So it seems like a natural fit for the city being already sort of moving towards these efficiency retrofits on their envelopes.
So I think in closing, I really hope that that you guys walk away and you've learned something here. I certainly did. I heard that it's doable. I heard that hopefully it is already cost neutral. And so why are we not doing it? So I think we got to walk the walk. And I hope you enjoyed the session. Thank you so much. This was fantastic. Thank you.
Thank you.
Thank you very much. Please remain on stage, and I would like to invite our speakers for a photograph. Everybody on the stage. Thank you very much.
All right. Is this a good volume? Okay, great. Welcome to the afternoon session. This is track C, which is the purple one in your program. So if anyone was thinking they were an A or B, either as a speaker or an attendee, this is the time to go that way. If you're meant to be in track C, then welcome. I am the session chair. You won't really be seeing or hearing much of me, but I am only here to introduce the speakers and to keep general order. So hopefully that will be an easy task. So first up, we're going to be listening to Caroline Johannesson, who is a senior associate at SOIL, who will be talking about delaminating New York City's building envelopes in a talk called Layered Living. So welcome up. And also I should mention to the speakers, I think you talked to the technicians already, but if something stops working, then there's a spare mic here. You knew this already. All right.
Hi, everyone. I'm really excited to be here to present the Facade of 9 Chapel. It's a 23-unit condominium project in Brooklyn, which is completing construction this fall. Let me see if I can. Great. But first, a quick introduction to SOIL. We're a 20-person studio based in Brooklyn. We were founded in 2008 by Jing Liu and Florian Eidenberg, and have completed institutional, commercial, and residential projects all over the world, and also right here in New York City. Our projects would not be possible without our ambitious clients, and also many, many talented and dedicated collaborators. In our process, we often start with the concept of the edge. The edge necessarily includes the traditional idea of the facade as a representational surface, as well as the technical limitations of the building envelope. But the edge is what mediates between the building and its context. And I'll just highlight, as an introduction, a few of SOIL's projects that are experiments in the edge, in creating edges. At Kucha Gallery in Seoul, it's one of SOIL's first projects, the envelope is made thick by pushing the circulation to the exterior and wrapping the form in a handcrafted chainmail mesh. Its draped form echoes the slope of the surrounding traditional rooflines, while creating an enigmatic and inviting landmark within the urban fabric. The Amant Arts Campus is spread across 3 blocks in rapidly changing industrial North Brooklyn. Its edge is extended and articulated to invite visitors deep into the site, where a series of alleyways, courtyards, and thresholds connect interior and exterior programming. The edge here offers a partially anonymous appearance, but with an unexpected tactility and careful detail that betray the everydayness of its surrounding industrial context. Cube House is an office tower currently under construction in Zuidas district of Amsterdam. It's a collection of lightweight timber boxes that sit on top of a concrete plinth that negotiates an existing parking garage below. Unlike the gallery program of the previous examples, office space requires maximum exposure to mediated daylight. Here, we quite literally delaminated the unitized curtain wall assembly to create what we call breathe spaces, or temperate microclimates that extend the office environment beyond its traditional boundaries. Las Americas is a prototype for vertical dwelling in León, Mexico. It's aimed at curbing urban sprawl and improving the quality of life for low-income communities. 60 condo units are arranged around 2 interior courtyards. Single-loaded exterior circulation provides cross-ventilation with voids for shared outdoor space. To accommodate an extremely limited budget, the facade is assembled with a custom prefabricated block and a repeating window unit. The sawtooth aggregation along the figure-8 form creates privacy. No 2 units face each other, and also gives character and differentiation to the corridor. Working across different scales, budgets, uses, and climates, we seek to shape the building's edge using massing and program organization, as well as careful detailing of materials and assemblies. By thickening, elongating, delaminating, and articulating the building's envelope, we create spaces that foster connection between inhabitants and their surroundings. Just a quick plug for our forthcoming book. We've collected our housing projects with a series of texts and essays. In Brooklyn, we've collaborated with Tank House, a Brooklyn-based developer, on 3 multifamily condominium projects. In the center, you can see the 2 partners with their dogs on the rooftop of 450 Warren, which was the first project we collaborated with them on. And on your farthest left is 9 Chapel, which is our second collaboration with Tank House. And now I will present to you its facade, or its envelope, but most importantly, its edge. Like in the previous projects I showed, 9 Chapel's edge was developed within a specific context. In this case, New York City, where regulatory, financial, and physical constraints restrict housing development by demanding neat delineations between home and community, private and public, and the conditioned and exterior climate. The majority of residential buildings in New York City feature envelopes that isolate residents from one another and the surrounding environment. By delaminating the layers of the building envelope, we can reveal opportunities to reestablish connections between our homes and our city. So to understand the context of 9 Chapel, I will first describe the context of these layers. The outermost layer of the envelope is constrained by the zoning envelope. In his prophetic response to the 1916 zoning resolution, Hugh Ferris describes the zoning envelope as, quote, a shape which the law puts into the architect's hands, and that without a preconceived vision, the architect follows logical steps to mold it into a practical final form. While Ferris's steps may have seemed straightforward in 1929, things have become much more complex today. In housing especially, subsequent zoning regulations like setbacks and open space ratios, quality housing, deductions, and affordability incentives now interact with complex market forces. Spreadsheets control much of the decision-making process, with efficiency ratios setting the limits for the building envelope before the architect can even take any logical step. The innermost layer of the building is determined by the core, which embodies all necessary flows through a building: people, energy, water, gravity. That the core mainly exists outside of the sellable floor area means it is ruled by efficiency. But the core need not be regulated to the purely efficient shaft in the dark center of the building. An early example is the 1890 Riverside Apartments in Brooklyn Heights, where exterior circulation allowed 2 orientations of daylight and cross ventilation. By re-examining the core's relationship to the envelope, the journey from city to home can be enhanced without sacrificing efficiency. Between the outermost layer of the zoning envelope and the innermost layer of the core is the thermal envelope. The Energy Conservation Code mandates that a single line can be drawn between inside and outside in order to calculate the energy efficiency of a building. A shorter line with fewer punctures achieves a more efficient envelope. As the imperative of envelope efficiency ascends to the forefront of architectural priorities, it paradoxically fosters a disconnect, insulating our immediate living spaces from the surrounding environment that demands our stewardship. While the capacity for an envelope to keep rain and wind out is non-negotiable, its thermal performance has historically been in flux, with a direct correlation to the cost of energy. Rising energy costs, coupled with an attuned awareness of buildings' contribution to global climate change, has resulted in regulation requiring thicker insulation. The thicker envelope assembly, however, conflicts with the profitability of gross to net floor area ratios. And despite the introduction of a floor area deduction for envelopes that meet higher energy performances, thinness remains a virtue. In New York City's housing market, one material has become dominant for its insulation properties, affordability, and relative thinness. EIFS, short for Exterior Insulated Facade System, is commonly paired with a masonry or panelized rain screen at the street-facing facade, while the remaining building envelope, including party walls, court, and yard-facing facades, setbacks, and bulkheads, homogenize into a smooth, monotonous surface. The distribution of budget toward a single face of the envelope is indicative of the regulatory and economic environment in which housing operates in New York City. To meet the target efficient ratios, the thermal envelope is pushed tight to the zoning envelope, while presenting an image of luxury only toward potential customers. In a typical New York City housing building, the focus on efficiency often forces residents into narrow, streamlined corridors, disconnecting them from the city and surrounding context. While zoning setbacks can provide outdoor space, it's usually reserved for those at the top floors. And when offered lower, it often results in inhospitable balcony extensions. To create better living environments, we need new metrics that prioritize spatial qualities, such as access to ample outdoor space for all units, multiple orientations for daylight and ventilation, and more diverse interactions with the surrounding context along the journey from city to home. Nine Chapel serves as a case study in delimiting the layers of the building envelope to create an edge. Nine Chapel's unique location allows for 360-degree exposure. The surrounding urban fabric of towers in the park, industrial, and institutional buildings meant that the expression of Nine Chapel needed to stand on its own. The principles of the plan and massing logic summarized here are integral to the development of Nine Chapel's facade. So I'll elaborate on them before I get to the facade, which I promise I will. In the plan, we broke down the massing into the scale of individual room, where subtle rotations and shifts between bedrooms and living areas pull the thermal envelope away from the zoning envelope, forming pockets of outdoor space. Like the 1890 Riverside apartments, the shared building circulation is exterior. The interior stair core is pulled out of the main building volume, sheltering the elevator lobby, and dividing the exterior circulation routes into intimate pockets of space that become the front porches for each unit. Taking advantage of the compact site and vertical zoning envelope, the towers of rotated rooms, some indoor, some outdoor, mean that every unit benefits from multiple orientations, cross-ventilation, and a variety of exposures to daylight. The room scale articulation and plan also allows us to calibrate the section to maintain efficiency while providing a diverse set of units, both in interior layout, but also in their access to different types of outdoor space. Balconies and terraces, some covered, others open to the sky, face different orientations and provide a variety of levels of privacy and exposure. These articulations and the use of other permitted zoning obstructions, summarized here, including bulkheads, balconies, dormers, and street wall articulations, erase the dominance of the zoning envelope in determining the building form. On the lower floors, the setback inverts, creating a permeable base for the building that steps away from neighboring structures. The building envelope the thermal envelope is pulled back from the property line, revealing a sunken garden beneath the building mass above. Following the subtle topography of the sidewalk, the terrace gardens buffer the shared amenity spaces and create intimate experience of entering the building on two different levels. An early concept image shows the intended expression of a unified, articulated volume floating above the street, in contrast to its grounded masonry surroundings. To achieve this, we worked with the concept of a semi-transparent veil that would wrap all volumes. The inner facade would be a contrasting material to emphasize the veil's lightness. At the interior volumes, the veil functions as an open joint rain screen system with black face mineral wool insulation behind. Here you can see the window installation before the mineral wool and panels were installed. At the exterior volumes, the veil continues to shelter portions of the terrace from unmitigated exposure to sun and wind and create a more intimate outdoor environment even high above the street. Using the structural logic of corrugation, the pleated screen panels span from floor to floor without the need for additional structure. We had different datums at the openings, which are at guardrail height and curb height and tie back to the handrail. The veil itself is created from a 4 millimeter thick aluminum sheet perforated with 3/8 inch staggered holes and corrugated to a depth of 4 inches. These dimensions, combined with a warm anodized finish, set it apart from typical corrugated panels, which might be too cold or feel too industrial. It was a long process of many mock-ups, tests, adjustments. On the right, you can see the distortion in the bends that had to be calibrated from the original machines. And it was important that the veil be identical from both inside and outside to reinforce a sense of lightness and looseness. To achieve this, we created 3 repeating panels with both curves and folds, which could be rotated and mirrored to create a varied pattern with no front or back. The inner and outer corners negotiate the multiple angles. Slotted holes allow for vertical tolerance during installation, while spacers allow for tolerance in plan. The curves and folds of the veil's geometry are mirrored in the inner masonry facade. However, the contrasting weight and robustness of the custom concrete blocks enhance the veil's feeling of lightness and transparency. At multiple scales, the combination of contrasting materials enhances the depth and layering of the envelope layers. I'll finish by showing some construction images. The scaffold got pretty close to our concept image, actually. And when it went up, it was immediately apparent how much edge we were getting on such a compact site. And as the metal panels went up, we saw the effects of the curves and the anodization, which constantly changed color throughout the day. During the process, we had argued quite a bit over exactly the right shade of warm silver. But in situ, the color was constantly changing, so everyone was happy at some point. So it worked out. Yeah, and it doesn't matter how many mock-ups or samples or renders or VR you do, as you all know, you never truly know until it starts being installed. And once they got past the first floors, we saw how the curves and the folds, both the softness and the sharpness and the way the light hit it, reinforce the verticality of the massing as intended. And from inside, the perforation created a dappled light and provided a sense of intimacy without compromising light and openness, which is very important also for the interior of the units. Finally, the scaffolding came down and the edge was revealed. And soon, most importantly, it will be inhabited. From the scale of the building in the city to the material detail, the process of delaminating the layers of the envelope can begin to transform regulatory, economic, and physical constraints into opportunities for connection, encounters with neighbors, filtered experience of climate and ecology, and unexpected interactions between the sanctuary of home and the life of the city. Thank you.
Thank you, Carolyn. That was beautiful work. Very interesting. Some housekeeping notes just as I'm up here. If whoever is coming and going could try and do so, for instance, right now, like as you're doing in the breaks, or if you have to go out and in during the talk, if you can just try to be mindful of the noise level, that'd be great. Also, I'd like to ask all of the speakers if you could stick around until this session is over, because we want a group photo on the stage. So unless you have to run for something, that'd be much appreciated. Okay, so following this, we have our next speaker is Peter Hutley, who's a principal with Curtain Wall Design and Consulting, and who will be talking to us about the 53 West 53rd Apex panels in the talk, Facades at the Top of the World. Welcome, Peter.
All right, good afternoon, everyone. Before I get started, quick couple words about CDC. We are a facade consulting firm. We have two arms of our firm, one arm that primarily works with architects and building owners doing design development, submittal reviews, field observations, restoration work. We also have a production arm that primarily works with subcontractors doing structural calculations, shop drawings, fabrication drawings, thermal calculations for glazing systems, and really all exterior wall systems. Today, I'm an engineer by trade. I'm not an architect, so I tried to make this something not too technical for the architects in our room. So really, this is probably the most complicated installation project that I've seen. And I kind of wanted to give everyone here the history of how the 53 West 53rd Apex panels ultimately came to be, and I hope everyone enjoys the conversation. A little bit of information about the building. This building is over 1,000 feet tall, over 500,000 square feet, 82 floors. It's primarily condos, 78 apartment units. And on the lower 3 or 4 floors, there is about 50,000 square foot of exhibition space for the Museum of Modern Art. The construction project team, developer is Heinz, design architect is Jean Nouvel, architect of record was AAI. And the construction team, Lend-Lease was the general contractor, facade subcontractor was Enclose. They partnered with Baker Metal Products as their manufacturer, and where CDC came into play was we were the facade engineer, the engineer of record for the facade for Baker Metal Products. Quick conversation about the primary facade. This is a unitized curtain wall system, triple glazed IGU, and there are 1/8-inch aluminum panels for vertical, horizontal, and diagonal, what they call diagrid bands. The idea is that the vertical and diagonal bands are actually tracking the columns and the sloped columns of the primary concrete structure, and the horizontal bands are tracking the floor lines. A couple of quick diagrams of what those look like. The horizontal panels are just glazed into the curtain wall system. The vertical bands, there's a couple of variations of those. Some of them are glazed directly into the curtain wall system. And some of the areas that is also your natural ventilation, those vertical bands are actually operable windows, some of them motorized, some of them not, to meet ADA requirements. And the diagonal bands are actually directly adhered to the glass. One of the things we looked at early on when we were looking at these diagonal panels is if a piece of glass breaks, what happens? And thankfully we had a VMU. We actually went out there and broke that glass to see what happens, and everything stays in place. So that seemed to work out well. For the MoMA wall, that was a specialty area for the first few floors. This is also a unitized curtain wall system, different system though. Laminated double glazed IGU and very large lights of glass. Just to give you the scale of some of this glass, the second floor is actually 28'6" by 7'6". Some of the largest glass that we've seen in a unitized curtain wall system, and just some quick diagrams of what that system actually looked like. But the primary focus of what we want to talk about today are the apex panels. So what you can kind of see highlighted here, and I'm going to have some zoomed in pictures in a bit, is that the curtain wall system comes up these sloped facades to 5 discrete points, which were called apexes by the architect, where we have the termination of the wall. No true proper roof, it just comes right to a peak. A couple zoomed in versions, apexes 1, 2, and 3 on the left are going to be at the top of house, and then 4 and 5 are a little bit lower on the building. And then there they are again, viewed from the opposite side. So here's a couple of pictures of those same apex panels on the building. You can see the gold one kind of right in the middle of the left picture, and you can see apex 1 at the very top, at the top of house. And then on the right side, you can see 2 silver apexes. You can see the lower one just behind, or just in front of the BMU unit, and then the upper one at the very top of the building, obviously. So these points, these apexes, terminate with aluminum plate facade, and the original architectural design concept for these apexes was to carry the unitized curtain wall all the way up to the very top of the building and then just put a cap panel on top of it. There were several issues that were ultimately found with this concept. Issue 1 was that there was very limited structural support. If you can imagine, some of the included angles within these apexes became very small. Because of that, the highest point of the primary structural support in some cases was 1 or even 2 floors below the high point of the apex. The most critical one I'm showing right here is actually there's over 20 feet of cantilever from the top support to the top of the apex. Now keep in mind, this is for a typical curtain wall system that is designed to span, call it 11 feet, 12 feet, 13 feet. Anyone who's done even basic structural analysis understands that that aspect ratio does not work. So the first idea we had was, well, let me go back. The first idea we had was, well, let's follow what's in the architectural drawings, which shows that these 2 units kind of come together and miter together, and we'll just build the whole thing out of one big unit. Which brings us to issue number 2. What you can actually see on the left is this is the vertical alignment of the panels on opposite sides of the apex, and then on the right you can see what the alignment of the panels looks like from above. The lines of the panels don't actually line up on one side of the building to the other. Now, remodulating this by the stage when Baker Metal Products and CDC were brought onto the project was just not an option. The whole building had been programmed. The entire project was set up for the alignment of the wall as it existed. So there was really no opportunity to merge outer panel or one panel with the other and make it one big unit. Then, as we were starting to get into this design, issue number 3 was brought to our attention by the field team. And issue number 3 is that you can kind of see on a typical floor plan, this apex curtain wall is off to the left and it's extending almost 21 feet from the primary floor plate. And the only place you actually had to work on this floor plate was literally on the plate itself. There was no opportunity for putting scaffolding or extended workspaces off the side of the building, which meant that if you were going to try and build this as a traditional unitized curtain wall system, you would have to have someone literally standing on a 10-inch wide HSS member out there trying to hang these units. It just was not realistic. There was no way to do that safely. So what do we do if we have no alignment, we have no access, and we can't change what this building looks like, and construction schedule demands that this system be installed quickly? We unitize the entire apex. So this is the apex 3 that I've been showing you guys. We actually went 20 feet wide by 14 foot tall, and we unitized the entire depth of that panel system. You can see in this picture that we have vertical framing members aligned with the panel joints on both sides. All of this is built out of steel. Here's a picture of what one of those assemblies looked like. You can see there's a lot of complexity inside of this assembly to try and track all the points where you've got different panel joints to make sure that you have an attachment point. Here's a picture of the same assembly except highlighted with how this was constructed in sub-assemblies. All of this is above the air-water line, so all of this has to be galvanized. So one of our critical constraints in terms of how we were actually building these assemblies was how big can we go and still actually put this in a galvanizing tub. So what we actually have is all these yellow and blue and green and orange assemblies are actually separate parts that were sub-fabricated, shipped to a galvanizer, galvanized, shipped back, and fully assembled into the overall unit. From an installation standpoint, this had to be done directly off the tower crane, which meant that there was limited ability for installation and doing connections and things like that. So what you can see here is what we devised as an anchor. There's a tube steel extending down below the bottom of this truss assembly that we've created that actually stabs into another piece of tube steel that is pre-assembled with the structure and is also preset with jack bolts both inside of the tube that is married into the apex and outside of the tube that is married into the primary structure. We also have some leveling bolts down below that are used for vertical adjustment once you get this whole assembly set into place. One of the critical structural design aspects of this was the wind pressures on these apexes. This job did have a wind tunnel study. When it was originally presented, the assumption by the wind tunnel modeling team was that all of the walls of the building would be independently supported, so there was no provisions for what is the net loading on both walls. So what we did was, once we decided that this was the route we were going to go, was we actually went back to the wind tunnel team and said, can you give us the net pressures in all 6 directions, one direction along the apex, the other direction along the apex, sucking it off the side of the building, net uplift, because some of these wider included angles, the net uplift was potentially a design consideration. And we actually got charts similar to what's below for all 5 of these apexes, providing all of the net pressures on the different walls so we could run that through a full structural design. Once we had that information, we were able to take it and run it through a full finite element model for the entire structure. Again, I have to run it through 6 different load cases, 5 different assemblies. Every single one is different because none of the modulation is the same, none of the heights are the same. Every design winds up being different. And then, as we're hoisting it, this truss assembly was actually rigged to be lifted with cables that could be disconnected from the bottom of the truss. So what you can actually see here is there's a couple of rigging cables that come down into this truss assembly, and there's conduit inside of the truss that allows those cables to run all the way down to the bottom end of the panel. And as this thing is hoisted, it's brought up and dropped into place, and then those cables are disconnected from below to pull the entire thing away. Again, this is being lifted to 70 stories in the air, so that's one picture of this whole assembly being lifted up. And once we kind of got the first couple of these done, what ultimately happened was this kind of turned into a partial top-out celebration as each one of these was installed. So this is Apex 2, same concept where it's being hoisted. You got the American flag there. There's the Apex 2 being hoisted into place. And here is, unfortunately, you're taking this picture from about 80 stories below, but this is actually the apex being dropped on top of the building with the workers underneath getting ready to do their work. Apex 1 became a special case. At the top of the building, we used the same concept. We expanded that concept. Ultimately, though, was expanded to include many other elements of the building. The primary structural columns. There was actually one side of this facade that turned into a sliding door. You can see that here. And that sliding door was because the building maintenance unit was actually inside of this apex. And the only way for them to actually have that installed was to put it in place first and then drop this whole assembly on top of it. And I talk really fast. Concluding remarks, the installation of the apex panels on the 53 West 53rd project represented the most challenging aspect of the project in the eyes of the facade subcontractor. The unique architecture and the limited site access required a lot of out-of-the-box thinking to create a constructible facade system. And in conjunction with our manufacturing and erection partners, we were able to devise a novel approach to installing the top-out facade elements in a manner that accommodated all of these challenges. That's it. Okay. Thank you, everyone.
I think since you rushed through that, if you want to take a question from the audience, if anyone has a question.
So we were the facade subcontractor for the cladding manufacturer, who was ultimately brought in late design assist. Same as any other cladding job, the facade subcontractor is going to be brought in a competitive bid arrangement. And ultimately what usually happens on these types of projects is, you're bidding the job based on understanding the typical areas. You may not have the entire facade laid out until once you actually have the job and start working your whole way up the building. That's what happened in this case was the first one, we had this project phased. I think we had 7 or 8 phases of curtain wall we were working on. And this area didn't even come up until about the 3rd phase we were working on. And once we got there, alarm bells started kind of going off in everyone's eyes of, okay, what are we actually going to do with this? And that's when, we kind of sprang into action to sort out what we were going to do. Sure. So at the topmost apex, that ultimately wound, okay, so the question was, at Apex 1, what was our role versus the structural engineer's role? So ultimately what wound up happening at Apex 1 was the structural engineer did wind up taking on the columns and the primary steel frame, and we ultimately provided the panels. At Apexes 2 through 5, we provided all of the steel, and including the engineering support for all the steel, all the way down to where we would connect to the high point structural beams. I'm sorry? 2 through 5, if they fly off, don't call me, please. But yes, I would get called.
All right. So I think that on that note is a good one to end on, I think. So thank you again. All right. Thank you, Peter. That was super interesting. Now we'd like to welcome Dean White, who is the regional facade sales manager at Cosentino. It's getting mic'd up, I think, right now. The clicker. It'll be talking about ultra-compact stone and how that enables sustainable facade design.
Thank you. Can everybody hear me fine? Yep. Great. It's a great opportunity to be here in front of you. I enjoy these Zak events. Today we're going to talk about ultra-compact stone and the ways you can get it on the wall and ventilated rain screens, curtain wall, window wall, etc., what the material is, and so forth. So we're going to talk about Cosentino real quick, give you a bit of an overview, and start from there. So Cosentino is a global company. We're in 120 different countries. We manufacture different hard surfaces. One of the hard surfaces we manufacture is Decton, which is an ultra-compact stone. There's a few other manufacturers in that space as well that make ultra-compact products. We have 6,000 plus employees around the globe, and we manufacture with a sustainable approach to manufacturing. So we'll talk about what that means. What that means is we use the 3 pillars of environmental, social, and governance. I'll talk about social first. That means we want to have a positive, lasting impact, sustainable impact in the communities we're in, the people that are working for us and the communities we're working in around the globe. This includes giving back to the communities, but also being a sustainable business that is providing employment and opportunities in the markets that we're in. Very, very key. Governance is the idea that we are transparent about all our efforts around sustainability. We report on it on an annual basis, and it's third-party verified to global standards. So very, very important, EPDs, et cetera, and all the efforts we make around sustainability. When it comes to the environmental side, that's really the physical part of the sustainability. And if you were talking to manufacturers 25, 30 years ago or working for them like I was, they wouldn't know how to spell sustainability, right? You made a product, you pushed it out to the market, you may have had a warranty on it, but basically it was a one-sided transaction going up to the market, as opposed to this philosophy to understand that everything's interconnected and you've got this circular economy. So that's the first thing, having that mentality of a circular economy. And then it starts at the procurement. So when we procure raw materials and so forth, inputs to our production, we're going to purchase from a supplier that also has a sustainable approach. Very, very key. So if we've got 2 products that are alike, one of them is from a sustainable partner, we're going to choose the one that's from the sustainable partner. That's the first thing. The second thing is we design our products from the start to be sustainable. This is really key. It's not an afterthought. So we think about the embodied carbon, we think about the amount of energy, the recyclability, the recycled content, all these things up front, and we design the product to perform with all those in mind. And then the more physical part on the production side is really key. One of the things is to seek out best available technologies in the manufacturing process. And I'll give you an example of this. A Decton ultra compact line is about 1 kilometer long. We have 3 of them. And the last station they go through is they go through 200 meter long ovens, and we heat the product up to a liquid state and then let it cool and bond at the molecular level. Those ovens currently run off natural gas, so we've got emissions there. We're switching those to hydrogen. That's going to bring the emissions way down. The current gas and emissions we have, we offset with carbon credits and projects that we invest in around the globe to offset that, to get to a carbon neutral status for the product. But we're going to have to do less of that in the future because we're going to reduce our emissions. So best available technology. The other thing is energy. We only use renewable energy in our factory. We've got about a 25 million square foot campus. We have the largest self-consuming solar farm in Europe. That only provides us about 20% of the electricity we use. We use the equivalent to 400,000 homes of electricity. All the other electricity that we purchase on the open market is from certified renewable sources of wind or solar. Water. I like to see some people here from my generation here. So when I say we manufacture about an hour from where they used to film all those Clint Eastwood spaghetti westerns, and you think how dry that is, it's really dry in the south of Spain where we are. So water's a precious resource. We recycle 99% of the water that we bring into our production process. We lose a bit through evaporation and through feeding a green belt around the facility, but we don't discharge any water because it's going to evaporate. We also built a treatment plant to recycle the water from the communities around us because otherwise it would just discharge and evaporate. So picture dry river beds, dry creek beds everywhere in that area of Spain. Very, very dry. We have a zero waste model. That means we want to get to the point where we have zero waste. All the inputs that come into the factory, we want to put to some kind of finished product or finished use. Okay, we're not quite there yet. We have a very high-tech waste management facility where our R&D department is constantly working how to reintegrate that waste into either our products or into the secondary products that are finished good. So no waste when it comes to raw materials. And the emissions. When we're moving material around the factory, we use robot sleds, and these robot sleds move the slabs of material around the factory. They go from point A to point B, the most efficient route, the lowest emissions. Unlike me, when I'm on a forklift and I see my buddy 50 feet over there, I stop, have a talk, go over to another one, and I finally make it to my destination. I've got all these emissions all day long happening. The robots don't have any friends. They just go point A to point B, right? Efficient logistics is really key. We're as much a logistics company as we are a manufacturing company, so we work to move our product around efficiently around the globe to keep the emissions down, and also partner with logistics company to do the same thing. You will see us, I know some people here have probably seen those new freight ships that have very tall metal sails on them. So that's a move that's going ahead at some point. And we will be, I'm sure, one of the first companies will have our product in those type of ships to move around more efficiently with less emissions. The product lifetime of a deck, in the service life, we rate at 60 years, but it'll last longer than 60 years. It has very low maintenance costs. So the total maintenance costs and the energy and so forth that goes into maintaining the product is very minimal. And of course, it is recyclable at the end of life. Of course, you know that recyclability is something that is attainable, but often doesn't happen because you can buy a new product cheaper than you can return a product for recycling in a lot of cases, particularly with building materials and so forth. But it is recyclable at end of life. And when we calculate our carbon neutrality, we talk about our emissions from manufacturing, delivered to anywhere in the globe, and delivered back from anywhere in the globe, all the emissions that are involved. So the result is we have a carbon neutral product. And what is it? Ultra-compact stone is a very unique material. We mine minerals that have gone through the metamorphic process, 20 plus different minerals. We pulverize them down, we mix them in a mud slurry, we put them in silos, we dry it out and leave just enough humidity to make a slab. So from a design perspective, it's very important to know that these products are slabs and they're not extruded products. So they're dead flat from slab edge to slab edge. So when you design, you're designing with flat planes and geometric shapes and not curves, for instance, or not with like baguettes and so forth, okay? And then that material gets formed in the slab, goes down the production line and hits a 25,000 ton press. It presses it for 10 seconds and makes it ultra compact. It compacts it with the weight of the equivalent of 2.5 Eiffel Towers for 10 seconds. Then it continues down the production line, hits 3 different decorating stations where mineral pigments are used to put the colors and the patterns on it. And we've also mastered now to put through body colors, so you'll see a lot more of that coming in the future. It goes through that, and then the last station it hits is the ovens that I talked about earlier. We heat it up to near 2,300 degrees Fahrenheit. It gets to a liquid state, And then when it cools, everything bonds at the molecular level. And it gives the product some very unique physical properties. So the product is UV stable. It's going to look the same 40 years down the road as it does on day one to the naked eye. It's not going to vary. If there's dust or grease that gets on it, you can just wash it off and it'll look just like new. You can use harsh chemicals if you want. It doesn't have any impact on the material. It's non-combustible, and it is non-porous. And that non-porosity is a very unique effect. Very low water absorption, so very low expansion and contraction of the product. It's freeze-thaw proof. It's not going to spall, do that type of thing. If graffiti goes on it, you can wash graffiti off with soap and water the same day, or 10 years down the road, it'll come off. You might have to use a pressure wash, but it'll come off. You won't damage the material, it'll look just like new. It is freeze-thaw proof, can handle lots of cycles of freeze-thaw, and it comes in a large format, which we'll talk about more in just a minute. Very dimensionally consistent. So it's a highly automated manufacturing process, and unlike some other slab products, it's dead flat from slab edge to slab edge, and the same gauge all the way across the slab. So very, very tight production tolerances. It's durable. It's 7 on a Mohs scale, so diamonds or topaz or itself will scratch it. It's highly impact resistant. Of course, impact resistance is boosted by the thickness of material as well, so thicker material is more impact resistant. But to give you an example, with the Miami-Dade NOA testing, we use half-inch material, and when they do the large missile test and fire it against the material, the large missile shatters, not the material. So very key, it's highly impact resistant. When you're designing, you don't have to use the same thickness or same attachment method everywhere in the building. If you've got very high traffic areas, you'll use thicker material, and you can move to thinner materials up above where there's less contact, and you can impact your budgets that way. So that's a key thing to think about. Don't get pigeonholed in one attachment method and one thickness when you're designing. Ease of cleaning and maintenance, I talk about low life cycle costs, carbon neutrality, and a 25-year material and finish warranty, although it'll last much longer than that. So sizes. We have 3 production lines, and in the market, the ultra compacts have various slab sizes. So it's really important to understand who you're going to work with early on and know their slab sizes, because you want to optimize your panel layout to reduce the waste of the material that you're using. Because if you have 20% waste in making a panel for the job, you're paying for that in the cost of the fabrication of that panel. So a key thing to know. So we have 2 sizes. We have 2 production lines that make 56 by 126 inch. And we have a third line that makes 64 by 130, which is really key for things like modular wall, curtain wall, window wall, where you can get that 5-foot width and have it in a total opaque surface like an ultra compact stone. Relatively lightweight, so 4 mils, just over 2 pounds a square foot. It's about a half pound heavier than ACM. When you get to 8 and 12, which are most common, then you're looking at 4.3 and 6.5 pounds. Lots of finishes, 70 plus to choose from. A very good alternative to natural stone, value engineered, and some of those colors, this is a bit old, but some of them, yeah, there are 90% plus recycled content. Customization is key. We'll do it from scratch for 25,000 square feet, or if we're combining stuff we already have, different combos will be 10,000 square feet. You see here a job that was designed with an ultra high performance concrete in a terracotta color. Curtain wall company come to us and said, do you have a color like that? We said, yes, we do. It was in a flat texture, a matte texture. They said, can you add texture to it? The architect did, and we did. But there's something key, and this highlights what I said earlier. That was not designed with our material to begin with. So when we did those panel sizes, the facade study, we had 49% waste, which is unacceptable. And that was with our smaller slab size. When I knew we had the big slab size, we redid it. That brought it down to 25. But we can actually make custom slab sizes off our 3rd production line. We have a set of widths and lengths that we can put together in different combinations, and we can reduce the waste. I just had a job with 38% waste. I said, let's find a custom slab size, see if we can find something that work, and it brought it down to 10. That has a big impact on cost. And we do colors that we don't advertise anywhere, solid colors that go out there and compete against other materials going on the wall that are in those solid colors. We do them for minimum quantities. We provide full slabs. Some of our customers do all the fabrication. We provide cut to size, often for curtain wall where they might be glazing it in. And we provide cut to size with holes or grooves depending on the attachment method. Line 3, I copied all or mentioned all the main things. But that custom slab size is really, really important. ventilated rain screen, curtain wall, or direct adhered options. You've got chemical or mechanical attachment methods, and you've got many different budget ranges can be hit with those attachment methods. Curtain walls, you can glaze it in SSG, or you can do it in a captured system. Obviously, you can unitize it. Here's an example of a unitized job in Germany, Cap West. And you can see what they did was they hung it with an undercut anchor here, put their vision glass in and hung it on site. Here's a job in Vancouver where the white flat panels are ultra compact. The fins are not, but you can do fins with this material. It's finished one side, so you got to bring two pieces together, adhere them, mechanically attach them back through the panel joint. Another one where all the fronts are done with an undercut anchor. And finally, Toha. This is one of our signature projects. It's an interesting building because it's flipped on its head. The mechanical is all down on the bottom. On here, we've got 11 different decked in colors, 6 of them custom. You can see the design here. And a very interesting X pattern down where the mechanical is, where they're providing ventilation to the mechanical area. Okay, so you can see that there. And again, you can see it here. And that's the first phase down on the bottom. There's a second phase next to it, which is started in 2022 and be finished in 2027. And that'll have decking on it as well. It's unique and universal. You can use its material wherever there's a hard surface, interior, exterior. So please stop by and see us, and we'd be happy to introduce you to our product in more depth. Thanks so much for your time.
Thank you, Dean. And wrapping up the presentation part of this will be Andrew Priest from Boston Valley. Where are you? Oh, there you are. I was looking at where you were sitting before.
I'm here to talk about a sustainable high-performance facade material, but first, before we get into that, I want to talk about the urban heat island effect. I'm sure everyone is well aware of what the urban heat island effect is here in New York City and the consequences of choosing different facade materials and how that can contribute to the intensity of the urban heat island effect. It's not just a New York City problem, though. If you look across the nation, it's basically in every metropolis around. You can almost make out our entire interstate system from this map. When you couple that with the global CO2 emissions, it paints a really picture. The built environment utilizes about 42% of the global emissions annually, of which 27% is from building operations, which, as you can probably put together, a lot of that is combating the urban heat island effect. So how do we deal with that? That's a question that Danish Architekten was asking at our most recent ACA event. They partnered with TransSolar, Nippers Helbig, and Tri-Pyramid Structures to try to solve those problems. They want to look at a way to direct and slow down the rate of water flow across the terracotta facade to improve evaporative cooling. They also study the different facade types and methodologies that you can install terracotta on a facade, and there's a myriad of different ways. Unitized curtain wall, precast, rain screen, shingle approach, and they settled on the shingle approach because it had the least embodied carbon to start, and they wanted to further optimize it. And you can see from the left-hand side, that was the baseline option, and they got all the way to, if you use timber, it's a highly optimized system from a carbon standpoint. So after the design charrette took place, they came to Buffalo in August and built this beautiful mock-up. The stainless steel is all provided by Tri-Pyramid, and Boston Valley produced all of the ceramic elements. But they didn't just stop here. They wanted to test and prove out their theory. So they looked at how simulating cooling the wall during a hot day would perform, and within 5 minutes, it dropped about 7 degrees Fahrenheit, and after an hour, it dropped about 16 degrees Fahrenheit. To take that even further, after a 10-minute rain event, they were able to drop the temperature by about 20 degrees, and after over 2.5 hours, the temperature of the terracotta facade was still 22 degrees less than the other walls that were also wet at the same time, which happened to be a CMU block wall. So what's next? How do we deploy this in the future? That was a great mock-up, but is it readily available for production to be able to put out in the marketplace? How do we continue to solve problems like this, and how does terracotta play an integral role in that. Challenge you all to think about that. For those of you who don't know what terracotta is, it's a timeless material. It's been around for centuries. It's known for its malleability, versatility, and durability. And it works great in historic context, where it was featured a lot, and also is integrated into a lot of modern facades as well. Terracotta is known as a 100+ year material. It doesn't fade or degrade in UV as either a natural through-body or glazed material. It also is mildew resistant, and Boston Valley is unique in where we do both historic restoration as well as new construction. So we've had the honor of participating on the restoration campaigns of a lot of the historic terracotta structures within our nation and abroad. But terracotta is not just a historic material. It's also one of the greenest materials out there. If you look at the building fluid pyramid, it's one of the greenest materials out there. We joke to eat your veggies, if everyone remembers the old pyramid. But all jokes aside, to put it into other context, when you look at the amount of energy required to produce terracotta versus other typical facade materials, terracotta requires half the amount of energy as cement, and aluminum is about 100 times more energy to produce than terracotta. So where does terracotta start? Well, it starts from one of the most abundant materials found on Earth, which is clay. We mix clay with a variety of different ingredients to come up with our mix design. And we put as much recycled content into our body as possible, which is somewhere around 30 to 35%. And that's where we cap out at. We make sure we're partnering with local clay mines to us. So regionality is very important. Minimize trucking. Clay isn't the lightest material out there. And we also want to make sure that all the clay mines follow the Land Reclamation Act. We don't want to work with someone who is going to leave the mine as an open strip mine like they used to do back in the day. We want to make sure they're restoring the mine and turning it into a thriving ecosystem once they're done working on it. Terracotta comes in a variety of different shapes and sizes, and we custom tailor our production to match your design intent. This project is the Robert D. Mortensen building located in Austin, Texas. This is actually a reclad of a building. On the left-hand side, you can see what it looked like before. Right-hand side, you can see what it looks like after. They say the greenest building is the building that's already built, so why not clad it with a material that's very green and sustainable as well. Sustainability was actually a key component as part of the 512 West 22nd Street, designed by Cook Fox along the High Line. They were looking to achieve LEED Gold, and terracotta played a large role in that facade. They also want to exploit the malleability of terracotta. So this entire facade was extruded, but we were able to bend the terracotta to create both the concave and convex curves on the facade. The terracotta was also chosen to fit within the historic context of the neighborhood, and also coupled with some of the more modern contemporary facades that are existing there. The dark gray, kind of charcoal, metallic glaze was actually chosen to pay homage to the industry that used to exist in this neighborhood. Changing gears a little bit is a very bright, vibrant green glaze project known as Richmond Muse. It was designed by Allies Morrison in London. They wanted to reinvigorate the streetscape. So they looked to do that with the bright glaze terracotta. They actually call it faience in the UK. This project is unique where it used all 4 flooring methods that Boston Valley employs. So probably most familiar with extrusion, but we also do hand pressing, slip casting, and ram pressing, which allows us to create a lot of really unique shapes that other manufacturers can't do. That actually gives us quite the competitive advantage because we can realize your design intent without compromise. Changing scales a bit, it's a project most of you have probably seen, which is One Vanderbilt. There's about 180,000 square feet of terracotta on the facade between the spandrel panels and the soffit material. KPF was the design architect on this project, and they actually spent a lot of time trying to fine-tune the glaze on this project. They want to develop a glaze that both had reflectivity in it so that it could actually shine light on Grand Central, which is next door, but they also wanted to come up with a look that was unique unto ceramics by themselves, which is this pooling glaze. The other characteristic that pooling allowed for them to do is all the spandrel panels were put on an angle, and that diagonal line of pooling helped emphasize that diagonal axis as well. Permis de Lisa was the unitized curtain waller in charge of the project. We had about 14 months to produce the entire facade. So it was critical for us to partner with them and tailor our production process to ensure we are delivering all the panels to them in the right order so that they could install them in a timely fashion. And by all measures, it was a resounding success. The terracotta was not only chosen because of the unique glaze qualities it could offer, but they also wanted to fit the building into the fabric in Midtown. The soffit actually got its inspiration from the Guastavino terracotta tiles within Grand Central Station. This was a modern reinterpretation of it, if you will. And we actually had the honor of making the restoration tiles for the Oyster Bar within Grand Central. So terracotta has really become quite the prominent material within New York City over the years, and it's phenomenal to see a timeless material be able to go on a lot of these new super talls within the city. But moving beyond super talls is a project out on the West Coast. This is Orange County Museum of Art by Morphosis Architects. This is a really unique project for us, as it actually started off as an ACOB project. So in 2017, Morphosis came to us and they wanted to explore the malleability of the material, see how much they could bend and twist the terracotta. But they also wanted to understand the environmental impact that the terracotta could have. What's its thermal mass? Evaporative cooling, how much could that help with the facade given the climate that I was working within? So it was more than just the malleability. After the workshop, we proved that was a successful prototype. We worked hand in hand with Morphosis to develop the panel layout across the facade so it could be optimized for fabrication and also erection. There's about 6,000 curved panels on the facade. We got down to about 80 unique types. So that's a little over 1%, which is quite a feat. Another fun part about the project is the lettering on the facade. We actually hand carved that into the panels to add a nice signage feature for the project. So those were all really beautiful projects that were built works, and they started to explore the possibilities of how terracotta can be more performative in the built world. But it's capable of a lot more. So we developed a workshop called the Architectural Ceramics Assemblies Workshop, ACA. And I want to just run through a couple of these quick projects with you to discuss them. So this first one is Woods Baggett from 22. They're looking at how to integrate PB panels within a terracotta spandrel so that the terracotta could actually articulate the PB panel so it would perform better than a typical flat panel. They also look to have the glaze help tie in seamlessly with the PB panel so neither one stood out starkly against the other. Wish Jenny Elsner in 22 as well looked to reimagine how a rain screen cornice could be developed. They do a lot of restoration work, and his terracotta cornices were torn down in the 70s and 80s, really for a lot of structural reasons. And a lot of building owners want their crowns back on the facade, but they're too heavy. So WJ came up with this really nifty idea of using our rain screen technology to be able to put a lightweight ceramic cornice back on the facade, return to its former glory, if you will, and also made installation actually quite a bit easier too than installing massive terracotta blocks. The next project is from Seldorf Architects with Silcotech. This project, they look to minimize the amount of weight in a terracotta panel by looking towards origami and folding to produce the panels. They were able to achieve a 50% reduction in weight per square foot on this facade, and they also challenged us to find post-consumer ingredients that we could put into the clay body and glaze to be even more green. We actually found a pigment that is taken from stream reclamations from coal mines. So this is actually what gave this project its color. Rios and Arup look to create both a structural block wall and rain screen system to help minimize the amount of aluminum in the facade, but also create an active facade with pollinators and plantings in there to create a living wall. Cook Fox in the year prior also looked to do something similar, but they took one singular module and were able to rotate it to give it different programmatic uses. So there's a bird house, there's a beehive, and a planter within it. And each one has its own pod design for it. The pods were able to be removed and replaced if something was to happen to them. Henning Larson and Thornton Tomasetti looked to create a living green wall by having moss grow on the terracotta. The moss would not damage the terracotta, but they didn't want the entire wall to be a moss wall. So we actually used directional glazing and a crackle glaze to control where that moss would propagate. And then the final project is Eric Perry's. This one, they look to do actually something similar to what Hank Larsen did, but with lichen. This is in the down on the Thames River. And for the fishmongers, hence you can kind of guess where the shape of the pieces came from. But they want to grow lichen on the terracotta, so we actually put a gradient spray of the glaze on certain pieces to help propagate the lichens to grow on the bisque body and wouldn't grow on the fully glazed area. And then the speckle was actually to simulate that lichen growth without, so the building didn't change too much as lichen actually took foot. So those were all great projects, but those were just basically small mock-ups. How do we bring those to life? What do we need to do about that? So ACA is entering its 10th year now, and we've been dreaming about how to make ACA even bigger and better than ever. The idea that we're working towards now is actually turning it into a longer event where we can take these prototypes, do true testing on them, and introduce a feedback loop to really push these ideas to market and allow these phenomenal ideas to actually turn into a way to better the built environment with a really sustainable material. So I challenge you all to think, how can terracotta help you with your next facade project? And if you want to participate in ACOP, please stop by my booth and I'd be happy to chat more with you about it.
Thank you, Andrew. And as a thanks. As a long-term participant in ACOM myself, on and off, I can recommend this event, in its new format, as well as the existing one. So now I think we have recovered a little bit of time. So while the panelists for the final moderated panel sort of assemble themselves, if anyone wants to ask a question of Andrew or any of the other presenters, we can take like 2 minutes to do that. Or if not, we can also move on to Matthias's panel. So, presenting here, Matthias Holwich of HWKN, who I think will present his own panel. So I'll just get out of the way and let you do that. Hey.
Good to see you. Hey. Awesome. Hello, hello. How's everyone? So far, so good? Still energy? Amazing, amazing. So somehow 4 chairs gonna miraculously appear here. I hear it from the tech team. So, there already the first ones are coming. So good afternoon. So today, super excited to be here at the Zak World of Finance conference, the conference. So for this panel, we will explore the theme of handcrafting and modern aesthetic with old world brick. And we're gonna have some surprises for you, which is gonna be a lot of fun. But as we all know, of course, brick has been a fundamental building material for centuries, deeply rooted in the architectural tradition worldwide. But in our rapid and evolving industry, the challenge is to blend this old world craftsmanship with modern design sensibilities. So what our discussion will dive into is how architects and designers are reimagining brickwork, merging time-honored techniques with contemporary forms to create facades that are not only visually striking, but also sustainable and functional. We'll explore the balance between preserving the tactile, handcrafted quality of brick while pushing the boundaries of its application in innovation, modern design, including a little bit sprinkled in AI. Now I would love to welcome my panel, and the panel also going to give a presentation each. And the names are probably a little bit butchered because I speak Jinglish, so that's German and English. So we first have John Marcel. He's Executive Vice President of Sales of Consolidated Brick, with extensive experience in the brick and masonry industry. John has been instrumental in driving growth and forging strong partnerships across the construction sector. His deep understanding of materials and market trends has made him a key figure in delivering high-quality products and solutions for modern building projects. We look forward to hearing his valuable insights. Maybe I'll start with you, and then I introduce everyone consecutively. Awesome. All right, and here's a clicker. And there we go.
Can everybody hear me? Okay. Excellent. Well, thank you for inviting me to be part of the panel. We're very excited to be here as Consolidated Brick. We've been around for almost 60 years, doing nothing but brick and stone and all these wonderful buildings throughout the Northeast. So we're very happy to talk a little bit about some of the facades that we've done going back on some of these historic buildings. Some of the ones that we're talking about here had a lot to do with our architectural partner on this job, KPF, and a few of the other jobs we decided to bring up, just to give you an idea of what goes on bringing historic buildings, most of them are landmark-based, to coming along and bringing them to the modern world. So we're going to go back in time a little bit here as we get into a few of these projects. Let me just the green one in the middle. Okay. This is a video that we KPF shot at our facility. We're partnering on this job with General Shale Brick. They're a big part of a Wienerberger group conglomerate that you probably are aware of dealing with for your international people. This is part of their plant tour and how they manufacture the material. This is the brick that they used on a project that we were able to work with called 64 University Place here in New York City. So in looking at this, you can see some of the colors and ways that the brick are created using raw materials, kind of a cradle to grave kind of a situation with a lot of brick detailing. A lot of this detailing has to do with some of the modern designs that a company here that is on board with us, Ferro. We've been working and collaborating with them as well for a lot of these structural lintel areas on some of these buildings. So what I wanted to bring up here, first of all, on this particular project, this is an older building that we were very happy to be involved in back in the late 80s, called Carnegie Hall Tower. For those of you that know Carnegie Hall, this was a building that was built in 1891 and had undergone a lot of renovation. And at the time, almost 40 years ago, the architect Pelly Clark wanted to design something that related very nicely to the brick on the building on Carnegie Hall, which is, of course, a landmark approved project. And we worked very diligently with them to create, as you can see here from some of the pictures, some of the material on the right is the original building, some of the material on this 60-story brick tower with multiple colors, which it was kind of an iconic building for brick. Lots of different sizes and textures and colors, which is what we basically sell, was pulled off very well. This is some of the modern day renovation of Carnegie Hall. It's undercover right now, but we're very proud of supplying some of this back in the 80s. Roman sized brick, 1 5/8 by 12 inches nominally, and very proud to be part of it. Here's some of the older brick from the original building. Very cool looking. We really love to be part of this. As you can see, some of the infill brick was some of the brick that we had supplied back in the 80s. So it's a timeless product, brick, and it's something that many of the architects have used very nicely to incorporate into modern designs. Here's a original arch that they built back in the day. More exciting things about arches as we talk about the University Place project and how KPF and Ferro had worked out the engineering to create these fantastic arches on the building. Here's a quick shot of just the original on the right, which was Carnegie Hall in a Roman size, and then the base of the Carnegie Hall Tower job, which we were asked to relate to and not exactly match, but relate it and relate the whole building to Carnegie Hall itself. So we are very proud to be a part of that. The next building, for those of you that know the Meatpacking District here in New York City, just a few blocks south of us, this was a very old rundown area 30, 40 years ago. The developers came in, kept a lot of the old factories that were landmark designated, and we were lucky enough to be involved in this job. This is a BKSK job which took a lot of time to go through landmarks and whatnot. And the brick up top that you see is in addition to the factory that's on the bottom, factory building. And this new building up front here is part of a new relationship to some of these older buildings that were factory based. So as you can see, the bottom of the structure there is the original building. The top is an addition that we put on with the red brick. And then the building down below is the original that was, we were allowed to kind of relate and match to that one. So there's a better shot. So you can see these buildings are probably late 1800, early 1900s, and they want to incorporate the old with the new. And I think the architects did a great job looking at that. So that's about 10 blocks south of us. For those of you that have been down there, it's the jobs came out quite nice, and these were award-winning buildings. So I think that takes care of my area, and I like to go back to talk to, who's going? Matthew. Okay.
Awesome.
Thank you.
Thank you.
Thank you.
Fantastic. As a second presentation, we're going to have Ted Carpinelli. He's director at KPF. We have seen already other KPF projects here today, so it's really exciting. Obviously, KPF is a globally renowned architectural firm, and Ted, with a wealth of experience in designing iconic projects, he has been a key leader in shaping innovation in sustainability in urban spaces. Notably, he worked on the celebrated 64 University Place, demonstrating his expertise in creating dynamic, high-performing buildings. We're excited to hear his perspective and insights into the project.
Hello, everybody. I'm Ted Carpinelli from KPF, and I'm going to talk about 64 University Place. 64 University Place is a 10-story residential building in the heart of Greenwich Village. When we started looking at this building, we knew we wanted to kind of blend into the fabric of the neighborhood. So we started looking at the surrounding areas for some historical context. And you see this revival style of brick architecture, these beautiful arches and these piers. And we started to think about how that could kind of give us inspiration and direct our design. So when we started our facade concept, we ended up with a series of one-story segmental brick arches up the facade. It worked with the planning modulation and it worked with the building massing. But we didn't want a flat wall. We wanted something more unique, some more presence. So as we started developing the facade, we started looking at stepping the piers and the arches. And this is not something you normally see in like a hand-set brick application. And to be honest with you, without the assistance of Ferro and Consolidated, we probably wouldn't have been able to pull this off because it is extremely complex. And Andrea will go a little bit more into the support system of this, which we refer to as like a chandelier system to support this brick. In its final iteration, we determined that the piers and the arches would be done out of modular bricks, topped off with a soldier coursing of Norman brick. Inset into these arches, we had these aluminum painted windows and matching handrail that created these beautiful Juliet balconies for the units. And it all sits upon a natural stone Indiana limestone sill. So once we had the design kind of figured out, we had to figure out what we wanted the brick to look like. We wanted something very natural looking, but we wanted it to have variation. We didn't want a monolithic type of appearance. We looked at blending 4 colors, couldn't find the right mix, just wasn't working out. Working with Consolidated, we ended up on flash bricks, which gave us a really nice color variation that we wanted. It's vibrant, and it really sets the building off for the area. After the appearance of the brick, we had to figure out what kind of brick. We looked at these molded, washed sand bricks, but they're very dimensionally unstable. There's a lot of variation, and with the complexities of the arch, it was not going to work. So we landed on an extruded and wire cut brick. There was a very dimensionally stable, and they give us the crisp, clean look that we were going for, and still provide the textured finish for us. Now, we could talk about design, we could talk about selection, we could talk about everything, but in the end, it's the craftsmanship and the people who put it together is what really makes the project successful. So this was Noel. He was the site super for the bricklayers. And I just want to acknowledge the fact that without these guys, and you can see that he's proud of his work, without these guys, all of our designs would not work out. We wouldn't be talking about this building if it wasn't for these people putting in the work, the dedication, and having the skills and the craftsmanship to do it. So the street facade was very articulated, but for the back facade and the courtyard facade, we went more with a flattened wall. We still kept the same design language, the arches, the Juliet balconies, and you can see it relates to the surrounding buildings, but it's also a lot easier to build these walls than it was to build a front wall. So we put the money in the street facade. And because we really wanted the brick pattern to be very strong and to read, we went with a color matching recessed joint. That allowed the bricks to have some kind of shadow lines and you really read the patterns of the brick. And as you can see from the initial rendering to the final project, we ended up with a project that we at KPF are very proud to say we did, and very happy with the work we did with Ferro and with Consolidated, and the owner's very happy, which can't ask for more than that. So with that, I will turn it over to Ferro.
Thank you very much. So the third presentation going to be from Andrea Hatzini-Kolas, principal of Ferro, a leading innovator in the field of building envelope solutions. With a strong background in engineering and business, Andrea has played a pivotal role in advancing sustainable and high-performance facade technologies. And under her leadership, Ferro has become synonymous with cutting-edge innovation that enhances structural integrity and energy efficiency. Andrea's deep experience and forward-thinking approach continues to shape the future of the building industry.
I will discuss innovation and energy efficiency in masonry wall details. Before discussing innovation in brickwork support, let's review conventional shelf angle design. A masonry veneer requires a highly conductive steel shelf angle at each floor level, attached directly to the backing. The yellow bands in this image show the thermal bridging caused by this typical conventional shelf angle design. Brick is an inherently energy efficient veneer, however, it is a heavy veneer that requires steel support. What are our masonry support design options? On the left is the ugly, where the shelf angle is attached directly to the backing with no insulation. The bad shows added insulation to improve thermal performance, but the thick shelf angle still causes thermal bridging with that heat loss shown in the yellow bands that you saw on the prior slide. In this detail, adding more insulation increases the wall cavity, requiring a larger shelf angle, which worsens the thermal bridge. We often call this the dog chasing his tail detail. On the right is the good, where a thermal bracket is used with only point contact to the backing, and the shelf angle is offset, allowing insulation to run behind it nearly continuous. Using an offset shelf angle design achieves an 84% improvement to the effective R value in the wall assembly. How? On the left, the conventional design has the shelf angle directly connected to the backing, interrupting the insulation. On the right, the thermally efficient design uses a bracket that spans the cavity, allowing nearly uninterrupted insulation behind the shelf angle where it can do its job. The truss-like sides of the bracket further improve the thermal performance of the assembly. Thermal performance design is often viewed as a long-term return on investment. However, as we saw on the prior slide with the thermal bracket design, you're definitely achieving that 84% improvement in R value, which is the ROI that you're looking for in the long term. However, an added benefit is an immediate 50% reduction in material costs, as this design eliminates the need for heavy, expensive shelf angles. Plus, installation is faster and easier with no welding or specialized trades required. The cost savings and thermal performance in this high-performance wall assembly design comes simply from significantly reducing the highly conductive steel needed to support the brickwork, which also reduces the embodied carbon of the detail by approximately 60%. The conventional method requires 2 inches more insulation to match the performance that is achieved by a thermal brick design. Thermal brackets help designers optimize costs and most importantly, optimize their wall cavity sizes and maximize usable floor space ratios, which is really important to us here in New York. We had a great time collaborating with KPF to incorporate thermal brackets at 64 University. and masonry support systems for their 5-tiered arch design. Here are a few images of the supporting details on that project. As Ted shared earlier, they were referring to it internally at KPF as the chandelier design, so I'll have to let our marketing team know that you've bested them. We'll rename it. Thermally efficient wall assembly design can be applied to various brickwork details, including corbelling, as demonstrated in this Princeton project where we collaborated with my fellow panelist, John from Consolidated Brick. Here are a few more examples of brickwork support innovations that help contractors with on-site installation and allow designers to maximize the thermal performance of masonry wall assemblies, including corbelling, soffits, etc. On the left, we have a curved brickwork thermally broken support system, fully adjustable on site to match concrete conditions and allow for construction tolerances. On the right, you can see how the same thermal bracket principles can apply to custom geometry, creating energy efficient wall assembly details for unique brickwork designs. Here are just a few additional examples of thermally efficient supported arches alongside curved brickwork, both convex and concave. With over 3,000 projects in North America and including hundreds in New York, we've basically seen almost every, I hope we've seen almost every brick support detail there is out there. And with that, I will turn it back over to Matthias. Thank you.
Thank you. Awesome. So this is actually really exciting to see you guys on the stage as a collaborating team on a project. So I'm like the odd one out because I'm also presenting. I was not actually poised to be the moderator, but I became it. Because I want to just tell you guys briefly, so I'm the founder of Hawken, a boutique innovation firm for architecture in New York, recently kind of elected as one of the most innovative firms. And we love brick. Brick is awesome. We have used it on a high-rise in New Jersey. Maybe you drove by to the airport. We did that also for a neighborhood in New York, in Munich. This one is in New York, 25 Kent. Just opened a project in Frankfurt, and then also something on Broome Street. But what's happening right now, which is actually really amazing for us in our work, is that AI is kind of sneaking in on many different levels. And for me, it's actually started 2 years ago when I hung out with my friends and we played around with DALL-E. And suddenly I saw, it's like, oh my God, my kind of level of creativity now becomes replaced. But then I also played around with Lensa and I reinvented myself. So you see this haircut is still my haircut today because I went to the barber with this. And but what's so exciting is that there are so many different programs now on AI that kind of start to go into this architectural world where we can actually work on a lot of new innovations. And I believe that we are at a moment that is as relevant as at the Bauhaus with modernism. But modernism is over, right? Postmodernism was also there, is also over. Star architecture, sorry, kind of also over. So there's this whole kind of new kind of creativism that's kind of happening. And we have explored this, and this is where I see a lot of new application coming in. So we used all of these icons of New York City. We put them into the AI machine, and we let it come up with new ideas. So here you see the Rick Chrysler building, maybe reinvented. There's a new building. And then we're having something we call reverse engineering, where actually through our process, we can very quickly turn the AI into like a real buildable kind of project, but then of course with a lot of challenges that then have to be solved with a collaboration that we have seen just now on this very beautiful project. And it's like a whole new process of designing, right? Through AI kind of scripting, and then world building, and then choosing, and then we call it reverse engineering, where then these kind of really fun kind of designs coming in. Now the kicker is, very briefly, something new is coming because AI is also merging now with robotics. And we're seeing that robots slowly but surely going into the construction sites. And they become more and more kind of free from its kind of typical conditions of a factory. And we see that also applications, and that's already a few years ago, are going into this kind of world of the kind of brick with installations that can happen in a very different way. So I call this kind of buildings with a personality that we're seeing kind of shaped out of new kind of technologies. And yeah, so it's kind of an interesting new kind of scary world out there with AI, but also super interesting to explore and see where the journey kind of leads us in the future. And that's why now we're going to start our conversation about the past, the present, and the future of brick on facades and architecture. And first of all, I would like to ask everyone quickly just to say what excites you the most and what scares you the most about brick. Let's start with you.
Well, I think it's the same thing. It's just trying to be innovative with brick, right? You don't want to do the same old brick walls. You want to do something different, unique, and you want to push the boundaries. But that's also the scary part, is because you can't fail. You know, this is something that you have to really spend a lot of time on and really work the project and be realistic with it also. And then you're also kind of working within a modulation that's, you know, very strict. You're not dealing with stone panels, which can have varying sizes. You're dealing with bricks that have a very specific modulation, and it's designing the whole thing and actually laying out every brick to make sure that your design works. So there's a lot of, I think people think brick is easy, it's just like a pattern. It's not. It's very intense. You have to really work with it. You have to understand it, because you're off a little bit, you're actually off a lot.
Mm-hmm. So Andrea, I feel like nothing scares you, but is there something that scares you about brick?
I think, I think I'm seeing more and more with wall cavity sizes increasing, that there is the thought that a brick veneer, although inherently energy efficient and very sustainable, and the longevity piece being there, is that there's a misconception that using a brick veneer is going to make your project too expensive. And I think what I've tried to demonstrate today is that there are a lot of ways to optimize those details, optimize that usable floor space ratio, and bring those costs dramatically down.
Amazing. And John, since you guys delivered the brick for Carnegie Tower, like so iconic.
Very iconic. We're very pleased, and that's one of the reasons I wanted to show that building, is because that was almost done 40 years ago. And the original building was done 130 some odd years ago, original Carnegie Hall. So there's almost the past, the present, the future, and moving right along, right up the block here in our own town, for those of you from New York. But it's taking really the past and bringing it ahead by being able to get some of these original colors and being able to match a lot of this brick that is typically either companies that have gone out of business, companies that can't find the same raw materials that they had from years ago. We have to go where it was more of a locally sourced region going back 100 years ago. A lot of these manufacturers have been shut down, EPA, and we have to venture out now into other areas of the country to create colors that are more indigenous to those areas, because we can't get them anymore here. So it's a little bit of a challenge, and working with the architects that I feel are the big high design firms, which is what we really love about Matthias and KPF and all these folks that really know how to design buildings using masonry, brick, stone, full bed, thin. A lot of innovation has also come about with new technologies. Ferro is a good example of one. We've done a lot of buildings with brick and precast panels as well. These are all different technologies that have really enhanced our ability to really offer architects color, size, and texture. That's it. And then their creative minds are able to really look at the buildings and design really fantastic structures. So we're really happy to be part of that moving ahead.
And Ted, I mean, this is an amazing facade and very complex, but the three-dimensionality is kind of like architecturally priceless, but there's a price to it. What is your conversation with a client about the value proposition to do something like this?
Well, the client is a relatively new builder, right? And he wanted to make a statement, and this is a higher end luxury building, so he wanted something that he could really sell. Originally, the design was going to be brick on precast, right? So it was a little bit more of a simpler system. But as things went on, we ended up having to go to a handset brick. But he didn't want to give up on the facade because he loved it. He fell in love with it. He kind of was sold on it. So that's when we worked with Ferro, with Consolidated, and all these other companies to just make sure we could pull it off. Because at first, when you looked at it, our initial think was, this is going to be really hard to do in a handset, right? The stepping arch, we looked at reducing it, but the client was really adamant about maintaining it. And that's the big difference. If you have a client who will go the extra mile and push for it, you could pull these things off. It's when you don't have the client that wants to go the extra mile where you have to kind of pull back and try to maintain the design intent at the same time meeting their budgets.
Awesome. And Ted, you have to move your microphone a little bit up because it's scratching. Perfect. Thank you. Then people can hear you better. Andrea, now, do you guys wait for challenges to come from the planning team, or do you also look for your own challenges and come up with solutions out of a blue box?
Great question. I think all innovation stems from solving problems. And so I think a lot of the things that we have solved or seen before come from architects, contractors coming to us to say, you know, you did this here, what would you do here? I want it to be adjustable on site. I want to, you know, continue I want to achieve this design intent and preserve the image that you had from the very beginning. And so I think all that innovation really stems from that collaboration.
And do you see, or what are the biggest challenges today, maybe technically, and then I'm going to ask you the same question about sourcing, because you already hinted at that there are like sometimes challenges now about getting the right brick with the right color. But maybe technically, what do you see as the biggest challenge or opportunity?
Yeah, I see it all.
Oh, we got you there.
Oh, sorry about that. The engineering challenge is increasing wall cavity sizes. And so we're seeing more often that the heaviest point load of the brick is supported at the end of a long shelf angle. It's cantilevered out at the furthest point that it can be from its backing. And so that's a technical challenge that we have solved. But I think that continues to be, you know, the biggest challenge for brickwork in New York.
And John, what about you with the challenges about getting the right stuff to the right people?
A lot of, as I mentioned before a little bit, the brick manufacturers, they've, you know, over time go out of business, they get sold, products get deleted, clay sources run out. So we find that we need to go far and wide to create opportunities to be able to match buildings and create colors and sizes that maybe the local manufacturers are not around to do anymore. What we've actually done over the last few years is we brought a lot of European brick in, which you know is quite expensive relative to the brick you can get in North America, but they do some innovative creations with sizes and colors and textures. A lot of linear products. I know we've been able to supply quite a number of these jobs here in the Northeast with some of the architectural firms we've worked with. One of them was the job that Ferro is doing with us over at Princeton University using their system. But in order to give architects the ability to create, you still and want to come up with new and innovative ideas of length, size, heights, textures, that are a little bit different, and of course special shapes, which because of the manufacturing advancements over the years, we have the ability to create these shapes that really we didn't have the technology to do years back. And with a lot of the computer enhancements and 3D enhancements, the brick manufacturers that we're able to work with and partner with are able to perform a lot of these different aspects of color and size and texture. So it's challenging, but we're very happy to be part of it, to be able to allow an architect more abilities to grow and design their buildings with enhancements of color and size and texture.
Awesome. And Ted, since KPF is also leading in sustainability, can you maybe a little bit elaborate on the kind of balance that brick has to play, right? Because it's energy rich, but there are also new kind of brick solutions. I'm curious about it.
Right. So we're always trying to be cognizant of the fact, and the new changes in the energy codes have obviously moved the way buildings are being designed, right? We're moving away from the glass buildings more to the mass walls, smaller window wall ratios, and brick is one of those kind of very rich materials. And when you're doing like a project like 64 University Place, which is a residential building, it just kind of feels like the right move. And you work with, the facade consultants and everything about how to be energy compliant and all that. It is an ongoing process. There's not a one-shot answer. It's ever changing. It's ever evolving as the products get better. Like Andrea said, the old lintel, the old design that I even knew, that was very energy inefficient. And then they just developed this offset angle that allows you to run the continuous insulation to meet the energy codes. So it's constantly this constant conversation, constant pushing each other to develop and to come up with a system that will meet these new energy codes and provide the design that the clients want, that we want. So it's constantly evolving.
Mm-hmm, mm-hmm. And Andrea, what could you tell people about how to actually innovate? Is that something that needs to be self-motivated, or how do you guys do that in your firm?
That's a great question. And I was speaking about this earlier today. I think we've assembled a world-class team, but that starts from the top. So we have to give them exposure as much as possible directly to the end users, directly to the designers. We have to make it part of their job that they have the time and space and incentive to innovate. So we really challenge them to take on any sort of problem, and if we don't have a solution, come up with one. And we really make sure that they've got that time, to be creative in the engineering field, which is really important. Mm-hmm. Thank you for that. Great.
Awesome. Now I just want to see if there's some urgent questions in the audience. I do have more questions, so this is your one and only chance. Okay, awesome. Back there, please. Mm-hmm. Coming, your microphone is coming. Mm-hmm.
I have a question for Andrea and Ted about 64. The thermal bridge bracket, it's not thermal bridge, it's thermal bracket. Was there any concern about the point of contact being a thermal bridge, or was it just negligible in the overall scheme of things, given that continuous lintel, compared to a continuous lintel? Or was there like some sort of coating on the bracket to block the thermal bridging?
That's a great question. So there, with the bracket, yes, there is a point of contact. So with a conventional shelf angle, you'd have that linear, continuous point of contact for the entire length of the building. And so with using a thermal bracket, you are limiting that to usually about spaced every 4 feet. So it's just a function of how much brick load and height you're supporting. Now, in terms of a thermal brake pad, maybe applied as a shim, we've done a lot of thermal modeling, and the improvement with using any sort of pad or in a masonry veneer application is extremely limited. They are not structural, so it's in a masonry veneer facade, the best route to mitigate thermal bridging is by far and away a structural thermal break. So the modeling shows that if you add a thermal shim behind our bracket, you're only getting a negligible 1% to 2% additional improvement, which is really just a rounding error. That significant thermal performance is achieved by offsetting, taking away that thermal bridge from the building. We occasionally see a detail where people will put a thermal shim behind a conventional shelf angle, and that does offer some improvement. It's a dissimilar material approach to mitigating thermal bridging. It's roughly in the order of about 30%. And because those pads are not structural, you're not really meaningfully reducing the size of that conventional shelf angle that you're attaching onto it. So you've still got big, thick, heavy shelf angle with multiple penetrations that's increasing that heat flow. So thank you. That's a great question.
Awesome. I get a 4-minute warning, so one more question from the audience, if there's one. Yep, over there, please.
Can you comment on the pros and cons of the thin brick systems that are out there?
I think that's a question to all of us. So I can actually say from our experience that first we start with full brick, then the client says, oh, it should not become full brick, and then we end up with full brick again somehow. I don't know why. Is that happening to you guys too? So why is that actually?
I think from our point of view, there's kind of like the weight and the feel of a full brick. There is concern sometimes with a thin brick that it starts to look like a wallpaper. It kind of doesn't have the same texture, doesn't have the same kind of like imperfections almost in a way that a handset brick system gets laid. And sometimes just it doesn't really fit the project. If you're trying to get some depth, if you're trying to get some corners, it might not work. It has its places, and sometimes it's more in a VE type effort. I mean, we don't start with a thin set brick like Mattia said, but it just doesn't seem to have the same gravitas as the full brick, at least from our point of view.
We would agree with that. For years, we've always gone with full bed, and I would say over the last maybe 10 years, thereabouts, there's been a little bit more in the way of using precast. From our perspective, panels, panelization, different types of construction that can be done more for longer walls as opposed to maybe intricate design like on 64 University Place. But it is part of it. It is sometimes cost effective for longer walls where you just need these precast panels to be put up in a factory and transported and attached to the building. We've done it both ways. We do prefer, though, the full bed material when possible. Sometimes we've done split jobs where we've got full bed on a building, and let's say a parking garage is going to go with a precast to match and use. And we can offer that in a full bed and in a thin as well. So it varies.
Mm-hmm. Some additional secret knowledge?
No, not at all. For the same reasons, we obviously want to ensure that we're making these wall assemblies so efficient that they can bring that cost down to a thin brick level, while also achieving, the longevity and sustainability of a full bed brick.
Mm-hmm. Now I have one final question to each of you. What would be your most favorite commission next to come dealing with brick?
Ooh, you got the wrong guy. We should have our president on. I'm honestly not sure. There's so many ways you can use it in so many buildings. I guess maybe to go away from the more smaller scale buildings and start using it in a larger application, like we did the terracotta on One Vanderbilt, to maybe start moving towards something like that, where we start getting larger scale projects out of brick and not just below like academic or residential buildings. That would be an interesting way to go.
Because my answer would have been to get a commission that you guys had already for like such a complex, beautiful kind of brick application. Yeah. John?
So you're asking me what was our
What's your favorite? No. What's your favorite future project with brick?
Oh, future project.
Yeah. What commission you want to get?
Let's see. I would say something that has maybe an abundance of colors, abundance of sizes, different sizes. And the ability to supply something to the architects that are designing the building that have the creativity level that enhances what we can supply. I don't know if that's really the answer you're looking for, but...
this is perfect. I think we have a lot of architects here who can come your way to challenge you
yes,
about it.
We're very happy to support everybody in the room here. So dial us up, and we've been around forever. So a lot of buildings, look at our website, and a lot of collaboration with a lot of the architects that are at the show. So we're very happy.
Awesome. And very briefly, Andrea, we're over time.
My answer would have been the same as Ted's, but since he stole
Bigger
it...
is better.
Yeah, no, but I would say stadiums. We see brick used in healthcare and low-rise and all that kind of stuff, but, it seems like maybe cost is a factor, not so much in stadiums anymore. And I'd really love to see all the stadiums coming out across North America back in brick.
Amazing. So all the architects who design stadiums, talk to Andrea. Thanks, everyone. Awesome panel. Thank you so much, everyone.
Thank you.
Thank you.
Thank you, panelists. If I could ask you to stay on the stage, actually, for 1 minute, because it's picture time.
Hello. Welcome back, everybody. Oh, we got a little thin here. Uh-oh. I have some work to do. Yankees are 2-0. Hold on. I practiced this. ChatGPT. Tell me how to enliven crowd after a 7-hour conference on facades. You're in trouble. All right, guys. We are back. Did you miss me? Yes. I asked that already. This is our final plenary session where we're going to wrap up. Hopefully, incredible day of insights, innovation, collaboration. It sounds like out there that everybody's like really happy and awake and eating and talking. And then we come back in here and everyone's very quiet. So I'm going to make sure you guys ask some questions. We only have 2 more sessions. We have one incredible architectural keynote again. I'm calling them all keynotes. And then we have our final panel on affordable housing. So, Jason Long. He's close, I hope. He's a partner and director at OMA New York. Hello, Jason. I see him coming. U.S. branch of the world-renowned architectural firm OMA. With a diverse portfolio that spans cultural institutions, urban master plans, commercial developments, and public spaces. Jason is known for his innovative approach to architecture and urbanism. Welcome, Jason.
Aren't we all? Hi, thank you so much. Thanks so much for inviting me here today. I'm looking forward to sharing with you a couple of projects that we've either completed or are about to complete recently, both of which use precast or GFRC to create residential buildings that we hope, despite their different scale, relate to the neighborhood that they're sitting within. So the first is Eagle and West. This is a project at the northern end of Greenpoint, so the very north part of Brooklyn. It's a project that we did, of course, like every project that we all do, with a whole host of collaborators. Our clients here were Brookfield Properties and Park Tower Group, and we worked with Beyer Blinder Bell very closely as our partner architect, and they were, of course, instrumental to the success of this project, as well as Thornton Tomasetti, who are our facade engineer. The facade itself was fabricated by BPDL, together with Tivitec, Interpaint, and Pickler, who created the glass and the actual frame for the glazing. These are 2 towers that sit on the East River as part of an overall development called Greenpoint Landing on land that Park Tower Group owns. When we came into the project, there were already 3 towers by Handel Architects that were well underway or even completed. And we're the 2 towers that, of course, in the middle of this image. And of course, this is all part of a general transformation of the North Brooklyn waterfront, and specifically of the Greenpoint waterfront. A waterfront that had historically been an industrial area that stretched up along Newtown Creek and featured not only the fabrication for ropes and other things kind of in the early part of its existence, but later for even oil refining. That industrial waterfront sat at the edge of a fairly low-scale residential neighborhood dominated by 2- and 3-story, mainly townhouse units, typically made of wood, and unlike the brownstones of southern Brooklyn, clad with wood shingles and later aluminum shingles. So our 2 towers, we tried to conceive in a way that could locate 2 fairly tall towers, one 400 feet and one 300 feet, onto the same block while having them work together as a set of fraternal twins. So almost like they were broken out of a single piece, but yet each different, so that they could be complementary, but yet distinct. That strategy allowed us to make them also adapt to the situations they were in. So the shorter tower at 300 feet has a series of terraces, while the taller tower steps back to create a dynamic face that actually faces the neighborhood rather than away from the neighborhood towards the waterfront. The sculpting of the building also, we hoped, would break it down into a set of 8- or 7-story volumes that could perhaps better relate to the lower scale of the neighborhood, both the kind of remnants of the industrial waterfront directly adjacent to it, but also to, again, those townhouses that were even beyond. So that as you approach the building, it has a scale that, of course, is different than the neighborhood behind it, but is also related to it. And we wanted the facade of the building to also give us a strategy to enhance that sense of division and breakdown as you move up the tower. So we looked again to the townhouses that were there and to this idea of shingling, something that we thought could maybe be reinterpreted on the face of these buildings into something that would give them a texture, a solidity, but also a differentiation. So we took this idea of shingling and kind of twisted it around a little bit, turning it into shingles that could be either horizontal, as typically you see, but also vertical or even diagonal, and that different shaping could be deployed across the tower to, again, subtly break down its scale and create some sense of also detail and texture across this residential building. So we decided that we could almost kind of reasonably do that with precast. We were interested in using precast also because of its own inherent sense of cementitious solidity, which we thought would also meld better with the industrial neighborhood, and would give us the kind of subtle play to be able to form it to create these shingles. So typically what we found out was that we only had about 2 inches of play within the precast, so kind of 7 inches to accommodate the rebar that's within the precast itself, and then 2 inches extra that we could use to shape it without adding weight that might make the whole thing become suddenly unfeasible. And so within those 2 inches, we experimented with different scales of shingles in the office and finally settled on a set of panels that are all around a window on a 12-foot module around an 8-foot by 8-foot window, with, again, shingles that, again, have these different orientations from vertical to horizontal to diagonal. So we were worried a little bit that although we had this graphic, you could say, that would be on the facade, that that the 2 inches might not be enough to really register a difference and also register a difference throughout the day. So we built a mock-up and filmed it over the course of 24 hours in order to really test how it would also change, so that we would have differences not just between the different segments and the different orientations, but also difference across even an individual panel throughout the day. And it works. So their combination together, again, gives you a building that comes together as a whole, but at the same time has kind of clear differences between them. And as each section meets the next section, we also introduced a so-called beak, so a different horizontal articulation that could emphasize the division between these different blocks. So originally we wanted those beaks to be in aluminum, but that created construction sequencing issues that made cost a little bit of a problem. So we switched it actually to be also integral to the precast panels themselves. So the top of each of these blocks also has a different panel that accommodates this so-called beak. And you can see the effect of that here, where actually the beak steps out as the building cantilevers 24 feet out to the east. The combination of these different shingles, we wanted to create a kind of dynamic facade that could relate to the dynamism of the building's form, but at the same time create an overall composition and an overall impression that would come together as a holistic composition and a holistic whole. So making this facade, of course, was a kind of international endeavor, or became an international endeavor, where the glass itself was fabricated in Spain, then kind of combined into IGUs in Germany before finally being assembled into the frames in Italy. It was then sent to BPDL's fabrication plant. They were the ones that actually did the precasting in Quebec, where it was then glazed, and then the glazed panels were shipped to Kingston, New York for kind of lay-by, where we could do inspections, and then they were ultimately brought, of course, to Greenpoint. So here you see the wooden forms that were used to make the precast themselves in panels themselves in the BPDL's plant. And then each of these were then cast in place. You can reuse each of these wooden forms a certain number of times, but ultimately have to redo them. So that kind of set a certain limits on how many different panel types we could have, but also meant that having multiple panel types wasn't really that much of a problem, because these panels don't just last forever. So after casting the precast, as I mentioned, they were pre-glazed, and then into mega panels. So each typical panel is actually 24 feet wide, which is about the limit of transportability. So combining two windows with a false joint between them so that the basic grid of a kind of 12-foot panel could be read across the facade. Then these were shipped to Kingston, where we went in the height of COVID to try to inspect the panels and make sure everything came out all right. As I mentioned, there's a number of different panel types just by virtue of the nature, the design itself and the variation between horizontals, verticals, and diagonals. There are also special conditions to capture that beak moment. So at the top, so for example, between between yellow and green, for example, is the one panel type, and then the same panel type with the beak above. And then, of course, there are corner conditions. But in general, the panels are relatively repetitive across the facade. All of them captured within this 24-foot wide mega panel that stretches from slab to slab and is supported off a set of gravity and shear connections that are anchored to the concrete slab of the building. One of the big issues that comes up often when you're discussing precast is how you will actually get the panels onto the building. You need to use the crane for the most part, and how you will do that without disrupting or creating issues with the overall schedule and the pouring of concrete for the actual structure of the building itself, not to mention all the other things the crane has to do. In our case, a lot of the picks actually happened at night, and then some were kind of erected with alternative methods, but this didn't really affect the schedule in any kind of adverse way. And here you see, of course, them bringing up the one of these mega panels onto the facade and hoisting in place, all happening in the evening. There are also, given the building's form, certain special conditions that are slightly problematic, where we have overhangs. As I mentioned, on the east side of the taller tower, there's a set of 24-foot cantilevers. And as you get closer and closer to those cantilevers, of course, it's not possible to get the panel in place with the crane itself. And so in that case, they're craned into position and then hoisted up from points that are on the cantilever itself. And then simply placed as they were. So of course this happened kind of at the end of the whole construction process. Each of these overhangs was then clad with aluminum paneling, which integrated a series of tracks, which will also allow for maintenance of these facade areas that aren't necessarily accessible from the typical kind of davits and baskets. So the basket actually gets lowered down, and the facade maintenance people hook onto the track and then pull themselves over. In any case, we engineered the windows such that you can release a safety, swing the window out, and then actually clean from the inside as you're turning over units. So they're not typically using these this facade maintenance. This is just for breakage and other issues like that. But overall, it's somewhat dramatic. We also wanted the building itself to be to meet the neighborhood, not just in the way that we divided it vertically, but also in the way that it met the street frontage. Greenpoint has some very long blocks, especially between, say, Manhattan and Franklin. But even our own block, given that it was going to be developed as one single whole, we wanted to try to modulate in a way that could create some relief along the whole street wall. And of course, looking at the neighborhood, there were moments where bay windows create effectively notches in the street wall as well. And we thought that notching strategy could create an effective way of also going from a overall monolith to something that could be a bit more subtle in its articulation, and also to help emphasize the location and of lobbies as well as the form of the towers above. And to emphasize those so-called notches, we also wanted to then utilize the facade itself and to do that as well. Similar to the example you see here, we have kind of moments of shingle, but maybe also moments that could be slightly more complex. Here, combining vertical and horizontal, but in our case, combining even diagonal, vertical, and horizontal interwoven into a single form. So as you see here, so that these special moments actually are slightly more three-dimensional in the sense that they combine all the different graphic strategies that articulate the main components of the rest of the building. And that those are in the same material as the rest of the facade, but as you get closer to them, they articulate a kind of special condition, either the side of a building or the moment of entry. So the windows themselves are also, of course, quite important. We wanted the building to have a solid reading, as I mentioned, but we utilized an 8-foot by 8-foot window as a module that could be fabricated, of course, but also one that could both work within a one-bedroom apartment or within a bedroom. So we tested in the office a bed and a window, and didn't want that window to overwhelm a single room, but also wanted to have a big enough opening so that we could take advantage, of course, of the views out to Manhattan across the river that are one of the things that makes this site quite special. And then in other areas of the building, the same modulation is used for amenity spaces, but can become things like a window seat, for example, in a double height common area. The two towers are also connected together by a bridge that houses fitness areas, so a pool and also a gym. You see that here where it says indoor lap pool. That bridge is a literal bridge that contains a very large truss that allows for the terrace space to actually flow underneath it. And we looked at different options for how to articulate that portion of the building to either express that structure onto it, or to treat it as something more subtle, and ultimately decided that the best strategy was to use curtain wall to create real contrast between this exceptional moment of the building and the rest of the facade, which you see here. So as you're sitting on the terrace, the skyline and the sunset's actually even reflected into that facade, while within it, of course, you have this kind of vista of the Manhattan skyline. And similarly, we wanted the entry to the lobby within the taller tower to also be clear. So here again, we used the curtain wall to try to bring you in under the end of that bridge and provide a kind of view back out to the rest of the neighborhood and the waterfront. And altogether, we think that the building hopefully is a kind of dramatic focal point on the skyline, but also not such a bad place to live. So the second project I want to show is a little bit different than the first. Similar in that it has a facade strategy that involves precast, but in this case, GFRC. It's also different in its scale and its location. The first project I showed has 745 units, 30% of which are affordable. This project at 730 Stanton in the Haight-Ashbury neighborhood of San Francisco has 160 units, all of which are affordable. And this is really geared towards families. So the first project had 25% 2 and 3 bedrooms, mostly twos in that 25%, whereas 730 Stanton is for families and actually has half of the units as 2 and 3 bedrooms, roughly split within that 50%. So here we worked with 2 nonprofit developers, TNDC and CCDC, as well as the Mayor's Office of Housing and Community Development, and our local partner, YA Studio. And for the facade, we worked with Clark Pacific, who did the GFRC, as well as Vitro for the glass and Connier for the actual frame systems. This project sits at the end of Haight Street, at the gateway to Golden Gate Park, on the kind of somewhat western side, you could say, of San Francisco. It's a site that held a kind of notorious, or housed a notorious McDonald's for many, many years. I lived not far from here back in the 90s, and this McDonald's, well, like many McDonald's maybe you can encounter in Manhattan, it was not the best place to be. But in any case, the city bought the land and then was going to use it for this affordable housing project at a time when zoning had been changed to allow for up to 8 stories of affordable housing in a neighborhood that, as you can see here, is predominantly 3 or maybe 4 stories and dominated again by a series of townhouses. The neighborhood is Haight-Ashbury, which maybe you know from its place within the counterculture of the 60s. It's also known for the kind of richness of detail and the bay windows of the townhouses that make it up, as well as many other parts of San Francisco, but also for a colorful and dynamic retail presence along Haight Street especially, terminating in Amoeba Music, which is in the former bowling alley, and then in our direct neighbor to the east. So here you see this site plan with the site at the end of Haight Street, between Haight and Waller Street running along Stanton. So Stanton's a much wider street that faces the park, whereas Haight is a more commercial avenue and Waller is a much smaller scale residential street. Bringing an 8-story building into this fabric was something that was controversial, generally supported, you could say, in the idea of affordable housing, but the scale of the building was something that many in the community had concerns about, and we wanted, of course, the building to touch down in a way that could be sensitive to that. And so we started with the idea of 2 4-story volumes that could run along each of the side streets, with the 8-story portion running parallel to Stanyan Street, the wider street facing the park. And then this bar of 8 stories, we manipulated or formed to create a series of courtyards, 1 facing west and 2 facing east, and together with a series of terraces on the 4-story volumes as well. And this shifting back and forth of this bar also creates additional corners for the building, which we thought was critical for the success of these family units that we would create, because given the, of course, efficiency of an affordable 3-bedroom unit, you really need a corner to make it successful as a living area, because the corner gives you a way to organize the unit and allow people to occupy that living area that can be more pleasant, simply. And to also give those family units more prominent views of the park and the rest of the city. This shifting back and forth, we also shaped into a series of scoops to create an organic language for the building that would be a bit softer, but also relate to the park space itself. Creating an overall form that we hoped would be playful and welcoming, but also relate to the neighborhood around it. So when viewed from the park, you have a kind of prominent terrace at one of those scoops at the 4th level that looks out into the park and shared as a common space directly adjacent to a laundry room. And then from Haight Street, there's a part of the building actually steps out and cantilevers to make a dramatic terminus for Haight. Whereas on Waller, that upper volume actually steps back to help mediate the relationship with the neighborhood. And at the end of the building, we actually even have a little mini scoop that helps it meet the neighbor that's set back to create a stoop. So this, along Stanyan Street facing the park, there's a lobby and entry moment that's just off of this most prominent scoop that's the welcoming garden. And then within the building, the way that the upper volume is formed brings in landscape areas really tightly around public areas of the building. So here you're walking down the corridor from the main lobby to the elevators, framed on both sides by these open spaces that are on the west and the east sides of the building, bringing in light but also kind of green into the life of the residents. So here, as in the previous project, we wanted to draw upon the surrounding context as a kind of inspiration for what the facade could be. But rather than creating a texture here, we wanted it to be a bit more of a plastic form across the building. So, of course, we looked to the bay windows and their modulation within the typical San Francisco street frontage, but we didn't want to make literal bay windows. And we also didn't want to ignore the diversity that you see in the kind of scale of openings and also the articulation of these townhouses. And so we had the idea of making a series of waves, so utilizing a 10-foot module that's similar to the bay window module, and then sculpting the building vertically to make these kind of shallower waves that could be a texture across the building's form. And we thought that texturing of the building or the waves themselves could vary in scale, and that variation could also help emphasize the difference between the taller portion of the building and the lower portion of the building. So creating large waves, medium waves, and small waves to give us another ingredient to help really articulate the building's form and the way that it met the city. That shaping of the waves also gave us a way to deal with the inherent complexity of trying to do a curved facade, so that in these moments of curving, like at the kind of main entry courtyard, we could make a facade that was essentially faceted, but whose faceting wouldn't undermine the ambition of having the curve in place. So you essentially, while each of these panels, which is in this case are on a 5-foot module, can have a backside that meets a slab that has a straight edge, the front face has a curve that makes it not really noticeable, you could say, as a strategy for dealing with the shape. So here you can see the kind of parapet that's faceted, and then the 1 inch of GFRC on the metal backing frame that holds the wave itself. And we thought that this strategy really could make also a building that, as you look at it obliquely, could have a very different feeling than when you're looking at it in elevation. So that essential strategy also we developed over time to create something that in the lower volume could vary in its dimension, creating something that would be a bit more dynamic and kind of responding to a lot of comments from the community, but also giving us a way to incorporate different aspects of the facade. So different scales of window, but also accommodating even the mechanical systems, as I'll show in just a second. So this is the kind of final set of types. So at the upper parts of the building, there are actually very large moments of wave, so to speak, that stretch about 30 feet, and then smaller medium modules, the 5-foot moments of radius, and then the diversity of panel sizes along the base of the building. So the smallest scale panels actually gave us a place to locate the intake and exhaust for each of the units. So there's an individual ERV system for each one of these units that requires intake and exhaust to be placed in a way that could be appropriately separated. And we wanted to do that in a way that would feel deliberate across the facade and not just end up where it needed to end up in the overall planning of the building. And so in each case, sometimes even 2 units are combined into a single louver that runs within these smaller waves that sit between the actual glazed waves on either side of them. And together, this kind of larger, medium, and small modules that run along the base of the building also create a sense of scale that's actually quite closely related to the townhouse scale in the rest of the neighborhood. So GFRC, of course, differs from the precast, and we chose it because we wanted this dimension of the wave to have a slightly different impact than what we had done in Greenpoint. So here, there's typically a 9-inch return on each of the waves, which is something we really couldn't have done with precast. So here, there's a kind of 1 inch of the GFRC, then that's on a metal backing that also supports the glazing of the window within. And then those are sometimes assembled again into mega panels of up to 24 feet in length. Here you see on the left the kit of shapes, so all the different panels that were deployed, combining sometimes straight portions with curved portions in order to create these larger scale waves of the upper part of the building. And then we also use these same set of curves to create a kit of parts that could be deployed to create special conditions for corners of the building where 2 sides are meeting even sometimes at an angle so that we could avoid, again, having too many different panels. So these were also fabricated with metal formwork rather than wood. So in this case, reducing the number of different conditions was actually really a priority. Because this was San Francisco, that we had to do a lot of community outreach, or we were happy to do a lot of community outreach to a whole host of organizations and a set of different Zoom meetings throughout the whole course of the design process from beginning to end. One of the biggest issues that came up actually was the desire for color. I think people in the neighborhood had a certain kind of nostalgia for what they thought of Haight-Ashbury being and wanted it to be dynamic and colorful, which we of course supported in principle. But of course, when you look at the neighborhood itself, there are moments of color, but the typical residential fabric is not necessarily acid green. And we wanted to make sure our building also fit into that context as well. So one of the good things about GFRC or precast is that actually it can have a range of different colors. And of course, we had the window frames themselves. So we did a lot of tests of how that could come together. And had a final community meeting on site finally where we could actually show the different colors we were looking at and even get input directly by speaking to people, but also through kind of comments and post-its and voting on what people preferred. And thankfully, they preferred the same direction that we preferred, and we agreed with them that baby shit yellow is not so great. So in the end, we settled on this color palette, which drew upon the buildings of the neighborhood, but also even art references, really a kind of beige, whitish beige color for the top of the building and light blue for the bottom, accented with kind of more champagne color for the metal components of the window frames themselves. So that there would be also a differentiation between the lower part of the building and the upper part, and an articulation for the windows that would be special, but without making the whole building look like student housing. Again, here there was a slightly circuitous journey for the glass into the frames, making a stop in Canada for some bird-safe acid etching, and then finally making their way to Clark Pacific's facility far east of Los Angeles, where the glass was then again pre-glazed into these GFRC panels. So here you can see again them using steel formwork in order to do the panels themselves, where they spray in this 1 inch of GFRC, then back it with the metal backing, assemble it into their yard, glaze it, and then bring it to site. And then finally, with the crane, assemble it onto the building. And here you can see in these larger portions also the integration of these, the ERV exhaust and intake louvers. So here, the BIM model of the building of the assembly. Here showing a special condition of a corner window, which we tried to integrate into special moments where you might have a view ultimately of the park. Here you can have just a hint of the green that you can see through it. But really in this building you have spectacular views out over the park, and one of the nice things as it's come together is that the nonprofit developers are actually getting calls from people trying to figure out how they can buy a unit, even though it's actually just, it's all affordable housing for rent. I think that in the end, the difference in scale between these different waves, this larger waves at the top and the smaller waves at the bottom, help to really give it a sense of plasticity and also break down its scale as we'd intended, and while also responding to the scale of Golden Gate Park with, again, this main entry courtyard. And emphasizing this datum that you see here, this is the Stanton Park Hotel, our neighbor just to the south, which is at the same height, of course, as this 4-story lower volume of the building. Along Haight Street, there's, again, this portion that cantilevers out to make the terminus of Haight. While within the entry courtyard, here you're standing actually within the lobby, you'll get ultimately a view back out to Golden Gate Park, and where this crane is, you'll eventually have a tree. But having the courtyard also gave us a convenient place to put the crane in the first place. And again, we hope this building will be kind of integrated into the city around it, but also kind of an amazing place to be and to live, and it'll open in just a few months. Thank you very much.
Thank you, Jason. Okay, our next panel, I think we have to set up. Yes. Okay. I got to fill the time. What are we going to do? Does anybody have any questions? Nope. All right. Everybody still awake? I thought that was a great presentation, Jason. Thank you very much. It also ties quite well into our next panel. Brian Laughlin is a principal at Magnuson Architecture, and he will be moderating a panel on creative solutions for affordable housing. So that was a great tie-in. I'm sure Susan planned that quite eloquently. And we'll get set up here. I think we have a big panel. So if you guys had one thing that you would like to add to the 165th edition of Zak World of Façades, what would it be? Somebody. I'm gonna call. I know a lot of you. Okay, I'm gonna call on somebody. A built-in bar at the end. Oh, an open bar at the end. Do we have don't we?
Not today.
Oh, we don't. Oh, shit. What am I doing here? That was a trick. Thought there was. Anybody else? Music. Okay. This guy likes to party. I'm sorry, what's your name? Oh, back there. Okay. Simon. Simon likes to party. And your name? Joe. Great. Those are two very good ideas. Anything in terms of content? Oh, we're ready to go. No, I got to get this. I need to get you one thing, Susan, okay? Content. What are we missing? Cost per, are you a developer? Are you an owner? You're an architect. That's important. Cost per square foot. I like when architects ask that. It's good. It's good to get the architects involved in the pricing of a project. Okay. Well, maybe we can do a cost reconciliation or something like how architects and owners can work together to value engineer projects. No, that's not what you meant. Anybody else? And then we'll get right to our panel, because I'm sure you guys are ready to get out and get to the bar that doesn't exist here. Nobody else? Okay. Brian? Come on up.
So the bad news is there's no open bar. The good news is you have no place to go, so you can stay with us. So I'm Brian Laughlin, a principal at Magnuson Architecture and Planning, and I am joined to my right by Carla Swigarath, who is a partner at Studio Libeskin, Seroponis, thank you, with L&M Development, Dylan Baker Weechie? Rice. Right. Okay, sorry. With NYCHA, and then Rachel Ehrlich with Datner Architects. And we're going to talk to you today about creative design solutions to affordable housing, and we're going to focus primarily on facades. And we decided to do this as a little bit of a hybrid. If we all presented a whole bunch of projects, we realized that we'd probably be here till about 7 or 8. So we'll use a series of questions to kind of prompt through the projects that we have to share with you today. So our office, and I'll talk a little bit about our office, but a little bit more about some of the larger topics that we tend to focus on. The building behind me here is Casa Salina, and we just updated this slide with square footage and the TDC, so you have to do some of the math. But the facade on this building here, and then another building, we did a modular approach. We worked with Jersey Panel as a VE exercise. We originally had this designed as just a traditional brick building and shifted to a panel. So as to save costs and construction time. And then the second building here, which is still in pre-development, is also on another NYCHA campus. This one is Solon Park, which is on Morris Houses, also up in the Bronx. And this is an Equitone cladded system over a Dextall modular system. So the importance of facades, especially as it relates to affordable housing, from the perspective of our office, and I think you'll hear this as a theme that's iterated multiple times across the next 45 minutes or so, that we don't think, or we don't see design as being a luxury. We don't see places that instill a sense of pride and instill improve their neighborhood as we tried to achieve with both these buildings, and by making them not only focus on the needs of the residents within the building, but also have the building turn out so that it's facing the community around it. To look at a new affordable housing building in your neighborhood as beautiful and as improving your neighborhood as really important, and we rely very heavily on facade and facade design for that. So those are some of the themes that we will be teasing out, where this group will be very happy to jump into nuts and bolts too. But without further ado, I'll turn it over, and I'm going to hand you the clicker. Yes. Sarah, if you're our lone developer up here, we have one developer, one city agency representative, and 3 architects. I think we can hopefully present a balanced perspective, but not to put you on the spot. Can you talk a little bit using some of the projects that you brought with you? From a developer perspective, what are some of the criteria that go into facade design and material selection?
Yes, definitely. I wanted to say though, L&M, we're developer, builder, and property management. So I have the benefit of seeing projects through from the beginning through building, and then our communities being lived in and property managed. So I'm kind of coming from that perspective as well as the management part. So Baychester and Murphy, also all of the projects that I'll be showcasing are preservation jobs. So jobs that we've come in, NYCHA projects, PACT projects that we've come in, we preserve, and then our CNC property management team continues with the community. Baychester, which are the smaller buildings, a community here, and Murphy, which are the towers. Oops, I actually don't know how to go back now. There we go. In this community, it was all the buildings were cavity and masonry and needed FISP repairs throughout. So we conducted those, and we opted for a overcladding of Stowe EFIS, which worked well for this particular community. And really, the first thing we do when we go in is find out, ask the community what's best for them, what are their needs, and then we also think about it from a maintenance standpoint. So in the case of Baychester, it was a big open green space, and we really tried to tie in the overcladding, give the buildings the facelift with the site work as well. With the maintenance, you'll see a lot of horizontal and vertical control joints here, and then even some window ACs. So a lot of times we do try to panelize. So when we do have maintenance issues, we can quickly repair one panel at a time rather than having to recoat half an elevation. As well, in this case, we tend to coat the first floor masonry, which has a double advantage. One, it's easy to maintain, and then two, now with the DOB probes at all cavity buildings every 60 feet, we have our masonry still available. We're not going through the EFIS.
And we had talked previously about the involvement of residents in the decision-making process, which is something that NYCHA has become a really strong proponent of. Can you talk a little bit about how that affected the outcome of this project and some of the exterior facade decisions that were made?
Absolutely. So actually, I'll use Baychester again. When we come in for preservation, there's a whole lot of goodies going on. We do mechanical upgrades, elevator reconfigurations, new roofs, new windows, basketball courts. And I think that the facelift on the outside really is a face forward to uplifting the community. And people, it really is true, they just start thinking and acting different about the same buildings that they just lived like generations through. And you really see it. But again, I'm a little biased because property management also really plays a role in that. And the maintenance, I really focus on easy maintenance of our overcladding because I'm the one who has to help maintain it. So.
Okay. And I don't know, I almost hesitate to tease this concept because but I do feel like it's something that we're all going to end up talking about at some point or another this afternoon. It's not just cost, right? For L&M and for this particular development, when you're looking at what sort of facades to select for an affordable housing project, that you're not just looking at the cost of the product, which I think is kind of a myth around affordable housing, that we're only driven by the cost.
So I think it's a myth that cost isn't an issue for every project, right? Because every project has its costs. I might feel like ours is a bit finite and set in place. We have to work towards it. And depending on what type of overcladding system or roofing system I use, that means the community center doesn't get as much there, or the basketball court is a half court and not a full court. So we definitely all work together. We're always balancing the scope with the different consultants to make sure that we are meeting the community's needs for what they asked for, if it's the community garden. And, you know, the facelift that I'm talking about, we're in a room full of designers, so rain screen, metal overcladding versus EFIS. Whew, it's a dirty word, but if it allows to get that facelift while also getting all those other goodies that we need in these communities, I'm for it. I think when it comes to overcladding, for me, EFIS with the rasping is a bit, or it's a little bit disruptive, and it's somewhat seasonal. I am pushing, I'm always for the advocating for our residents, so I would like to work more with prefabricated panelization. So it's in the factory. It doesn't matter what guys are on that rig. It's going in correctly. It's going in quickly, and we have the whole year to put it in.
And that was another thing that I think is important to point out about both these projects is that they were tenant in place. Everyone was home.
Yes, that's a major part of these preservation projects. And it's I don't know if anybody else would be surprised, but these preservation projects with tenants in place actually end up being more expensive than new construction. But maybe you have seen in the news with the Chelsea protests, these are people's homes, and the roof over their heads are, that's sacred. And no matter how many promises you make, showing like a nice new building and a rendering, and people think that they want that, the fear of moving out and, you know, trusting those promises, it's a hard thing. So we spend the extra money to preserve in place, but it's upheaval. You know, you're coming in as a new developer. You're coming in, they don't know you, the communities, and with lots of dust, lots of noise, and lots of upheaval. But at the end of the day, residents say, thank you. We're so happy that you've come here.
Great. So if I could turn to Rachel, and give you the magic wand. Rachel, you're with Datner Architects, and you guys are at the forefront of really pushing on sustainability and improving all of our vocabularies when it comes to sustainability and affordable housing. And part of that, I think, definitely sort of manifests itself in the way that we look at facades now as being high-performing envelopes as opposed to just cladding. Can you talk a little bit about your office and the project that is up on the screen behind you?
Yeah, sure, Brian. So this is Santa Ea Gardens. This is a project in the Soundview section of the Bronx, and this facade has to work so hard. It's more than just representing, for instance, the colors of one of the clients. Acacia Network is an organization that has its roots in the Puerto Rican diaspora, and they wanted to have color on the facade. Now, those of you who've had a client that said, make it colorful, you know, like Jason said, that's a challenge. But in this case, we have to do so much more than give the building a skin. We have to block the noise coming from this elevated train that you see here. This was a passive house project, so it had to be a high performance envelope. And in delivering this hardworking facade, we are advancing environmental justice for the communities where we do work, because these are Bronx residents who are exposed to high levels of air pollution, to noise. You can't see it in this view, but just behind where this photo is taken is the culvert for the Bronx River Parkway. So there's soot, there's noise, there's all kinds of environmental degradation. And the brief here was to create a building that expressed the client's, you know, desires to show their brand and their heritage, but also worked really hard for the residents to address some of these inequities that we see in disadvantaged communities in the Bronx. So this is a 249 apartment building. It has various community facility and healthcare program in the ground floor. It's 14 stories, and it was designed through a ULURP, went through a ULURP process to upzone the site. Here's a few more photos. So in the top left, you can see the proximity to the elevated train is very real. This is really right outside people's bedroom windows. We had a little oasis of a roof garden at the setback floor, you can see in the lower left. And we also needed to bring this tall building down to the street in a gracious way that made it a good neighbor in this Bronx community. So this, as I mentioned, this is a passive house project. It's also what we call a block and plank project. For those of you that know how affordable housing is so often constructed in New York City, this is the sort of tried and true method to put together a low-cost building that uses widely available materials that contractors can source through, various subs. So, of course, a block and plank building means that the building structure is its skin. And so the challenge of making a passive house envelope out of the bones of the building, right, the structures on the outside, was that we needed to use readily available materials and systems that are common, that are non-proprietary, that are available to, multiple subs, and get this facade to perform in a really high-tech way. So the floors are a precast plank. The backup wall is CMU block, and it's clad with a combination of brick and metal panel. It has 4 inches of mineral wool and a 5-inch cavity. And we thought about this really deep cavity, this 5-inch deep cavity, and how we were going to separate the skin from the structure and inject design elements that were like, say, VE proof, so you couldn't take them out of the project. So we worked with the builder, Monadnock. You can see on the left side there's a mock-up in their shop of how we were going to use this deep cavity as a kind of a design feature. We worked with Monadnock to detail jamb, sill, and head enclosures in a way that would eliminate thermal bridging. You can see in the center photo is an on-site mock-up with a kind of jumble of different panel colors because it was what was available for the mock-up wall. But you can see that we are using this deep 9-inch space from the face of the block to the face of brick. You can see that even more clearly in the photo on the right, where you see those gray recessed. You see the air barrier is liquid applied membrane on the backup wall. We decided to make that where we use the color that was requested by the client. So this is a construction photo that shows a combination of painted ledgers, 9-inch deep ledgers at the windows to close that cavity at the head, clips that are ferro brackets that offset the brick angle at the pier. And then we needed to wrap the windows. You can see in the detail on the right. Let's see if I can spotlight here. This is not spotlighting. Well, in any case, we had the brief was to use these really basic materials. So you see a plastic thermal shim shaded or hatched in blue. This is a window jamb detail, by the way. You see the green is a piece of sheet metal that was attached by the mason to create a kind of a clip or a standoff. Then the insulation went on top of that. And when the metal panel installer came along, they attached to this piece of sheet metal, this L-shaped piece. They have these 2 orange brackets that you can see attached to it, and they use that to mount this jamb enclosure. And then we used a plain old brake metal sill to close the cavity at the bottom of the window. So we have a painted steel ledger at the top, a route and return metal panel detail at the jambs, and a brake metal sill. I think I broke it. Sorry, guys. You're just going to have to stay on this slide.
We're just talking about this detail
Someone that can help
a
me
lot.
troubleshoot the clicker?
Oh, there you go.
I was
It
about
just
to
moved.
stand at the lectern there.
It's back.
Okay, great. So here, this is a view from the sidewalk that shows a little bit of the effect of using that deep cavity that we use to separate the skin from the structure as a design feature. And again, these are basic materials that stretch our budget, so we can get the most bang for our buck for every dollar counts in affordable housing. And we came up working closely with the builder with a system of, pieces from different materials that together could create these deep, colorful reveals. So here's a view from the train and a final view of the playroom that ties the colors together. The reason that we went to Passive House on this project is because we already had what's called an environmental or E designation on the site, which meant we couldn't have openings in the facade that would let noise through because of the train and the parkway. So we had to go to split system BRFs, no grills for ventilation. We had to have high performance windows to block sound. And that got us most of the way there to a Passive House envelope. And so it was just an incremental upgrade to then take this envelope to the next level of performance. So that's Santea Gardens in a nutshell.
Amazing. Thank you. Dylan. So NYCHA with, I think, a capital needs assessment that was all over various newspapers a couple of years ago with a price tag of $80 billion.
Yeah, sticker shock, yes.
Yeah, a bit of sticker shock. You guys are now undergoing probably what's the single largest modernization project in the history of New York. Can you talk a little bit about what some of the criteria are involved when you're deciding which projects to tackle and which projects to push off for another couple of weeks?
Yeah. So I put this slide together, or we have this as a general informational slide. So we like to think of ourselves as sort of a city within a city. So we have about 172,000 units that we oversee in various models. And so that's spread across the 5 boroughs. We have around, do I have it here? No. Basically 1 in every 15 New Yorkers. So at any one point, close to 600,000 people are living within NYCHA buildings, so within public housing in New York. And of course, those houses were built from the 1930s really up into the 70s. There were some other ones that were acquired or built in the 80s. So most of them are getting quite old. So there's no one-size-fits-all model. So we're looking at many diverse ways to deal with the project types. So of course, most of the buildings that we're known for are the tall brick buildings, the sort of leftovers of modernism, the towers in the park in New York. Facades are one of our really big costs. Facades are constantly degrading because of local law requirements, local law 11. We need to focus on making repairs. So as much as possible, some of the other projects that we saw here, we're interested in addressing those needs comprehensively. And that really means like what we call either a comprehensive modernization, or the PACT program is another program where we're it's a public-private partnership. We're looking for public-private partnerships, public-public partnerships with what we have now is called the Preservation Trust, or we're overseeing the work ourselves with a stable of consultants or in-house work. So in terms of how we choose or decide, I'd say it's needs-based. So it's both the age of the building. We do a physical needs assessment where we look at the rate of deterioration of both the infrastructure and the facade. And those that are bigger and have more need generally get prioritized as first. But myriad choices, and I couldn't say there's one easy way that we choose, which is which. And then, so this is a good slide maybe to talk about that. We have kind of a suite. So let's see, your left is the basic where we're doing more capital work that's intensive, which is mostly we're dealing with existing brick or cavity wall construction, masonry construction. We want to retrofit that, make that good as much as possible. We're interested in novel technologies. We're not thought of as maybe a technology leader, but given our need, we have to come up with many different solutions. So whether it's interior cladding that goes on to improve the energy requirements, we're replacing windows, we're adding active ventilation. There's a number of measures that we do that don't overclad the building. The next step is we're looking at overcladding. Then it becomes progressively more comprehensive, alternative energy systems, much more active ventilation. I think I have later slides that talk about we're moving towards more distributed systems. So that means moving what used to be centralized mechanical systems that dealt with a campus into the buildings and into the facades. So heat pumps, that's a big focus on ours. And so moving towards this end, that's the kind of vision where we're doing, where funding allows and we can unlock additional funding, we're doing everything. And we'd love to get to passive house. That's kind of a goal. But we're steps along the way, and that depends on individual sites as we can do more. I have this slide. I'm kind of jumping the gun here, but a lot of the drivers for us is not only cost, but also community. So what's really important to us is that we come with the needs. We think about which buildings we should start with, but that the residents are participants. We talked about it before. You mentioned that for Baychester, the residents were really involved in that. And the idea is that if someone lives there, it's their home. So of course, like if you're hiring an architect or designer, you want to have a say with how it looks. The residents want to have a say with how it looks. And that helps tremendously, both in terms of the overall vision, but in terms of residents feeling like they're part of the process. And so that means flags that would come up for them, as long as they feel that they're engaged and they're involved early on, those are much less of an issue during the construction phase if they have their say early on. What happens, or we get a lot of pushback, is when issues weren't discussed up front. We're late in the construction phase, and people are only realizing the impact that it's going to be to their indoor air quality or noise, or they won't have access to this part of the campus. So that's one of the reasons why we always try to put residents first. And that's been a big pivot for us in terms of changing our engagement process. So it's now required for any projects we do, but also for any of our consultants. So this slide gives a little bit of idea of scale that we're working at. These are 2 sites. Actually, I think I have here. These are 4 sites that we're looking at various types of comprehensive modernization. So it gives you an idea at scale where we're working at the full development. We're either looking at overcladding or recladding, dealing with particular problems with the masonry, but because we're working at scale and we're also getting into the units, that allows us to accomplish a lot more than if we were to do one by one. So the building model one by one. So St. Nicholas is in Manhattan, up in Harlem. Toad Hill is in Staten Island. So both different, they're both campuses. The campus is easier for us as an owner because unlike most New York City buildings that are, covered on most sides, where you have to set the staging in the street, we have this open space on the campus that makes the staging a little bit easier, but it's still disruptive to residents. So we want to make it quick and as efficient as possible. But these are various scales, and these are the projects that are underway in Kiwanis as well.
Okay, if we could turn attention to you and what is yet another NYCHA project. Your office, Studio Libiskin, was part of the team that was awarded the senior building on Sumner Houses. And I think it was actually during some of those press conversations when you were first awarded, but it was repeated when they just did a ribbon cutting a couple of weeks ago, that your studio said that part of the importance and part of the driver of the design of the facade of this building, the overall approach to the building, was that it was so that people in the community, both at Sumner Houses and in the surrounding neighborhood, would have something beautiful to look at. Can you talk about how important that was for you guys when designing this building?
Yeah, absolutely. Thanks, Brian. I think from the very beginning, we said beauty shouldn't be a luxury, right? It should be really great design, should be in all sectors. And having had a lot of experience around the world designing museums and luxury towers and commercial buildings, university buildings, as you said, every project, has a tight budget and every project has its constraints. And so I think we were really eager to work in the affordable housing sector to really kind of make a statement that design doesn't have to be more expensive, number one. You could be creative. It's not about the budget necessarily, but about the amplitude of your vision, right? But I think also to just try to innovate in this incredibly, critical sector that, there's such a huge need. So how do we do it better, and how can we think more creatively about the solutions rather than just, being daunted by the problem? So I think you can see the project here. It actually was a pilot project with NYCHA, which was part of the NYCHA Next Gen kind of experiments, I'll call it, where they had public-private kind of partnership with NYCHA, and it was a competition. So we teamed with Urban Builders Collaborative, which is also part of Latier Construction, Self-Help, which runs senior facilities, and Riseborough, which is a community development agency. And we entered this competition. It's at Sumner Houses in Bed-Stuy. And they basically take the Towers in a Park scheme and kind of cordon off a site for a new project kind of within an existing NYCHA campus. Here you can see the completed project, which opened in May. And there you can see kind of the diagram to the top right where you see the towers in the park of the current Sumner Houses, and then our project there kind of on Marcus Garvey Boulevard there. We had to kind of respond to the context, create something kind of bold, sculptural, and we really wanted it to be abstract, but stand out, right? To be, make people think and see something different and maybe inspired in the neighborhood. Probably one of the most innovative things besides the design of the shape of the building is really the atrium at the center. So many affordable housing projects have to be as efficient as possible, right, for the need to try to provide the maximum number of units. But we also tried to push against this idea of just double-loaded corridors all the time. And how do we really create a community? Because this was for seniors only. And how do we try to create a place that's fostering a kind of community for them and a sense of belonging and a sense of home and place for them. So the atrium is really what all the units are kind of designed around, and then the skylight at the top, so it's useful all seasons. There you can see the plans. I think this is very helpful to understand, talking so much about budget and design. And, all of these small units is quite a challenge in any project. And how can we kind of create that dynamic shape, but still keep as much regularity and make kind of minimal moves with a maximum impact around the atrium. So the ground floor actually has public programming as well. It has a PACE center. So it's kind of a medical facility, not only for the residents, but for the community at large. And then, of course, resident facilities at the grade as well with the community room. And then you see the green there on the second floor. That's the atrium level. So it's kind of raised up, safe, secure within the building for the seniors to really have as a sense of place. There's a few more images. You could see we did tried to create a project that really focused on active design for the residents, encouraging the use of the stair cores with light in it. We kind of colored each floor to give a sense of identity to each level of the units. And then they all look out onto that atrium space. So you could see your neighbor across the way, or there's always this sense of activation. Even if you might be a senior living alone, you're really always kind of seeing the dynamism and, the activity within the community. And then there's even, landscaping at the atrium. And there's even a program where some of the residents help to take care of the landscaping on the site. And then there's a unit.
So I'm going to ask you a question, but I kind of open it up to everybody. One of the things that I have always really liked about, I feel like I've had a privileged front row seat to early days of this and how it's evolved. But one of the things that's always struck me about this particular project is that the facade does not stop at the exterior of the building. That you see even in that last shot of the interior of a unit, the facade resonates. There's some reminder of how the facade is working, and it carries all the way through. So I would kind of put that to the larger group. Here, I think it's a little bit more formal in community engagement, like some of the trade-offs that we have to make, especially when doing adaptive reuse. What you do on the facade impacts whether or not you get a basketball court, and Rachel, you were talking about the depth of your facade and how that depth was incredibly important. So I open up to all of you to talk about where you see the facade stopping and where the building starts, or some alternate, I guess, which is these things are very much entrenched in one another.
I mean, in the case of Santea Gardens, the facade was really like a protective skin, right? You're keeping out noise and pollution. You are creating a building that is resilient. So if the power goes out, people can shelter in place because it's going to stay, insulated. And so how do you create this high performance shell without it looking like a bunker, right? You still want it to be a good neighbor. You want to contribute to the neighborhood. You want to extend the fabric of the neighborhood into what was formerly a weedy, underutilized lot. So in this case, there was the specific request to showcase these colorful, panels as a reference to in this case, it was the doors of Old San Juan in Puerto Rico, right? It was this kind of literal reference to have these colorful panels. But, the drive to efficiency for the double-loaded corridor, right, to maximize unit count is inescapable when you're doing an affordable housing project with HPD in this case, and with clients that are looking to address the housing crisis. So for me, the trick is to how do you have this facade that is both creating an oasis inside and also being a good neighbor and saying something to the neighborhood that this is a community that is worth investing in, that people want to live in, that we want to enhance, we want to improve. It's a tricky balance, and so carving in the case of this project that I presented into the facade to create these sort of deep reveals was one way to kind of literally dematerialize that thick shell a little bit. As I mentioned, we brought some of the colorful, playful colors to the interior. It also continues in the corridors where we have, colorful painted doors and bright yellow mosaic tile at the elevator, typical elevator lobbies. So this idea of color being key to the experience there was, inside and outside of the building. But ultimately, the fact that the people that live there have healthy interiors, they have total control of their interior environment, and they have a building with amenities that make them feel like, they've arrived in a comfortable, gracious, welcoming building. I think we achieved all those goals with this project. And then that being our first block and plank passive house project, kind of used it as an R&D opportunity to improve our passive house detailing in future affordable housing projects.
Yeah, was that before or after was it 425?
So Santea Gardens actually went ahead first and was completed first.
Interesting.
Our claim to fame, yeah.
Maybe just to add to that, I think for us, whether it's a rehab or a new build, we can make the argument for more money to go to the facade if the facade does more. And so I think one of the big interests in deepening the facade is if we can do more in terms of moving more of the equipment, which was in the interior of the building, to the facade, that achieves two goals for us. One, that frees up critical space on the interior, because a lot of these buildings are older. And as they adapt to new uses, things that used to normally go through the center of the building, the guts of the building, if we can free that up and move that to the facade, then that's critical space that opens up other uses. And so whether it's like data or information systems or ventilation. There's a lot of competing interests. So the more we move it to the facade, we deepen the facade to make it more efficient. We move mechanical systems to the facade. Sometimes we can move pipes to the facade, or we panelize the facade. Those are all things that are better from a long-term standpoint from operations and maintenance, because it's easier to get to. It's easier to repair. And we can kind of make that argument from a cost-benefit standpoint, that's a way to go, and that makes sense from an investment. And so I'd say that these are lots of different examples of it, but that's an easy argument for us to make.
I was actually going to put that on my wish list because I know we have a lot of vendors here, and I was thinking like, that's what I want, a second skin where you can house all those mechanical upgrades and electrification on the outside, and add insulation because like you said, it's easier, you can access them all, and also it's less disruptive to the residents. You're just giving them all of these added benefits, but on the outside. Similar to what you said, a lot of these buildings are in green spaces, so you're not up against a party wall or a landline on the sidewalk side, a lot line. So if anybody's out there and you want to
have you heard of
design it, we're ready for you.
Hydroshell is doing that. Have you
Yes.
heard of them?
Yes. Yep.
So-
Yep. So they, yes to that. I didn't want to just mention one
It's
manufacturer.
the only
but
one I know. If there's any other
yes,
contenders,
yeah.
let's hear about it.
And they're still, they're focused on the mechanical side. Like it,
Yes.
You're still providing the, the rain screen on the outside, but just an all-in shell where you're putting everything in it. It would be great.
I think, the question about the trade-offs, right? And how do we achieve a higher standard in beauty and performance and sustainability for these affordable housing projects? There's a lot of innovation we can do in the building, but I think one thing about the Sumner, the atrium at Sumner, is we innovated in the process. Where I think from the very beginning, because it was an RFP with NYCHA, the developers got together, the contractor was on board, and we had to kind of very quickly get to a solution that was actually practical and visionary at the same time. And for us, that set a stage for the commitment we made to the project for everybody, but also kind of short-circuited some of the design process that you go through with value engineering, et cetera, because we had the contractor on board already from the very beginning, talking about what was affordable and what wasn't. We also designed the envelope to passive house standards, and we knew we had ideas about the vision and the kind of support services too for the project from the very beginning. And so I think the ability to kind of set that vision at the earliest stage, commit to the things that matter, and work together to the goal. I think for us and for this project, for our office, I know the process in itself was very innovative.
That's great. We only have a few minutes left, but I do. I do want to highlight one thing on a panel of 5 people. I think we've presented in total, probably loosely about 10 projects. All of them except for one was a NYCHA project, which was not intentional. But we are in the middle of a housing crisis, and so we need to do as much as we can for as many people as we can for as long as we can when it comes to affordable housing. And I do want to say that I think and I used to work at NYCHA, so I have a bias. But for as long as NYCHA has gotten a bad rap, the fact that there is this level of both commitment, as you were saying, and willingness to engage in unique and sort of innovative projects and approaches is really fantastic. And I think it has created a partnership not only from the private side to the public side, but also within the public side, because the other project was an HPD project. And I think a lot of these things are happening because of partnership with other city agencies, which is really encouraging and makes this an amazing field to work in right now. And I think part of it is because of what you were just saying, Carla, about having that clarity of vision, because the goals are so right out in front of you in this typology. Because of that, what we refer to in our office as the tyranny of the unit count, right? That's what's driving everything. That it allows you to recognize those trade-offs a lot clearer, and on a project like Sumner, to recognize the atrium is key. Right? This is the thing. We're going to the mat for the atrium. We can pivot around everything else that's happening with this project. But going back to what I was just saying about NYCHA, Dylan, you and all your colleagues deserve a lot of credit for continuing to push on that level of innovation. So are we allowed to open the floor for questions? Okay.
I will say, though, that most designers probably would agree that these constraints can sometimes be an inspiration.
Yeah.
Right? How to solve the problem is part of the fun of the challenge.
Yeah. All right. So please join me in thanking all of our panelists. And enjoy the rest of your evening.
Thank you guys very much, Brian and team up here. Your passion for what you do is quite evident, and I think this panel wrapped up an incredible conference today, the 164th. Is that right? Did I get that right? Yes, 164th. So thank you so much. I mean, this, I think, brought me all the way back to my opening remarks, which were about building from the inside out and really influencing the built environment. So what a great way to end this conference. Thank you very much. So as we come to a close of this edition of Zak, I'd like to take a moment to thank all of you for your participation. Leaving you guys up here for a minute while I finish up and then go. And the valuable insights that were shared throughout the day. We explored cutting-edge facade technology, sustainability strategies, innovative designs that shape the future of our built environment. A special thanks to all of our speakers throughout the day. Many have left, come and gone. This end of the session, if everybody could come up, all you guys are still up here, so that's good. I think Susan wants to take one more photo. I don't know if our other speaker is still here, but if you are, come on back up. And let's take the knowledge and the connections that we gained today. We spent an entire day here, some of us. Push the boundaries of what facades can actually achieve. And I look forward to seeing you again in the future, the next conference and other ones. Susan?
I just wanted to thank Kimberly. Can we give her a big hand? You did a fantastic job keeping the energy up. So from all of us at Zak, I just wanted to thank you so much for being here. Thank you all so much for being here. I hope you had an inspiring day and some fun and some good food. And we will see you maybe in another city and certainly in New York next year. Thanks a lot.